We're going to discuss the concept of SQL injections. SQL injections are a very common type of vulnerability that exists inside of web servers and web applications. The idea is that if you have a SQL server that is typically queried, when the user queries that, if they have control over the input, they may be able to inject malicious code into that input in order to essentially be able to execute arbitrary SQL commands against your database. So to start off with, I have this login page that's vulnerable, but I want to give you a bit of an intuition behind the backend. So we have this localhost PHP myadmin setup. And inside of here, we have a users table. Inside of this user table, we have the usernames of each user as well as the passwords of each user. And again, typically when we store passwords, we would store passwords in a hashed format. However, in this case, I put them into plain text for the most part so that you can easily see what's going on and not have to sort of like work your way around like the hashing algorithms and that sort of thing. So very simply, when we query this database, if we want to check if a user exists, what we can do is we can do something like select username from users, where username equals test5, password equals 1234556. When we query this, we're going to get back the username if the user exists. If it doesn't exist, we'll get back nothing. So that's a very simple example of how we could query this database to determine if a username and password matches something inside of the database. Now, inside of our PHP code for this login page, we do essentially that. So let me go ahead and show you. So inside of here, we have a PHP and HTML sort of setup. When we post the HTML form, it comes into our PHP code. Our PHP code gets the username and password inputted from the user. It concatenates them into that query that I was showing you before, and then it queries against the database. It then checks how many rows were returned, and if the number of rows is greater than or equal to 1, it means that it matched at least one user, so it sends you to the welcome.php page. Otherwise, it will tell you that your login was invalid. So if we were going to test this, we can input something like, test5, 1, 2, 3, 4, 5, 6. That would be a valid login. It takes us to the welcome.php page. If I enter something that's invalid, you'll see it says your login or password was invalid. So that's the general sort of flow structure of this login page. The problem with SQL injections comes from this concatenation here. When we concatenate the user input into the query itself, essentially what happens here is when we execute the code, it's going to see the user input as code rather than seeing it as input. So it's going to be relatively impossible for the SQL server to distinguish between the two, so it'll execute whatever's inputted as code. So to give you an example, when we come through here, if we were to input a password that had a double quote in it, so for instance, if our password was something like this, you'll see it ends up interpreting that as code and gives me a syntax error. What I can do is I can input something like this, or 1 equals 1, and then maybe a comment at the end. What this essentially does is it closes this off and it makes it where username equals test5 and password equals blank, or 1 equals 1, and then we comment out the rest to get rid of the syntax errors. 1 equals 1 is always going to be true. So since that is the case, when we execute this query, it returns back the whole table. So this is sort of the idea of what SQL injection is doing. We're essentially inputting in something that could be interpreted as code, and that code is going to allow us to either like return the whole table or potentially do other things. It really depends on sort of the application. For login pages, typically we want to make it return a valid input, so an actual valid login or something like that. Now, one thing you might note here is that we return the whole table. When we do this query here, we check if it's greater than or equal to 1 on the count. You may be asking yourself, well, what if we set it as equal to 1? And that's a valid question, right? If we set it as equal to 1, it seems like an okay defense for this. However, we can also inject limit 1 at the end, which will limit the outputs to just give us one result back. So it's not necessarily a good solution to just say, well, what if we just limit the input to 1 instead? We can easily write code to do that. So to show you this in action, if I type in like test, for instance, test5, we'll do the same user. As I said before, I want to input a single quote and then or 1 equals 1 and then a hashtag. So recall essentially what we're doing is we're closing this off to make it or password is blank. And then we're saying or 1 equals 1 and then we're putting that hashtag in. We'll forget about this limit portion here. Just keep it simple. We put in the hashtag, which comments out that last single quote that's left, which will make it so that the syntax is now valid. And now when we submit this, you'll see it authenticates us. So as you can see from this, I gave a totally invalid password, however, I still got access to the login page. So this is an authentication error. It allows us to authenticate to our web page without actually having valid credentials, which is a huge problem. Now, it's not the only place where this shows up, of course, and it's not always just explicit user input that allows for SQL injection. User input is just one of the attack vectors, but there's a lot of other places where it could potentially happen, and I'll talk about a few of those now. One other common place where SQL injection can happen is when we take server variables from the user. One good example of this is sometimes when a user visits your site, you can find their IP address using PHP. There's a possibility that the user could alter pieces of information that they're representing themselves as. I don't think IP address is one that you can really alter, but if you can look at things like host name or that sort of idea, the referrer, that sort of thing, if you put that sort of data into a database, for instance, you may accept it regardless of the format and concatenate it on. If the attacker is able to alter where they're coming from, for instance, like the referrer is a pretty good example. If they're able to alter the referrer to put in a malicious payload like this, they could potentially expose data from your database or cause it to do something bad, like insert a user, for instance, or drop tables, depending on the permission set of the querying agent, right? So this would be an example of another way that you could attack a server using that. Another common one is cookies. When you authenticate with a web page, you're typically given back a cookie, or if they're trying to track data from you, they'll give you a cookie. There's a lot of different instances where you get a cookie. And that stores a lot of different information inside of it. It's also controlled by the user. So the user could do things like modifying that cookie to be able to change the data of it. And again, they can change the data to something malicious like these SQL injection commands and manage to leak the database completely, right? So that's another example of an instance where we can do that. The final one that I'll talk about is ones that essentially happen on second order, is what it's referred to as second order SQL injection. And these are instances where suppose I put my username as something that's invalid, like this SQL syntax. It might not inject immediately, but maybe that username gets used somewhere else, and that place where it gets used is vulnerable to SQL injection from the programmers like trusting their own data over the data provided from the user. So you have to be very careful about how we accept data from users. If anything is under the control of user, things like file names, cookies, server variables, anything like that, we need to sanitize that data to make sure that the person isn't able to put malicious data inside of it. Any instance where you can put in malicious data is going to be an instance where you can have a SQL injection occurring. Now, to discuss a little bit about the types of attacks, we've discussed one type of attack here, which is this or 1 equals 1. It's typically referred to as a tautology. A tautology is a statement that always evaluates to true. These are really good for leaking data from databases that we shouldn't be able to see or forcing authentication and that sort of deal. There's one other type that's relatively common, which is referred to as a piggybacking query. With a piggyback query, what we do is we actually utilize unions. So, as an example here, when we set password equal to blank, we can also come over here and union it. So we could say union and then union another table. The only condition being that the number of fields has to match. So if you have something that returns back data from a database, for instance, and has 3 fields that it returns back, what you could do is you can union a different table. So for instance, in MySQL, there are a whole bunch of tables that store information like the tables that exist inside of a database, that sort of idea. So we can query that table with a union and be able to return that information. And then once we have that information, we can find more valuable tables like login tables, and then we can leak those types of tables as well. So this is known as piggybacking. You'll see this fairly often in a lot of different applications. One that is sort of like near and dear to me is content providers through Android. If you're not familiar with Android, essentially applications can export things called content providers. And what these are is they're special types of listeners that essentially allow people to query data from your application and it returns the data back to them. In these sort of situations, the user is able to control the projection, which is the fields that are inserted in, as well as the where clause. So they can do piggybacking queries fairly easily. And essentially what happens is you can piggyback on a union of all of the tables in the SQL database, and it will return it back to you because it doesn't really control what data is returned back. And that's one way that we can leak data through, say, content providers, for instance. And there are ways to protect yourself against those, of course, and we'll discuss some mitigation strategies that are relatively generic to any language. I'll show you examples of them, but that's just one example that I've typically seen that is typically not thought about, because a lot of the times people don't understand exactly what users are able to do when they query your databases. In these cases, we always want to make sure that we sanitize user data. We always trust to set the user data as malicious. We don't trust user data. We always assume it's malicious and sanitize it properly, right? So let's discuss a bit about mitigations of these types of attacks. From now, you understand how an attacker can pull this off. So we'll discuss a few common mitigations and discuss sort of the pros and cons. One of the ones that I see very commonly is doing MySQL iEscape character. So you'll see here in the PHP code, I've added these MySQL iEscape character or escape strings. What these do is they escape SQL code. So if you put in like single quotes or that sort of things, it adds in escape characters so that they aren't interpreted as code, but rather as text. These are really great for situations where you have fields that require single quotes in order to close them. However, I want to demonstrate to you that this is not always a good solution. What I've got here is I've got an alternative version of our login form where we have the username and then we have the PIN as a password. Think of this like a bank PIN. If your bank accepts like a numeric input for the bank PIN, then you could have potentially a situation where you have an input for the password that doesn't have quotes in it, right? So you'll see here, if I go ahead and do like some SQL code, if I were to say where PIN equals 1234, you'll see when we execute this, we get back the PIN that's equal to 1234. We don't have to put the single quotes around it. It's not required to do that. So since this is the case, there's nothing that really can get escaped from this. So for me to demonstrate this, let's go ahead and go to this other page here. So we'll say login, what did I call it here? Login escape. And we'll go to give this a try. So again, if we do something like test 1234, that's a valid input. It lets us through to the welcome page. Now, if I do something like or 1 equals 1, you see how I put in like the closing quote there? This won't authenticate properly. You can ignore this error. That's just from me not properly sanitizing to make sure that the query is actually successful before I try to extract data from it. In a properly designed web application, you wouldn't have that error. But you can see next to that, the login is set as invalid, which is what we want to happen. However, I want you to realize if we don't put in the single quotes, we still get a valid SQL injection. We can say equals 1 or 1 equals 1, right? This input has no SQL characters in it. There's no special characters inside of this. It's literally just text. However, it's also a valid SQL injection. As you can see here, it authenticates us to the welcome.php page. So this is a word of warning. If the last thing in your where statement is numeric and it has no quotations associated with it, someone will be able to exploit it even if you escape the SQL characters. So really keep this in mind. A lot of people use that as a generic solution that always works. It does not always work. There are situations where that does not work, so you need to be aware of them and work with better types of mitigations. And the better types of mitigations are what are known as prepared statements. With prepared statements, what we do is we set up a statement to prepare a SQL query. When we prepared the SQL query, we put in question marks for the username and password. So we put question marks for the inputs, and then we bind the parameters to those inputs. So we say there's going to be 2 strings. Here's the first string, here's the second. What happens is when we go to query the database, it's going to take this username and it's going to place it in turn of this question mark. It's going to take this password, it's going to place it in turn of this question mark. And it's basically just going to replace the question marks with actual parameters. Why this works is because when we do a prepared statement with binded parameters, it ensures that it treats the inputs as inputs. It does not treat them as code. That's the key point here. We don't treat the inputs given from the user as code, so we're able to sanitize it using this type of prepared statement. This is the correct way to protect yourself from SQL injections. There's nothing wrong with also using like escape characters with prepared statements, but you should always use prepared statements if you're working with SQL queries. Just in general, anytime you're working with a SQL query, I would use a prepared statement. There's no reason to be concatenating user inputs to SQL queries, so don't ever do it. Just use prepared statements and you'll be totally fine. especially if you're getting data from the database. If you're getting data from anywhere, really just use these statements because you never know where an attacker might be able to get data into your database. They might be able to exploit it pretty badly with these sort of vulnerabilities. So this would be the main mitigation that we would want to work with. And in essentially every single different programming languages, there's a different way to prepare statements through the SQL libraries and such. So you just need to determine which one works for you. This is the PHP version. There's also another one in PHP called PDO. So there's really not much difference between PDO and using MySQLi. Again, it's really just up to preference of which one you like to use. When I was discussing the idea of content providers, there's one final thing that I want to discuss with this, and it's instances where you might be able to get input into the fields of the select statement. This is, again, not a particularly uncommon situation to happen. It happens with content providers I know quite frequently. I don't know about other types of SQL queries. There could be instances where you could like select what kind of fields you want to put into a report, and that gets put into the select statement, right? What I want you to be aware of is, so if we say like username, for instance, the user can put in whatever fields they want. What they can do is they could do something like this. If they put in fields, they can say select is already there, and then the fields could be something like they could select username, password from users, right? Users is a different table. And then what they do is they just put a comment at the end of it. And what this does is it essentially creates a new select statement. So this is something you also have to be careful of. If you allow input into the fields, like in content providers in Android, you need to be aware that people can insert in any sort of SQL queries in there. They can put comments at the end of it, and they'll end up getting a perfectly valid SQL statement and manage to do an injection. The way that you get around this sort of thing is you check the user input to determine if the column that they are trying to access is actually a column inside of the database. If it's not a column in the database, we don't execute. We just say, hey, that column doesn't exist. If it is a column in the database, then we do execute and everyone is happy. So that's the main way to prevent against this. So all of this should give you a really good intuition behind how SQL injections work, generally where they're typically located, what kind of attacks are typically common with them, and how to mitigate the attacks. So it's a good idea to go through your applications, make sure you're using the proper prepared statements, and try some of these exploits to see if they break your application. And if they do, make sure to patch up those problems because SQL injections are quite bad vulnerabilities. So this should help you out with getting that secured in any sort of web application that you have. We're going to take a look at the idea of command injections, which is essentially a way of being able to inject code into a web application. And it's relatively similar to other types of injection type vulnerabilities, things like SQL injections and that sort of thing. The general idea of it is the same, that we're going to input something that gets interpreted as code, or in this case as a command, and then it will execute against the server. And the idea is that by doing this, we're able to execute any system command against the server with the same privileges of the user that runs the web application, which means that we can either expose information about the server or potentially upload things to the server or get reverse shells. And typically reverse shell would be the goal of doing an attack like this. So what I'm going to do is I'm going to go over the basics of how this sort of attack works and give you a general idea of what exactly you're able to do with it. So just for a little bit of context, I have this this Linux virtual machine that's running, and this is what I'm using as my server. So when I log on to this, essentially I've got like this index.php file. It's a rather simple file. Let's go ahead and cat it. Essentially, what it does is when we get a post request, it takes in the IP that's provided, and then it's going to go ahead and it's going to execute the shell command to ping the IP that's provided twice, and then it will echo out the output from that. So the idea is if we can insert something into this ping command to get it to execute along with the ping, so to do the ping and then sort of do something else, that would be the way that we would be able to get a command injection to actually happen. So to understand exactly what's going to happen, you should understand a little bit about how Linux handles commands, right? So when we run the ping command, so if I do like ping -c to of my local IP, for instance, -c is count, so it'll say that it will ping the IP twice. So you see it pings twice, and then it gives you sort of like a summary of the actual ping itself. Using a lot of different methods, we can actually concatenate commands together so that they run like 2 at a time. So one of those in Linux is a semicolon. A semicolon essentially tells it, okay, there's the first command, and then here's a second command. And we could do something like cat etc/password is a typical one that you would do. What this will do is it will expose the content of the password file, which contains all the users that are on the system. So you see when this happens, it will do the ping, and then it does the second command afterwards, which would be exposing the contents of that password file. So this is one way that we are able to concatenate commands together. And there's a few different ways that we can do this. And they're all just different characters that separate. So another one that we have is these 2 ampersands, and it gives you a similar sort of output. It's equivalent of doing essentially an AND. So with the first one, we were saying like run the first command and then run the second command. This one we're saying run the first command and also run the second command. So this will allow us to concatenate the commands together as well. This one is particularly helpful if they happen to censor the semicolon parameter. For instance, like if you enter in an IP, it's typically like a numeric value with periods only. So if you were to try to protect from this, you could do a regular expression to take in only digits that have like periods or that sort of thing. And in some cases, you might be able to sort of sneak some other characters in using like the ampersands or some of the other characters that we'll go over here. So understanding different types of ways to concatenate commands together is beneficial to be able to attack different systems. So those ampersands is a very common one. The single pipe is one that's very common as well. With this one, this is the pipe command. So what it does is it takes the input from one command and uses it for the next command that follows. So it takes the result of the ping and uses that as the input for cat. Cat doesn't take any sort of input, so that just outputs everything to the screen. And then the final one is OR, which is 2 pipes. This one is a little bit more tricky. You'll see if I do it normally, it just pings the server and it doesn't execute our second command. The reason that this happens is because the OR command will only execute the second command if the first command fails. So if we put in like a letter, for instance, the first command fails, so the second command executes. So those are the 4 common types of ways of concatenating commands together. So when you're taking a look at the input from the server, we have control over the IP address, and we can write in a command that will have an IP address that's valid, and then we can write in one of those special characters and then the next command that we want to execute. So for instance, I could do that same sort of idea, and then we could do cat etc password. So you can see here that we essentially give it that same input. We give it the IP and then a semicolon, and then we give it the next command. When we execute this, you'll see it does the result of the ping, and then it also cats the password file. So you can see that this allows us to expose the data. And just to show to you that all of them will work in this case, we can do, for instance, the 2 ampersands. So that will work, for instance. And we could do it with all of them, right? So we can do it with the pipes, we can do it with the OR command. So all of those will work for this sort of instance. So you can see that each of these commands will allow a command execution to be completed. Now, as I was saying before, we want to know those different types of characters that work because they may be trying to filter specific ones out. In reality, if you're running a system command from a web application, it's actually very hard to actually adequately filter out all of the different types of injections that can happen. So typically, like the guidance on this is to try not to use system commands whenever possible. If a server has a system command like this sort of like ping feature, for instance, it tends to be relatively easy to be able to find something that will allow us to execute an arbitrary command. And again, just by trying those different types of parameters is how you're going to be able to find those pieces of information. Now, there are a few other things to keep in mind here. If the server is running on Windows, you have to slightly modify the payload a bit. So for instance, if you're on a Windows computer and you're using your command line, you see ls doesn't work, right? But dir does, for instance. So there's a different set of commands for Windows versus Linux. So you have to be sort of aware of that. As well with Windows, some of the different commands won't work. So I don't think the semicolon one works, but typically like the two ampersands together is a really good one because it works on both systems. So that's another thing to just sort of keep in mind with that if you're working with a Windows server, you have to use slightly different commands. And the slightly different command is going to be using the ampersands. And then like, I'm not sure about actually catting files. There are other commands, of course, that you can try, like things like dir, for instance, will expose the directory if it works. As long as you get one of these to work, then you can just sort of like look up whatever command you want afterwards, right? So a lot of the times people will be like, how can I get a reverse shell out of something like this? And the answer is you really just have to like run like a shell command or something like that. Or you can utilize this to expose the like hashed passwords and then do like an offline password attack to be able to brute force the passwords. But yeah, for instance, like if you're able to get things like shell or something like that, or you could potentially like install malware through it to give you that reverse shell. So the ability to do that is relatively endless, right? You could do really whatever you want out of this. As long as you have access to the command injection, you can literally inject any sort of command in. So this vulnerability is extremely critical. If it ever exists on a server, it's typically scored at a CVSS 10 out of 10. It's extremely critical because if someone is able to execute commands on your system, they can do literally anything, assuming that they have the proper permissions, right? But from being on the server and being able to execute commands, you can easily escalate permissions, either through compromising one of the files through catting like the password or shadow files, or by uploading a piece of malware or some payload to it. If you want a little bit more detail on uploading payloads as well, I can give a little bit of insight on this too. The idea with this is going to be when we have essentially like this ability to run commands on the server. One of the things that we would be able to do is create a user. For instance, we could do like user add to add a user onto the server. And what you can do is you can add a user to the server who you could then like use something like win SCP to like SSH into, or to FTP into, or SFTP into, or whatever you really want to do. In addition, you can also like enable FTP, or you can enable SSH. And then using that, you can essentially go onto the server and upload whatever you want onto it. And then using this command injection, you can sort of navigate to where you want to go and execute your payload from there. In addition, you could also like upload like PHP files or HTML files, or really anything that you really want to be able to do that. So a lot of time like website defacement can be done using this just by uploading different files or modifying different files. So the possibilities with this sort of attack are really large, right? You could do a lot of things with this, but this gives you the general idea of how to sort of prove that a command injection exists, and so the different ways that you can do that on a system that isn't doing any sort of filtering or anything like that. So using this, you should be able to, if you have like an input where you have control over a command, you should be able to try out some different inputs to determine if that system is vulnerable to this sort of attack or not. Broken authentication is the second most common type of vulnerability that's found in applications right now, according to the OWASP top 10 list. It's a type of vulnerability that essentially revolves around the way that we authenticate users, whether it be through username and password, or different methodologies like biometrics and secure tokens, or that sort of idea. And it's essentially flaws in those systems that allow an attacker to be able to gain authentication without being an actual authorized user. So in this video, I'll go over a few different types of broken authentication type attacks and discuss a little bit about how these sort of attacks are mitigated. So again, we're looking at issues that are really dealing with being weak or improperly implemented authentication. And authentication is really one of the key aspects of most applications, which is why it's so frequently targeted. If you have weak authentication, people can gain access to your system, and through access to your system, they can do a lot of worse things based on that. So any breaks in authentication would be considered critical issues and things that would need to be fixed really relatively quickly. So the first type of attack that we'll talk about is credential stuffing attacks. The idea of these types of attacks is that when there's a data breach from some website of some sort, that information is typically leaked somewhere online. And a lot of the time people can get access to those databases to be able to get lists of usernames and passwords, for instance. With a username and password list, someone can go to different web pages and try that same username and password against that web page to determine if the authentication works there too. This would be the idea of a credential stuffing attack. We have a list of usernames and passwords, typically compromised credentials from breaches, and we use a bot to automate this process of attempting to log in with those credentials. This type of attack has around a 0.1% success rate, which sounds very low. However, it's very easy to automate, which means that it can easily be implemented, easily set up to attack a system, and it will have some amount of success that will probably be able to get you at least one set of credentials, which a lot of the time is all you really need. The next type of attack is relatively similar to that, and it's related to brute forcing passwords and as well the general idea of weak authentication with weak passwords. Brute forcing is slightly different from the idea of credential stuffing. With brute forcing, we're attempting different combinations of letters and numbers and symbols to try to guess easily guessable passwords. And essentially, the idea is that we want to throw as much computation power as we can towards brute forcing these passwords to attempt to compromise the user account to gain access to the system. Now, the ability to do this is actually fairly easy. If someone's using just letters and numbers, for instance, a 6-character password can be cracked in about 3 hours with like a standard laptop. So essentially, the longer and more complex the password is, the less probability there is of being able to brute force it. However, in general, brute force attack tends to be a very effective attack if someone doesn't limit login attempts, because odds are there's going to be at least one person on your system who is going to have a weak password if you aren't enforcing a proper password policy. And if that is the case, then they'll be able to crack it relatively easily utilizing brute force attacks. So the next thing we'll talk about is weak credential recovery. This is one that we see actually fairly frequently. If a user ever forgets their password, they need to be able to recover it. However, the person who implements this system also needs to be able to verify who is trying to recover the password, because if someone who isn't the right person comes in and recovers the password, then they will be able to get access to the account without actually having to know the password, right? They can just recover it and then change it. So there's a few different aspects to this one. Most commonly, things like recovery questions are the easiest way to have a weak credential recovery type of attack. If you ask someone recovery questions, it's typically very easy to find the answers to them. There have been famous attacks that have happened with celebrities where people go to like interviews or Q&As and they ask their recovery questions, and then they answer those questions on the webpage and compromise their account through that. So a lot of the times this information is easily gathered through social media. There's a lot of information out there now. So asking recovery questions is a very bad idea for recovering passwords. Typically, the way that we do this now would be using two-factor authentication, an alternative email that you can email the credentials to, or like a phone number that you can verify from. So we use something that we know is going to be in your possession, or we hope is going to be in your possession. And speaking of two-factor authentication, missing multi-factor authentication is now becoming a big issue with compromising authentication. So multi-factor authentication helps add another layer of security. If you try to log in with a password, then we can ask you for some form of two-factor authentication, say like a verification code from your phone or from another email, maybe a fingerprint or something like that. And the idea is that it makes it much harder for an attacker to be able to authenticate as a user using multiple factors. So ideally, we'd be utilizing something like a phone to be able to do this, because oftentimes the only person who has possession of your phone and phone number would be you. Now, there are ways to be able to attack this. You may have seen recently in the news, people have been calling into customer service desks, pretending to be somebody and stealing their SIM card and therefore their phone number, and then being able to compromise it from there. So there are weaknesses to that sort of idea. In addition, sometimes people accidentally just like authenticate thinking that they were authenticating at the same time. Timing can play a really big role in that as well. So there are some flaws with multi-factor authentication, but as a general sort of sweeping statement, it is typically better than just username and password. It makes brute forcing and credential stuffing much harder if you have that multi-factor authentication available. So another thing that we can talk about is things like session IDs. A session ID is typically a way of authenticating a user throughout their session with the web page. If a session ID is exposed through something like the URL, for instance, like if it's written into the actual URL itself, or if it's exposed in a cookie, or it's leaked in some other way, an attacker could potentially gain access to it and be able to authenticate as the user using that exposed session ID. So ideally, session IDs should be properly handled in a way that is server-side only. That way, it's very hard for an attacker to be able to gain access to session IDs or any sensitive information that can be used to verify a user's identity. So to summarize, we can talk about how we can prevent these authentication issues. The main way to do this primarily is going to be to implement some form of multi-factor authentication. This will significantly help your ability to have a secure system, and different levels of multi-factor authentication are adequate for different systems. Perhaps a password and a phone authentication is fine for some systems. Some systems might prefer like a biometric authentication with a password if it's more secure. So those would be really good setups to be able to help with authentication issues. Things like using a password policy to prevent weak logins, right? Someone puts in like 1, 2, 3, 4, 5, 6. We shouldn't be accepting that as a password. So this would be a good way to prevent that. Not shipping with default credentials is another great way. If you set up, say, like some form of like CMS or something like that, and it has a default like admin login, that's just like admin, right? That could be exploited very easily for someone to just try default credentials on a whole list of sites running that specific software. So you want to make sure that you don't have those default credentials in your applications. Another big one is going to be to limit failed login attempts. So brute forcing relies on the fact that you are able to attempt to log in more than like 5 times, for instance. So if we limit invalid login attempts to 5 attempts and then lock the account, we're going to be able to prevent those brute force type of attacks. Now, this also is going to cause some issues for the user, because if someone tries to brute force them, their account will be locked, and then they'll have to potentially like call in to ask for the account to be unlocked, or they might have to wait a certain amount of time for it to get unlocked. So these sort of things are valuable, but more valuable is having a really good password policy that keeps their login secure. Combining the two together is great, but just keep in mind that limiting numbers of login attempts can be detrimental to the user as well. The final thing as well, as we discussed, is keeping session IDs on the server side. That way we aren't able to leak it to the client, which makes it easier for us to be able to store session IDs without worrying about people getting access to them. So this gives you a good idea of the different types of authentication issues that might exist in a system. Utilizing this information, you should be able to take a look at a system and determine whether they have any sort of authentication issues, and be able to suggest ways to patch those problems to ensure that your authentication is as secure as possible. I wanted to discuss a bit about the idea of sensitive information disclosures, or in general, just information disclosures. And these are situations where in an application or server or some sort of, thing that exists on the internet, we're able to disclose information from that service that tell us either sensitive details about a user, for instance, or sensitive data about a session, or sensitive data about the web application itself, or give us more information that we can expand our attack surface. So this is a really big step in not only information gathering, but actually exploiting systems in general. So I'm going to show you a few different examples, and I'm going to talk about a few different examples as well to give you a bit of a feel of what exactly happens with information disclosures and why they're a bad thing. Now, there's a huge variety of different types of information disclosures, and I'll try to talk through a couple of examples of each of the ones that I'm most familiar with, and that should hopefully give you a good idea of ones that are common sort of in the current environment or systems that exist. So to start off with, one of the most common types of information disclosure is error messages that are displayed to the user. In general, when we have error messages, we should try to make sure that they are error messages that are controlled by us. So the way that we do this is using try-catch statements with custom messages that output information that is descriptive enough for the user to understand what happened, but not so descriptive as to reveal information to the user. To give you an example of this, I have a login page here, and when I input like a username and password, it would say your username or login is invalid. This would be a great example of a proper error message because it doesn't expose any real information. Now, if it exposed something by saying like the login doesn't exist, this would be an example of a very simple information disclosure. What that tells the attacker is it tells the attacker that the login that they're trying to attack isn't one that exists on the system, so then they can try a different login. They know it's not the password, it's just the login or username. Now, when we keep it more vague, it tells them one of the things that they entered was wrong, which means that they can't sort of understand if the user exists or not. So this is an example of something that could potentially have an information disclosure. We have to be very careful about error messages. Even further, If we leak an error message, for instance, this one has a SQL injection available in it. So if I put a single quote, for instance, you'll see we get this PHP warning outputted to the screen. When this happens, it's a problem for a lot of different reasons. First off, it exposes information about the SQL function that I'm using for the login. It exposes the location of the actual file, like the full server path. Exposes a little bit of information about the location of this error itself. And as well, it exposes the fact that we have an error in the SQL query, which in turn tells us that a SQL injection is likely possible here. So this sort of information disclosure tells us information about the system in terms of how it's handling the SQL queries. In this instance here, it's telling us how we can attack the server in a little bit more detail, because now we know the single quote caused an error in the SQL handling, which in turn tells me that it's interpreting it as code, which in turn tells me that I can create a SQL injection type of scenario with it. So this is another good example of sort of an error message type of information disclosure. Now, there are other types of information disclosures that are very common. One actually comes with Apache, and it's one of the sort of defaults of Apache or XAMPP or those sort of server setups. What you'll notice is that if I put in something that doesn't exist, I get this typical 404 error page. Now, this looks quite innocent because it just sort of says object not found. But if you're paying attention, you'll notice that it exposes this server, the version of the server, the operating system type, the version of my OpenSSL, as well as the version of my PHP. And you may be thinking, well, that doesn't really seem like that big of a deal. However, we can easily now take this information and look up CVEs for that version. And from a site like CVE Details, you'll be able to see, okay, in 2019, there were all of these vulnerabilities that work for this specific version of Apache. So from here, I can just pick one that I want. So for instance, this here, I could try using to attack the system because I know the version of the system itself. So once I know the version, I can easily find attacks that could potentially work against that version number. So exposing the version number is extremely dangerous because it allows the attacker to know what they should be attacking. It tells them the version number, which is easy to sort of find these different CVEs for. So this is another example of an information disclosure. To solve this sort of problem, we can have like custom 404 error messages, and you can do that through like the configuration of the Apache server itself, and that's typically the preferred way to handle that rather than using these default ones. Now, one other common one that comes up is access to log files or configuration files that have sensitive information. You'll actually see this a lot. There's a lot of methods such as like Google Dorking, for instance, where you can look up configuration files or log files. And oftentimes you can find ones that don't have the proper permissions on them that may expose a username or password or cookie or some piece of information that is important to keep anonymous or secure. An example that I have here is, so if I go to my localhost directory, I'm able to traverse my directory here, and you'll see that I have this conf folder, and then I created this config.txt, and you can see it has all the information about my username and password and database. So these types of configuration files can exist on your system. However, they shouldn't be accessible by an outside user. Otherwise, they're able to potentially find these and be able to disclose information about the actual system itself. So we want to make sure that any configuration files or logs are not readable by the users if they don't have to be. If they are readable by the users, they should not contain any sensitive information. This sort of information you see a lot. One of the most common places where you see this is if you, say, run an installer for an application itself. Sometimes that installer will have like an install log, and inside of that install log, sometimes they might be like database initialized with these parameters, and they might accidentally put the password in it, for instance. And that just means if someone breaks onto the computer, they can easily find that installation log and they can get all that detail from you. So we want to make sure that that sort of information isn't being exposed in our logs or configuration files. So then the other type of information disclosure that's very common and very dangerous is about like plain text transmissions and plain text storages of sensitive information. So as an example with this login page, you'll notice that we don't use HTTPS for it, of course. So if we use HTTPS, what happens is we create a secure socket between the server and the client. So it means that all the data transmitted between them will have encryption enabled on them, meaning that if someone sits in the middle of the two connections, they won't see any plain text information. They'll see encrypted packets, and we'll have to figure out how to decrypt those packets to get any valuable information. However, if we submit without HTTPS, which for this example we would be doing, when we send the packet from the client to the server, it would send in plain text, which means that the username and password would be exposed. In addition to this, when we send the password, in this case, I'm not sending the password with any sort of encryption or hashing applied to it. I would apply the hashing maybe server side. And in that case, when it's transmitted in plain text, which is another dangerous thing to be doing. We don't want to ever transmit our passwords in plain text if we can help it. And speaking on the half of hashing passwords, passwords in databases should always be hashed, specifically with a salt as well. And the reason for this is because if the database ever gets compromised, they will only have the salted hashes of the passwords rather than having the passwords themselves, which means that they have to crack the passwords. And this makes it more complicated for the attacker to actually get that information because they'll have to do like brute force attacks or dictionary attacks. Hopefully dictionary attacks wouldn't work because you would have a random salt, but brute force attacks essentially would potentially work if the users pick weak passwords. So with a good password policy and hashing on the password, it becomes rather hard for an attacker to be able to expose that data. Now, there are things other than passwords that are important. Unique identifiers like, I don't know, driver's license numbers or SIN numbers, bank details, that sort of information can often be compromised. So we want to make sure that that information is sort of redacted or hidden in our database. So typically we'll obscure it in some sort of way, or we'll hash it or do something with it in order to allow us to not be able to store that just in plain text. So we want to be able to adequately protect that data as well. Now, speaking of sensitive data storage, another piece is when we have sensitive data inside of source code. Now, a lot of people think that, for instance, if you write like a Java application and you compile it, we think, well, nobody's going to be able to see the source code now because we've compiled it. There exists a lot of decompilers and reverse engineering programs that allow you to decompile code and turn it back into source code to read it. If we have passwords and usernames in plain text in that code, then somebody can just decode your binary just through like decompiling, and then they can just browse through it and search for the password. You'll actually see this very often with sort of like amateur keyloggers or that sort of thing. When people put up like those scam things for like games like, for instance, Fortnite, where they'll put up like a thing that will like generate the currency of the game, and you just type in your username and password and you click OK, and then it, you know, gives you free money or something like that. With those sort of programs, you can often decompile them, and those people will put the email that it sends those credentials to in plain text, so you can actually see that information. So that's something that's very common, and you see it a lot, especially with people who aren't particularly skilled with programming. They often put their passwords in plain text in their source code because they think no one can get back to the source code once it's compiled, but they can. So keep that in mind. In addition, like even with PHP files, when we talked about like the ghost cat vulnerability, for instance, the ghost cat vulnerability allowed you to pull pages from an Apache server that were anything, right? So you could pull the PHP code and then in turn expose like configuration data and potentially expose username and passwords as well. So that's another thing that you want to look out for. Ideally, what you should be doing is having the person put in a password whenever they have to authenticate to a service, or it should be stored in maybe a third-party sort of way, or using some form of encryption, perhaps. There's a lot of different methods that you could do. I think typically what a lot of people do is they will encrypt the password, and then they'll store the key for that inside of the key store of the computer. And then whenever they need to access it, they use the key from the key store to decrypt the password, and then use that password to authenticate to the database or whatever they're authenticating to. I think that would typically be it. You also see things like API keys becoming more and more common, because if those get leaked, you can just revoke the API key and it's not as big of a deal. But there's a lot of different alternatives next to just using a password in plain text, so you just want to consider those as well. Now, there are a few other small ones that I'll discuss here briefly just to give you a few more ideas of sensitive data disclosures. Things like timing-based attacks are actually common. Sometimes when you log in with a username and password, when you log in with an invalid username, it manages to check it faster than if you log in with a valid username. If you ever see something like that happening, you can actually time it and determine if a user exists based on how long it takes to authenticate. The reason being is because they might do like a query to begin with to check if the username exists and then check the password only if the username exists. So you skip that second step, which means that the process completes faster, which means that you could do timing-based attacks. Another one that's become fairly relevant, especially right now, is revealing chain of command through email auto replies. So this one's a very different one from the ones that we've discussed so far. When people are out of office, they'll typically put an auto reply on their email. It'll say something like, I'm out of office right now. Please contact this person if you need something urgently. And what that essentially exposes to the attacker is now they see that somebody is covering for you or someone is your superior. So then they can go to that person and be like, hi, I was talking with, this person and they were going to give me this information. I'm wondering if you can help me with that. Since the other person's out of office, the other person's covering for them, it's a bit easier potentially to get that information out of the person who's covering because they won't necessarily know that context. So you have to be very careful about the information that you're showing people. The final thing that I'll talk about here as well is the more classic versions of information disclosure, and those are being able to get access to data that you shouldn't be able to get access to. The most classic version of this is like SQL injections. If you can do a SQL injection, you can typically query other tables to get information, and when you can query other tables, you can disclose information that you shouldn't have been able to see before. So that's sort of like the classic information disclosure that allows you to grab information from another table. So to sort of summarize this, when we have any sort of information that is being provided by our application, we need to be very careful about it. If you ever have an instance where your application could potentially error, you should make sure, for one, that the default behavior is not used, that you are controlling every error message, and for two, that you're catching every error that could potentially happen and printing a message that is not the stack trace. Something that is written by you that does not expose any information about the application itself. Same goes for things like the Apache 404 page, for instance. Any of those responses, you should try to make them customized to your application so that they don't accidentally expose something that's of value. So that's something very important to note about those. In general, good programming practice of not having SQL injections, command injections, XXE, XSS, getting rid of those vulnerabilities so that we can't disclose information, making sure that you aren't revealing information through email auto replies or external facing processes. And that's the general idea of sensitive information disclosures. So it's always good to be careful of the information that you're displaying to people. If ever you need to print something to the screen or show the user something, you need to make sure that you are being careful of what you display. That's essentially the main theme here. So using these sort of ideas, you'll be able to better secure your application to hide information from the users and thus prevent attackers from being able to expand their attack surface or potentially compromise your applications. In this video, we're going to take a look at XXE-based vulnerabilities, which means XML external entities. These type of exploits are associated with being able to parse XML data in a way that allows you to leak information from the server primarily, is what they do. So the way I'm going to demonstrate this is through Portswigger's labs. They have a number of different labs that are available for XXE, and they're very good for being able to practice the sort of foundations of these skills and to be able to sort of demonstrate all the different scenarios that you may see XXE become available in. So I'm going to approach these from the perspective of showing you how you can identify these sorts of vulnerabilities and then how you can exploit them. And then we'll talk a little bit about how we can fix them and make sure that these problems aren't present in our software. So before I start, I'm going to give you a little bit of an introduction towards the tools that we're going to be using for this. There's one tool primarily, which is also made by Portswigger. It's known as the Burp Suite. There's a community edition and a professional edition. I'm utilizing the community edition. Essentially, this will allow us to capture traffic between ourselves and the web page. What that allows us to do is that every time we send a request to this web page, we're able to see what data is sent between us, which will allow us to sort of manipulate the data and inject things into it, which will allow us to be able to exploit these XXE-based vulnerabilities easier. So we're going to go through a few different scenarios. The first one that we're going to take a look at is exploiting XXE using external entities to retrieve files. The idea of this sort of problem is that when we use XML data, if a user is sending XML data to the server and they have full control over that XML data, what they can do is they can write in these things called external entities. And what external entities can do is they can reference files anywhere, really. So they can mainly reference files that are actually on the server itself. And through this, they're able to get back data from the server using this XML request. So this is something that obviously we don't want to happen. And this one, we're going to demonstrate how to get the password file from a Linux server, essentially. So what we'll do is go ahead and access the lab here. Just to note, as we're getting on here, in order to access these labs, you will need an account. It's a free account to register, so you can go ahead and register one for that. You'll see this essentially has just like a shop, and we can go into this shop and we can view details. And when we go to view details, we can check the stock of items. And when we do that, it will tell us how many units are in stock in the specific store that we look at. So obviously from here, we can tell that there's some sort of query happening in the background. And from that, we know that we're basically going to have to pass this information from our client to the server. Anytime that we're passing information from the client to the server, there's a potential to be able to inject malicious content into the actual web application itself. So to be able to see this in action, we're going to launch up Burp Suite, and we're going to do that ourselves here. So let me just go ahead and reset here. The way that this sets up, if you've never used Burp Suite before, I'm on Firefox. In this case, it's my preferred browser. If I go into options, I can type in proxy. And inside of the proxy settings here, we just have to set up a proxy configuration to the proxy that's set up on Burp Suite. So you'll be able to see that in general here. So you'll see proxy service started on 127.0.0.1, port 8080. We just put that information into here as well. And I just match it through everything and press OK. Once that's done, we'll now be able to intercept data. So we'll specifically go into our proxy section here and turn on the intercept. Now we'll be intercepting the web traffic between us and the web pages that we're accessing. So as discussed, we can come in here and we can check stock. When I click check stock, you'll see it will sort of pause. And inside of here, Burp Suite will show me the data that's being sent to the server here. So I can forward each packet and go through them one at a time and just see what kind of data is being sent through. So let's go ahead and switch it to say London, and we'll say check stock. And as you can see, it shows us the general packets that are flowing through. Now, for some reason, some of them work, some of them don't. So you sort of have to play around with it a little bit. In some instances, you might get these certification invalid things. Essentially, when you work with Burp Suite, it injects a certification between you and the server. So it will tell you that the certificate is invalid. You can just accept that and continue. So we'll go ahead and try this one here, for instance, and see if this one will work. So I'm going to turn the interceptor on, and let's say check stock. As you can see here, you can see the general payload that's being sent. You can see that it's sending this XML data to the server. And inside of this XML data, we have the product ID and the store ID. What I'm going to do is I'm going to go to action, and I'm going to send this to the repeater. The repeater essentially allows us to modify the content of the query itself and be able to send it back to the server so that we can try different things with it. So with that being done, I'll go ahead and turn off the interception for the proxy, and let's head over to the repeater. So you see, here's the general format of our XML. If we want to do an external entity attack, there's two main things that we're going to have to do here. The first is up here, we're going to have to define our external entity that we're trying to access. So we'll do this as follows. Say doc type. I'm going to call this foo, and we'll go ahead and do this. It'll be an entity. I'm going to call the entity xxe, and we're going to get a system file. And that system file will be the file at the location etc password. So this would be the general structure of our external entity. What we do is we essentially define that we're creating an entity, and we give the entity some sort of name. And this name can be really anything that you want. I just pick xxe as this example. And we say what the entity is going to be. In this case, it's going to be a system file. And that system file is going to be the file that is located at this path, the etc/password path. Now all we have to do is just change one of these values to that external entity. And what will happen is it will attempt to access that external entity, and it will return us back the results. And the results in this case are going to be the contents of the password file. So the way that we access this is we put an ampersand, and then we put xxe, and then a semicolon. So now I can send this query, and you'll see we'll get a response back here on the left-hand side. And as you can see, it says invalid product ID, and then it leaks all of the information that is contained inside of that password file. This is the idea of what an XXE exploit is going to look like. Essentially, it's going to attempt to access that product ID, and it's going to be invalid. And when it sends back that invalid error, it's going to in turn send back the contents of that external entity we attempted to access. And that would be, in this case, the contents of the etc/password file, which, as you can see, is all the different users that are on the system. So you can see with this, we're able to access really any sort of file that's on the system, which is very dangerous, right? The information disclosure from this is huge. If we are able to access the shadow file of a Linux system, for instance, that would give us all the hashed passwords towards which we can then do an offline password attack, and then potentially be able to exploit the system and gain unauthorized access. So like I mentioned before, this is really just one way to be able to do the XXE-based attacks. We'll take a look at a few others as well. So with this problem, we've now pretty much successfully solved it. So that teaches us everything about the external entities from that perspective. One additional thing we can do with XXE is we can use it to perform SSRF attacks. An SSRF attack is essentially the ability to be able to send a query from someone who isn't us. So as an example, there's a server running on here that has some metadata, and there's potentially some sensitive data inside of there. This IP would typically only be accessible from the server itself. So us as a client wouldn't be able to access that. However, if we use XXE, we're able to make the request look like it's coming from the server, which means that we can in turn access things that we shouldn't be able to access typically. So to show this, it's a very similar type of idea to the previous lab. So we'll go ahead and access this. Sorry, I'm gonna have to turn back on the interceptor here. Get this going. So we'll turn this back on. Let's go ahead and access here. Sorry, okay. I think we'll just have to disable the proxy and re-enable it. Sometimes this will happen. I think it's because the actual session will expire. So sometimes we have to go back in and just or disable and re-enable the proxy. So go and do that. Let's try to access this page. Okay, great. So now we can access the lab. And then once that's done, I'll go ahead and set up our proxy again. And then we'll come back into here and turn our interceptor on. And again, we'll do something very similar to before. We're going to go ahead and enter into the item, right? And then once we're inside of here, again, we can check stock. So we'll go ahead and check the stock of the London store, for instance. And we'll see if this one gives us, yeah, this one gives us an XML structured format as well, right? So we're sending an XML request to the server. Again, I'm going to take this, I'm going to place it inside of my repeater, and we're going to go ahead and modify this XML, but we're going to do it in a slightly different way compared to before. So let's just turn off the interceptor here. And what I'm going to do here is I'm going to use it to do an SSRF-based attack. So I'm going to, instead of accessing a system file, we're going to access an actual URL. And the way that we do this is relatively similar. So we'll have a similar type of setup. We'll have our doc type. I'll call it foo. And then we'll do our entity. We'll call it XXE. We'll say system. And instead of doing a file request, we'll do a URL request here. So we'll do 162 or 169.254.169.254. 254. I believe that that's the IP. And then we just have to close off the brackets. And this would be what we're going for. Now, again, we want to put this into a piece of the actual XML itself. So we go XXE here. Again, remember to end it with a semicolon. Remember to start it with an ampersand. And that's the general format. Again, very similar to the previous one. However, instead of doing a file, we're doing a URL this time. And you'll see the general process and flow of this is slightly different. So now when I send my request, you'll see in the response, we get invalid product ID latest. This tells us that the next sub URL here is latest. So what I can do is I can place this latest at the end and then query again. And when I do this, you'll see once this sends through, it says metadata now. So then the next path part is metadata. And this will just slowly expose to us the location of the secure data that we're looking for. So again, we're just going to keep on concatenating what is given to us as the invalid product ID. And essentially all we're doing is just building up the actual URL based on the results of the query, right? And eventually, once we get to security credentials, we're going to put in admin. And what we're going to get is the actual admin credentials. So you'll see here, we get all the information for the admin. We get their token, we get the access key ID, the secret access key, the expiry date, the type of hashing algorithms that's used for this. So this gives us a ton of information. Again, this is a very devastating vulnerability to have on your system. If someone is able to exploit something like this, they're going to be able to get your admin credentials, which is very bad, obviously. So again, the idea behind this is that we can make queries to web pages that we wouldn't necessarily be able to do normally. And one thing that we can do with that is we can slowly build up a URL to some sensitive data using the responses back from the XXE. In general, the response that you're going to get back is going to give you information about either the page that gets visited or the URL pieces that you need to piece together to get to the page that you're looking for. Regardless, eventually, if you continue to query different URLs, you could potentially expose data. So this is another thing that we're able to do here. I believe this sort of thing could also be used to maybe query from the system perspective to another website to try to like authenticate against it. However, I haven't really tried something like that. This is the typical use that I've seen for this type of vulnerability. So that gives us the idea behind this lab here. What we'll take a look at next is how we can actually exploit this through an image file upload. This is a rather interesting one because it's not necessarily through the request, it's actually through SVG images. Now, if you don't know anything about SVG images are essentially vector graphics. And inside of vector graphics, we're able to set up sort of like length and width and information about the actual vector itself. And that is in turn done using XML. So because of that, we can actually manipulate the XML in a very similar way to any other XML file that we've looked at so far. So let's go ahead and access this lab and we'll take a look at that. I'm just going to flip over my proxy here. We'll go back into the lab. So essentially the idea here is that we have a blog. And inside of this blog, we're able to go into posts and we're able to leave comments. And inside of the comments, you'll notice that there's this avatar that we're allowed to put in like some sort of picture for ourselves. Now, the idea is that inside of that picture, we can upload an SVG file and that could get interpreted as XML and in turn reveal information about the server. It'll actually reveal it inside of the image itself, which is quite interesting. So I'm going to show you what the XML looks like for this. Essentially, to understand this, you have to have a bit of an understanding about SVG files in general. So the actual XML pieces are going to work with like the XML version. It's going to display the general information about the standard that we're utilizing. And then what we're going to do is we're going to define our external entity like we did before. And in this case, we're targeting etc/hostname. That'll be the file that we're actually targeting. And then what we do is we set up the SVG width and height. So the width and height of the image itself. And then we give it sort of like the standards that it's using for its formatting and such. And then we say that we're going to print out some font. And the font is going to be size 16. Here's the X and Y coordinates of it. And the text that we're going to put into it is this external entity. So what this does in turn is it prints out the result of the external entity query to text in the image. So it'll create a very interesting sort of effect that I'll show you here. So I'm going to go ahead and type in a comment. I'll just say test. And let's go ahead and browse for a file here. So I put it into here and it's test.svg. And then we can go ahead and post our comment. We have to actually put it in an email. So we'll say ada.com and let's post our comment. You'll see it will load and it will say thank you for your comment. Then when we go back, we can head into the comments and you can see that my image there has some text inside of it. Now, to get to this, we sort of had to be a little bit creative. The best way that I found to do this is just through the source browser here. If I hover over it, it will show me the image. I can also navigate to that sub URL to get to the image. But as you can see, it wrote the results of the external entity query into the image itself. So you can see that we can be very creative with these types of attacks. We don't necessarily just have to like brute force XML data or anything like that. We can use SVGs as well. So there's a lot of creativity that you can do with these sort of XXE based attacks. Now there's one final type of attack that I want to talk about, and that's X-include. Now the idea behind X-include is essentially that when we have XML based data, we don't necessarily control the whole XML document. We might only control a certain input of it. So in those sort of instances, we have to be more creative about what we do because we can't just inject our payload anywhere. What we can do in these cases is using X-include. And essentially, X-include is basically going to concatenate the XML together with other XML that we provide. And through that, we can provide a similar payload to what we did in the first two examples. And that in turn will execute and give us a result that will allow us to do an XXE based attack. So let's go ahead and take a look at how this is done. So this is a very similar type of situation to what we previously had. Let me go ahead and set up our proxy here. And let's turn on our intercept. So again, we can check the stock. And what you'll see here that's relatively different is that when we actually check the stock, it's going to post the product ID rather than giving us the XML for it. Seems like this one doesn't seem to be working. Let's just go to a different one here. Let's try this one out for size. So we'll accept the risk here. We'll just forward those through. All right, so let's check the stock here. Let's try this one out. Let's forward these ones through. Oh, this one seems to be having problems. Let's try it again here. Here we go. So yeah, it might take a few attempts, but eventually you'll get one that works here. This one, you can see that it posts the product ID and the store ID. So what you essentially have to do is you have to inject into the product ID or inject into the store ID. This is a very typical sort of situation. You won't usually be given the whole XML document. So to be able to do this, we just have to utilize the X-include portion. So we'll go ahead and place this into the repeater like we did before. And let me show you how this can be done. So in params here, I can adjust the value of each parameter. So I'm going to adjust the product ID. And what I'll do here is I'm going to set up the following. XMLNS. So this is essentially us just declaring the actual format of the XML document that we're going to be using. You'll notice that anything that sort of references w3.org is basically just sort of like the templated, like here's what an XML file is going to be defined as. It just sort of tells the XML parser how to parse our file. So we can have this portion, let's do \2001 \x-include. So this tells us that we're going to be using an X-include. And the X-include that we're going to be using, XI, is going to be defined as include parse equals text, href equals file, so it's just /etc password. And then we'll close off the external entity. So what this does is essentially we have our X-include, right? And we define the format of the X-include, and then we discuss what we're actually doing with it. So we want to include a parse that's equal to text, and then we give it a reference to where the text is actually located. When we do this, we should be able to send this, and assuming I've done everything right here, we get a response back that is very similar to before, where we get the whole output of the shadow or the password file. So you can see how this generally works, right? The first portion here is us telling the server that we're using an include. And then after this, we put in the actual include that we have. We tell it that it's going to be text, and then we give it an href for that text. And the href is an external entity, which is the file that we're trying to access. And when we do that, the server attempts to access that file. It returns back the text, which gives us this result here, which is very similar to before. So this should give you a general overview of all the different types of XXE-based attacks that you can do. There are more than just these four. However, these are the most common ones that I've typically seen throughout my experience. These type of attacks are very valuable to have because they are quite critical if they are found. And the ability to actually fix them can be fairly straightforward. There's a lot of different ways to do it. You can whitelist the inputs so that the user isn't able to input XML data into post data like this, for instance. We could check the product ID to see if it has XML characters and just blow it out if it does. In addition to this, typically most XML parsers that are modern will have some sort of way of safely parsing data now. So you can set specific flags inside of the parsers depending on your language to be able to say, don't do this, right? To be able to stop it from actually parsing it incorrectly. So those are the general ways that you can sort of mitigate the risk of these XXE-based vulnerabilities. Realistically, the best thing that you can do is not allow the person to directly input XML-based data. And typically, we might want to favor other types of data like JSON, for instance, that don't have these types of vulnerabilities associated with them. So those are a few different factors that you can consider with these. So that's the general idea of these XXE-based vulnerabilities, and you should now understand how to be able to find and exploit and hopefully fix these problems if you happen to find them inside of your own applications. Broken access control is one of the top vulnerabilities that's discussed on the OWASP top 10. I believe it's at number 5 out of 10, so it's a fairly common one, and it sort of lives on the same sort of ground as broken authentication in the sense that we're not properly enforcing controls that determine who has access to what resources on a system. So we're going to take a look at a few different ways that this happens and then discuss some ways to mitigate these sorts of issues. So in general, when we're bypassing access control, we're looking at modifications of things like URLs, HTML pages, maybe through APIs, application states, things like cookies, really anything that's in the user control. They may be able to modify it and in turn utilize that to be able to bypass the actual access control of an application. In general, access control is the component that after you've logged into the system, it determines what sort of actions you should be able to take. And in general, it can also determine what sort of actions a non-logged in user can take. So there's sort of two components there, either a non-authenticated user being able to do authenticated things, or an authenticated user being able to do higher level things such as administrative actions. So one way that this can happen is through primary key manipulation. So inside of a database, you'll have a primary key which will keep track of the current record of the person who's utilizing the application. If for some reason the person has access to that private key, they might be able to change it to map to a different user, which can help them circumvent access control. A good example of this could be something like student ID, for instance. So if you're on like a student system and you have a student ID, if the user can modify that student ID for some reason, then it will change how it maps to a different user and could help them circumvent access control. Another even more common one, there are some people for some reason who may use first name and last name as a primary key, which in general is a really bad primary key because it has duplicate values. But if you do something like that, you can actually potentially, change those fields if you have power over those fields, which you usually would in an application, and that in turn could map you to different users and then help you circumvent access control. So things like usernames, that sort of information is the type of stuff that might be able to help you circumvent these sort of pieces of information. Also, in general, when you send a request for like an API or a cookie, sometimes you might have to put in a primary key like a username. If you can change that username and it doesn't verify it server side, then you might be able to get access to something you shouldn't be able to get access to. So the general process of getting more permissions than you normally have is known as an escalation of privilege, and that's a very typical type of vulnerability. And there's a few different ways, as we discussed, that this can take place. We can either act as a user without logging in or escalate from user to admin without authentication. Now, one of the things that I want to discuss here is the idea of escalation of privilege from the context of an operating system. A lot of the times if you compromise an operating system, you may compromise it as a normal user. For instance, if I have a Linux box that has a whole bunch of SSH users and they're all different users in my company, for example, if you manage to brute force one of the users because they have a really bad password, your next step would be to try to escalate permissions or escalate privileges to become an administrator. So if you're able to find an escalation of privilege somewhere, then you're able to escalate your permissions and become an administrative user. This sort of thing happens a lot with applications. If you find an application and you're able to find an escalation of privilege through that application, say it's like a system level application, for instance, then you might be able to escalate yourself to an administrator without any sort of authentication. So that would be an example of escalation of privilege. And in general, things like metadata manipulation is very common. If you have tokens such as JWT, which is, I think JSON Web Token is what that stands for, a lot of the times people could attempt to tamper with that information. So if you're storing tokens on the user side, the idea is that you always should be verifying it on the server side. Same sort of idea with cookies or hidden fields. Anything that the user has control over should be validated server side. You should never trust it at face value. So different metadata things like web tokens or cookies can often be manipulated to try to find an escalation of privilege. So it typically involves things like changing a role to admin, for instance, or doing something like that that will allow you to impersonate an administrator without actually being an administrator, and that would be through metadata manipulation. And then one of the big ones that's coming up more and more is everybody wants an API in their application, but a lot of people don't really implement them properly. So missing controls on APIs tends to be a fairly common problem. If you do like posts, puts, deletes, that sort of thing, you may be able to utilize these API calls without proper permissions. So maybe typically we only want an admin to delete data, but if we don't authenticate it through the API, someone might be able to delete data without having any sort of permissions. So this is a really important one to keep in mind. If you ever have an API that has external access, different things like post and put and delete and get, for instance, should all have permissions associated with them. If they can get to data that they shouldn't be able to get to without authenticating, they shouldn't be able to run that call through the API. So we should always enforce those permissions, ensuring that unauthenticated users can't get access to data or modify data without permissions. So the final piece here is to just discuss like a general idea of how to prevent access control breaks. So on default, whenever you're checking for permissions, if you run into some sort of problem, you should default to denying access. So if someone tries to access something and an error occurs, for instance, you should default to just denying access immediately. So you never default to allowing the user into the system, because that's how these sort of like escalations typically work. We want to always log the information too. So whenever someone accesses something, we should log that information. If something looks funny, like someone accessing an admin page without a username, or someone accessing an admin page that isn't an admin, that can help us see that there's an access control break without actually, having it happen, right? Well, it will happen, but we'll be able to notice it when it does happen is the idea. And then the other thing is to verify access control on the server side. We never trust user-controlled data. We should always verify everything the user gives us on the server side in a way that they do not have control over. If someone claims to be an administrator, we should make sure that they actually are an administrator. We should not let anybody be able to control that information completely. Otherwise, we're going to get into these access control breaks. So this in general gives you a few different examples of access control type vulnerabilities. It allows you to get a bit of an understanding of how these sort of things present themselves in applications. So if you ever run into these sort of instances in your own applications, you can apply these sort of steps to fix them. Otherwise, this will help you sort of look for those issues to determine if they exist on your system, to ensure that they don't happen and to ensure that they're prevented. Security misconfigurations are very common in a lot of different web applications, and they can happen whether you have an experienced team working on your application or a bunch of people who are sort of newer who are working on the application. It happens to everybody, and it becomes increasingly common as new technologies get released or new updates for the technology get released. So understanding where security misconfigurations can happen can help us locate those issues and be able to patch them when they happen or before they're discovered by anyone else. So one of the biggest things that typically happens is people will miss different types of security hardening. So things like this can be very simple. It can be things like compiling your application without protections such as stack protection. Stack protection can help prevent buffer overflows in applications. So when you turn off this flag, sometimes you get a more efficient program, but you'll also get something that's very more likely to be exploited with buffer overflows or those types of vulnerabilities. It can also happen with improperly configured cloud permissions. A lot of the time people will set up cloud environments environments, but they won't tweak the permissions and settings on them. From this, a lot of things can happen. I know recently there was a lot of talk about hard drive data being exposed from cloud instances, where you could literally just Google search for specific words and you can expose information from hard drives that shouldn't have been accessible from outside of the cloud environment. So these sorts of vulnerabilities come up fairly frequently in terms of missing those types of security hardenings. You have to have some awareness of what sort of security features you should be putting in place with, say, your cloud environments, so you can ensure that they're properly secured when people are attempting to access them. Sort of down the same sort of road as this is unnecessary features. This can include a lot of different aspects. Things like ports, accounts, and software are some of the most common. So to give you a few examples, if you have an application that ships on a server, for instance, that server could have software installed on it. And the software that's installed in it should only be the things that you are using. Same sort of idea as if you have a server running a web application, that server should only have applications installed on it that are actively being used. Otherwise, you can have old software that will be on older versions that will just expand the attack surface for someone attempting to attack your product. Enabling accounts that aren't used is a fairly straightforward idea. If you have accounts that are on the system, they should serve some sort of purpose, whether they're user accounts or administrative accounts or things for scheduling tasks. Setting up accounts that aren't actually used is a big problem because they could be potentially weak points where someone could attack and then do escalation of privilege to be able to compromise the account to get administrative access. The last piece here is enabling ports that don't need to be used, and a perfect example of this is the GhostCat vulnerability. With GhostCat, the AGP port was enabled, and it was allowing people to be able to get files that they shouldn't have been able to get or do remote code execution potentially. That AGP port was something that was very rarely used by anybody who was using Tomcat. For things like SAML, it was typically used, but there was a lot of instances where people had that AGP port enabled, but they weren't using it at all. So it just goes to show that when you default install an application, it's going to come with everything turned on essentially, and you need to be the one to turn off the things you aren't using, which means that you have to have a good understanding of what your application should actually be working with and what it should actually need in order for it to be running. So by understanding what your application needs and uses, you can lower the attack surface to the point where it's only things that are being used. That means you have to keep less stuff up to date and also less things for the attacker to be able to attack. Another place where we typically have security misconfigurations is in error handling. The most common is revealing stack traces to the user. If we run an exploit and we get an error, that error might expose information about what happened, and that exposure of information could tell us things about the actual system or service itself. It can tell us things about how the code is flowing through the application, where the error actually happened, what web pages are being accessed. It can give us a lot of information. So error handling is very important. Same sort of idea with creating error messages. If you make error messages that are too informative, you can expose too much information. The classic example is that username doesn't exist. When someone tries to log in, tells them that they are trying to access a user that doesn't exist, which means that they could try a different user. So they gain information from the error message, which is something we don't really want to do. We want to balance error messages displaying useful information to the user, as well as error messages not exposing too much information to the user that they can learn something about the application's functionality, right? And then default configurations, which I sort of touched on with the idea of the Tomcat AGP port. So when you install things, there'll be a default configuration. That default configuration is rarely, if ever, secure. You want to make sure that you are altering those default configurations to be as secure as possible. So changing default passwords, removing any default accounts, closing any ports that aren't using, stuff like that, right? So a lot of common attacks can leverage default credentials, for instance, default configurations, just any sort of weakness that may exist on the system due to a default configuration can commonly be attacked. So in order to mitigate security misconfigurations, there's a few different things that we should keep in mind. The first is that we should create a repeatable process that we can do to complete our configuration on updates and upgrades. So for example, if we're going back to GhostCat, if I update Tomcat to the newest Apache Tomcat version, we also want to make sure that we apply all the same hardenings that we did to the previous version. So in order to do this, we should have some repeatable process that can sort of automate that. So just like a quick script that we can run that runs through our configuration and sets it all up again when we have to update or upgrade components. Along with this, we should utilize a minimal platform with no unnecessary features. So if we're using like a Linux server, for instance, we should uninstall everything that we aren't using that isn't necessary. Anything that's default that comes with it that we don't need, we can just remove it. That way we can lower the attack surface and make things a little bit cleaner, right? In addition to this, if we're shipping the product to a client, we should advise the client on the proper security procedures and patches. If they need to apply anything after a patch is applied, or if they need to adjust anything on their system, they should know how those sort of things happen. And if we ever get any vulnerabilities reported to us, we should create test cases for them so we can ensure that regressions don't occur. So every single time we get in a vulnerability report, we create a test case, we patch it, we run our test case to make sure it doesn't work anymore. Every future version and every future patch, we run that vulnerability scan up against our system to make sure we didn't have any sort of regressions that are going to cause that vulnerability to come back. So these would be the sort of ways that you can mitigate security misconfigurations, and this will give you a general idea of how you can notice these misconfigurations to be able to detect and patch any sort of problems that come out of them. XSS, or cross-site scripting attacks, are a very common way to attack a web application that utilizes JavaScript or similar languages. And typically it occurs when we're taking data from the user and outputting it to the screen in some sort of way. Now that input can vary in a lot of different ways, sort of similar to things like SQL injections. The locations that you can get those sort of inputs from are very varied, right? They can come from input boxes, they can come from cookies, they can come from database information that is provided by the user. They can come from files that are uploaded from the user and like the names or the data contained inside of the files. So it's one of the vulnerabilities that are very common in web applications and very easily preventable just by not trusting user input and filtering out vulnerable characters and not executing essentially user input as code. And that's essentially the theme of what this is all about. When you have cross-site scripting vulnerabilities available inside of your application, they're available because we execute user input as code, or we write it to the page in a way that it can be interpreted as code. So we never want to allow those sort of situations to happen, and we'll discuss a few different ways that we can prevent this. But first, we'll take a look at a few different ways that we can find these vulnerabilities and what they actually do. So we're going to start off with what is called a reflected XSS attack. The idea of a reflected attack is that it's not stored somewhere in the web page. What you have to do is you have to convince someone to input the vulnerable input, or you have to perhaps provide them with a URL that will do the input for you, or you have to send the packets in some other way. So you aren't able to actually just like store it somewhere and anyone who visits gets attacked. This one is one that has to do with people actually inputting the input themselves. So let's go ahead and access the lab and let's take a look at the information here. Let's give a minute to log in. So essentially what's happening in this blog is when we search for something, say test, you'll see it says results for test, right? If we go ahead and inspect the element here, we can see that it writes whatever we wrote into this header here. So we are able to essentially write whatever we want into this header, which means that we can actually write JavaScript code. So for example, if I pipe in something like this, so script alert 1 script. What this does is the script tags tell the browser that we're going to have some JavaScript. We put the JavaScript code here, which is an alert window that will pop up the number 1, and then we end the script tag. When we search for this, you'll see our alert pops up on the screen. This is a perfect example of a cross-site scripting attack. When we input JavaScript code, rather than it displaying the information to the screen, it actually executes it as code. So we press OK here, and I'm just going to show you what this actually looks like in the code so you can get a bit of an understanding. So you can see here 0 results 4, and then it has our script, right? So you can see that it executes our script inside of the header, and it gets interpreted actually as JavaScript rather than get interpreted as text. So the question would be, how can we prevent something like this from happening? The first way to prevent something like this from happening is to not allow for specific types of inputs. So, these angular brackets, for instance, we can try to avoid those inputs. We can remove semicolons, for instance. We can remove closing tags. That sort of idea is something that we can do to be able to help filter out some of that data. There are also specific ways to filter out the actual inputs themselves to sort of escape those characters. So whenever you see an opening brace, for instance, you can add the escape character for the opening brace and closing brace to those. A lot of the time, these are done through actual frameworks in JavaScript or related languages that will allow it to actually filter out those values before they're actually inputted. So that'd be the example of how we can sort of prevent this sort of thing from happening. But this gives you some intuition behind how this sort of attack can happen on a basic level. When we take a look at the other types of attacks, you're going to see how we can do it in a bit of a more complex way, but a way that does a bit more damage. With this example here, we would have to convince somebody to search the blog for that specific input, or we would have to send them a URL that has like this in the search. If we were to do something like that and the person accesses it, it would execute our cross-site scripting code, and there's a lot of different things that could happen from there. One of the most common things is that we can steal the cookies from the browser. That means that we can typically authenticate as the user utilizing their cookie. So that's one of the most common things that typically happens. CSRF attacks are very common with cross-site scripting, and there's a lot of other different attacks. Basically, anything that you could do through JavaScript, you can do with these cross-site scripting attacks. So when we have these sort of situations where you have to convince the user to go to a specific URL or input something specific, it's actually a bit harder. One thing that I will point out here is that there was a very big set of these attacks that happened, it was maybe 5 or so years ago. And essentially what happened is inside of the console, attackers were convincing users to type in specific sets of code promising that they would do something. Maybe like expose some secret portal that they could like change specific settings, or, you know, any sort of lie that you can give them to convince them to do that. What that actually did typically was send the cookie to the attacker so they could authenticate as the user and essentially hack their account. So that console input is another great example of this reflected cross-site scripting. You'll actually notice if you go on pages like Facebook or Discord, for instance, if you open up this console, you'll see a big message there that says, do not input code into here. If you're being told to input code into here, you're probably being scammed. So it was big enough that all of the major sort of companies started to put that information in so you could see that you shouldn't input code in there. So that's another common example of a reflected cross-site scripting attack. We're going to take a look at a stored cross-site scripting attack as well. These ones are a lot more dangerous, and these sort of attacks have happened a fair amount of times. One of the biggest ones that I remember is back when YouTube was sort of in its infancy and starting up. People were able to put cross-site scripting into the comments section. So you would go to the comments of videos and they could redirect you to random sites, or they'd be popping up GIFs and all sorts of weird stuff. That happened quite a while ago, but it was something that was quite big. If you were on YouTube at the time, you probably remember seeing that. And that was a result of stored cross-site scripting. And a lot of other web pages have fallen victim to this. A lot of others are still falling victim to it. I've personally found a lot of these in the products that I've investigated through my career. It's very common to find these cross-site scripting attacks. They're just very common oversights from developers. So let's take a look at how this differs from the previous one. When we access this lab, what we're going to do instead of going to like the search or anything like that is we're going to go into the posts. And inside of the posts, you see that we can leave a comment. Now, if we're going to investigate some of these comments, we can take a look at them and see what they typically look like. And you can see inside of the paragraph, we just print out whatever the user put inside of there. Whenever we see situations like this, we should be thinking to ourselves, okay, this is a perfect location to try to do a cross-site scripting attack. So let's go ahead and give it a try. Like before, we'll use the exact same setup. We'll do script alert 1. So again, like this. And for the name and all of that, we don't really care what we put in here. It doesn't really matter. And we'll go ahead and post our comment. You see when we do and we go back to the blog, you'll see it pops up with our alert, right? The difference between this and the reflected cross-site scripting is that anybody who visits this page, no matter what, is going to execute our code. So this is a publicly facing one. We don't have to convince the user to do anything special to hit this vulnerability. All they have to do is simply visit the vulnerable web page and they'll get hit by it. This is, again, extremely dangerous because there's no need to convince the user to take some sort of action. No user interaction escalates the severity of this greatly because anybody who visits this site and has the misfortune of coming to a page that we compromised is going to get attacked by us. So we can execute our payload against almost anybody who accesses this site, unless they have like JavaScript disabled or something like that. So this is another sort of example. And again, the idea of it is very similar, very straightforward. The very last one that we'll take a look at is a DOM-based XSS. And the idea of this is that when we are working with JavaScript, sometimes we concatenate the user's input into a very specific location. And when this happens, we might need to actually escape out of that and then execute our code rather than executing it immediately. I'll give you an example. Like if we give an input and it lands in the middle of an array, for instance, we might need to like close off the quotation and then close off the array and then run our script. Or we may need to do something slightly different. There are a few different tricks that we can use, such as onload, for instance. What we can do is we can put in HTML elements and say onload do this, or even on error. On error is typically the one that you'll see. We could do an image and try to load something and say on error execute this JavaScript, and that will always allow us to execute the code rather than having to jump through hoops to close off the bounds or anything like that. So with this example here, it's relatively similar to the first one that we took a look at. Again, we have our search here. And when we search, our content does get written to this page here, right here. However, it's not really something that we're able to attack. But there's more locations where we could potentially attack, and it would be right here. You see that this tracker.gif has the search terms inside of it. So we can actually attack this specific section here. And what we can do is we can sort of close off the image tag, and then we can put in another tag that will be able to execute our code for us. So the question is, how can we do something like that? Well, if we want to close the tag, we can put a double quote and then a closing tag here. So see, that would do search terms equals a closing quote, and then it would close off the image tag. And then what we can do is we can open up another tag, and then we can create another tag that's sort of like of our definition. So what you do here really doesn't matter. You could do like image tags. You could do any sort of tag here that will have sort of these features available in it. So as an example, we could do an SVG. An SVG is just like an image tag, right? We could say on load equals alert 1. So again, what this does is it closes off this image tag, and then it defines a new tag that just is an SVG. It has an onload property that executes the JavaScript that we put in here. So essentially, it closes off the first tag, it loads our new image, and as long as the image loads, it will alert us with that JavaScript alert. So we can go ahead and do this search, and as you can see, it executes our code. Now, let's go ahead and take a look at what this looks like to understand a bit more. So you can see here, here's essentially the piece that we have. So you see we close off this tag here, and then we have our SVG onload here, which is the piece that we injected in. So you can see that we just sort of like close off the tag. We create a new tag that when it loads will alert, and then we're done. Now, there are, again, other ways to do this. Onload is one. On error is another one that's very common. On hover is one that's quite common as well. So you have to take into account that HTML elements can have JavaScript embedded in them too. So the key takeaways here are essentially the following. Whenever we print information to the screen that is provided by the user in any way, we have to make sure to sanitize that input in whatever way that we really can, whether it be escaping specific characters, whether it be avoiding certain characters altogether, whatever option you want to pick, whatever one's most appropriate for your application, you want to make sure that you're applying it. The second key takeaway here is that JavaScript is not the only location that's vulnerable. If you have HTML elements that are being written, you can actually execute JavaScript through a lot of them. Specifically, things like image tags, things like hrefs have onload, on error, on hover. You want to avoid being able to write those pieces, again, by either filtering out like onload or that sort of thing, or filtering out the brace brackets, or just like preventing specific characters, whitelisting certain things. There's a lot of different methods that you can use to prevent this, but those are the key areas where you're going to see those attacks. So this gives you an idea of the 3 main XSS-based attacks, and it gives you a bit of an idea of how they really look, what they look like in the source code, and what you should be looking out for in terms of preventing them. So remember that HTML and JavaScript are the 2 main areas. If you're writing HTML and JavaScript from the user, even like PHP echoes or anything like that, if you ever take something from the user and write it to the screen, you want to make sure that you aren't vulnerable to this vulnerability by using some of the same methods that I showed you here, by like writing a script that alerts 1, for instance. If you do that through your inputs, you'll be able to easily tell if you're vulnerable to this sort of attacks. So this should give you a good idea of how to locate these sort of attacks and prevent and patch them in your own web applications. Insecure deserialization is a relatively new vulnerability to the OWASP top 10 list. It's becoming sort of increasingly more popular, and although it sits at number 8 on this list only, it's a fairly common vulnerability to see in a lot of different applications because of the process of serialization and deserialization being so central to a lot of applications that utilize object-oriented programming. So we're going to take a look at what deserialization really is and understand how it's used to exploit vulnerabilities and what we can do about it. So first off, what is serialization? So in web applications, we typically use objects to store data. When we store data in objects, we need some sort of way of transmitting them either into a database or across the wire to some sort of receiver. So maybe if we're communicating between like the client and the server, if the client creates like an object, they need to send it off to the server. Serialization is the way that that's done. And what we typically do is we convert the object into a byte stream. That byte stream is sent off to the receiver. The receiver will receive it, and then they'll convert it back into an object. So this is really just a way of being able to store and transmit data when it's stored in terms of objects. So deserialization is, of course, the reverse process of serialization. So when the recipient receives the serialized object, they can turn that byte stream back into the object. And typically the process is like, so say we have an object that has two properties, right? We turn it into a byte stream. We send the first property and the second property. We might put the object at the very beginning, and then when the person who receives it, they see what kind of object it is. They see the properties in the byte stream, and they just build the object based on that information. So the typical flow is going to be that the sender will serialize an object, they'll send it off, the receiver will receive the serialized object, they'll deserialize the byte stream and back into an object, and in the end, they'll be able to transmit data in this way. So the vulnerability here is that an attacker can send their own data to be serialized, and then the deserialization process will be the portion that gets compromised. When the server pieces together the byte stream, we can potentially input data that is insecure. And if the server doesn't do proper validation on that data, it will potentially be able to cause some form of impact, whether it be escalation of privilege, remote code execution, information disclosure. There's a lot of different potential impacts of this type of vulnerability. Just to give you a bit of an idea, when you have escalation of privilege, it typically results of like tweaking a property of the object that's being sent off to escalate your privilege to say that you're an administrator or something like that. When this sort of thing happens, when the server receives the data, it will simply deserialize the object. It will turn it back into the object itself, and since it doesn't do any verification, it will just accept the object as is, assuming that everything you provided it is correct. And this will allow it to essentially escalate the privileges for you. Remote code execution is a little bit more tricky. If we have a situation where we're sending like a command in an object, for instance, you could potentially pull off like a command injection by changing that command. And there's a few other different instances, like if we call specific functions or specific methods, we may be able to modify those pieces to be able to do remote code executions. And information disclosure, of course, comes from the idea of, if you send off maybe an object that has an ID in it, you might be able to alter the ID to get different sets of information out of that object. So those are the typical sort of impacts of this type of vulnerability. So to give you an example, cookies are typically a way that object serialization and deserialization might be exploited. So suppose that we have a cookie for a web application that has a user, a role, and a password hash. If someone has a cookie like the one in the second bullet where it says Alice and she's a user and her password is 1234, we might be able to modify it to say change the user, change the role to administrator, and send it off to the server. When the server receives this and deserializes it, it won't be verified server-side because we're just going to assume that the server is trusting the data, in which case it will see that an admin is trying to make an action, and it will accept it because an administrator will have the ability to do that action, which will mean that they'll get admin access without actually having an admin account. So this is a very common way that object deserialization might be used to exploit a system to do like an escalation of privilege. So the main way to mitigate this sort of problem is to always verify user input. In the cookies example, when we send off that cookie and it gets deserialized by the server, the first thing the server should do is take that data and verify it against a database or something that it stores and has control over to see if that user is actually an administrator or not. In this sort of way, we'll be able to ensure that they aren't able to escalate their privileges because we're verifying it in a location that isn't controlled by the user. Similar sort of idea, if they provide you any sort of input, we should be filtering it out for any sort of commands or anything like that. We should never use user input in a way that it might be able to get exploited. So we never trust user input, and we always validate user input. Aside from this, web application firewalls could be a good additional mitigating factor for these sort of risks. It doesn't necessarily solve the problem, because even if you have a firewall, it doesn't mean that every single attack is going to get caught. There could be a new type of attack that your firewall isn't prepared for, and they might be able to get through. So really the best way to mitigate this problem is to keep your validation on server side and always verify user input. So this gives you an idea of what object deserialization is really about and how these vulnerabilities can exist on a system. So from this, you should be able to understand the general ways that you can exploit this type of vulnerability and understand how it can be mitigated and patched on the application server side. One vulnerability type on the OWASP top 10 is using components with known vulnerabilities. So I thought it would be a good idea to sort of discuss the idea of web pages like CVE details, which can tell you a lot about products and what kind of vulnerabilities exist in them, and give you some insight in towards how they can be fixed. And in that, we'll also discuss a bit about CVSS scores and discuss how vulnerabilities are scored to determine how severe they are, as those will all be very valid pieces of information towards using components with known vulnerabilities. So CVE details is a web page that can be used to find vulnerabilities by product types or open source software, for instance. And this is just one that can be used. There's a lot of different ones that exist out there. I know NIST is a really big one as well that can be used to look up CVE details as well. So as an example, we can type in a product that we want to look at. So for instance, we could say like Apache Tomcat. And what it will do is it will show us details about that product and what vulnerabilities exist. You can see over the years what types of vulnerabilities were actually disclosed inside of the product itself and the different types of vulnerabilities that exist. You'll get a lot of different insights towards the vulnerabilities. And by going into these, you can determine, for instance, we can say in 2019, we can see all the vulnerabilities that happened in 2019 and which versions they apply to. So you can see that you can get a lot of good information about that sort of detail on the source component itself. So when we're deciding whether or not to use like one open source software over another or one framework over another, it's always a good idea to check out how many vulnerabilities have been reported and how many exist inside of that software. We don't want to use components that have known vulnerabilities as much as possible. It's not really going to be possible to avoid that when you're using open source software, because there's always going to be new vulnerabilities coming out. So we just have to be able to keep consistently updating those components every single time that the vulnerabilities actually come out, so that we can make sure that we're sort of ahead of the curve and ahead of the attackers. Now, these sort of vulnerabilities happen a lot, and because of that, it can be very hard to manage open source software to make sure that it's up to date. So you see these vulnerabilities a lot. A lot of companies have these vulnerabilities in their software, and a lot of famous hacking incidents are related to these sort of open source vulnerabilities, these things that are well known about by other people, because the reason being is because if a vulnerability is really well known about, there's more of a likelihood that people will create proof of concepts, which makes it easier for people to be able to exploit the vulnerabilities themselves. It also is possible that things like Metasploit will create modules for them to allow automated exploitation of those components. So you want to have a good idea of what kind of things exist inside of your product. And there are ways of like automating this. There are different like news sources that you can take a look at to be able to automate this sort of information. But in general, you just want to be keeping an eye on these sort of things to get an understanding of them. So one other thing that we want to take a look at is like CVSS scores and understanding what those really mean to us. So for instance, if I go into 2018, you'll see that all of these have a score, and it's a score that ranges from 1 to 10, where 10 is the most critical and 1 is the least critical. And you'll see each of these have like a varying range of criticality, essentially, or high scores, right? So for instance, if I pick like one of these, say the highest one here, the 7.5, when we load this CVE, we're going to be able to see details about like what sort of components are affected by it, what versions are affected by it. You'll be able to see how we come to these sort of scores. So you'll see here, when we're taking a look at the impact of the vulnerability, that's how we're essentially scoring out these vulnerabilities themselves. So we're taking a look at the impact of confidentiality, so the ability to disclose information that is not supposed to be seen by other people. We're taking a look at integrity impact, which is modification of files on a system, and then availability impact, which is the ability for other people to access that component. And then we also take a look at the complexity of the attack. So it could be like low or high. Low means that there's very low skill required to exploit it. There's like automated processes, it works every single time. Higher things that maybe don't work every single time. You have to do a bit of trial and error. They have a higher complexity to them. We want to take a look at whether authentication is required. So if we need to authenticate to a server, for instance, to be able to do an exploit, it has a higher bar of entry than just being able to do it without any sort of authentication. We also take a look at how the exploit can be accessed through like what type of vector. So it's things like network, for instance, which can be done just like over the network from anyone who, just happens to be able to see the server. There's like adjacent networks, which are people who are on a network that is in like sort of the same sub-network or in the same sort of general area. And then there's like local attacks where you have to actually be on the system, and then physical attacks where you need physical access to the device itself. So those will each have different levels of severity to them. And there are different calculators that you can use to calculate these CVSS scores. The CVSS scores are very helpful because they allow you to be able to express risk in a way that is known by everybody. When we report vulnerabilities to people, we typically want to use the CVSS scores so that they can get a better understanding of how critical this vulnerability is without us needing to sort of express it in words. We can express it in this score instead, and it makes a bit more sense. So you can see here all the versions of Apache Tomcat that are affected by this specific vulnerability. And then from here, you'll also have your description of the vulnerability itself, which is here. It will show the version ranges that are affected, which will tell you in turn if you're off one of those versions, you aren't going to be affected. So it tells you essentially what you need to update to be able to fix this vulnerability. And then as well, there's a lot of different information that we can see here. A lot of these references are going to be different people that are talking about this. So for instance, you'll see that Red Hat has an entry on this. Red Hat is the Linux distribution, so they come packaged with Tomcat, so they'll have their own release on this sort of vulnerability, right? So everyone will have all these different releases on these vulnerabilities. So this is a really good place to come to learn about vulnerabilities, understand the vulnerable components that might exist on a system, and understand what needs to be done to fix them. So yeah, in general, using components with known vulnerabilities can be relatively easily mitigated by working with web page like CVE details to get an understanding of what components are vulnerable, what vulnerabilities exist, and then making an assessment based on the criticality of those vulnerabilities, whether or not you need to patch to the newest version. You also get details about like what situations the application is vulnerable on. Some descriptions are better than others, but this will give you a general idea of whether or not you're actually affected. So sometimes it might not, only work with Apache Tomcat. For instance, this one says the default settings of the CORS filter. If you aren't using the default settings, it means that you might not be vulnerable to this. So that's the general sort of idea. So you need to do a little bit of assessment and a little bit of work. And in general, really the best way to avoid these types of vulnerabilities is to just keep your open source software as up to date as possible. So although this can cause conflicts with functionality, in the end, it's very worthwhile because it will help you avoid security risk. So this gives you a bit of an idea of what vulnerable components might exist and how you can sort of look up details about a specific component to see if vulnerabilities exist for it. And from this, you'll be able to see information about vulnerabilities for your products and be able to update them so that you won't be exploited with these known vulnerabilities. So the final vulnerability discussed on the OWASP Top 10 is insufficient logging and monitoring. So this is more of like a generic sort of problem. It's not really a vulnerability per se, but it's something that helps to make security issues worse because you have no way of actually detecting that they've happened. So for this, I figured that we'd just take a look at the OWASP page on this to discuss a little bit about essentially what this means and what you should be doing to proactively or reactively catch problems when they happen. So A lot of the time when we're looking at logging, the type of logging and monitoring we want to do is taking a look at auditable events. Things like logins, login failures, a lot of things like access control issues, accessing admin pages, accessing highly privileged pages. We want to take a look at these sort of things. A very common sort of thing that a lot of companies might look at, for instance, is if someone logs in with a different IP than they usually do, they might send a notification to that user, especially if like the person is in North America, for instance, and you see a login from Australia, maybe. That's really far away from North America, so it might look suspicious, meaning that they might flag that to say, hey, did someone break onto your account, essentially. That would be an example of being able to log these sort of things. Now, in addition to this, we may also take a look at logging in general access and any sort of like errors that might occur on our server. So for instance, like 404 errors, resource not found errors, any sort of error that might indicate to us that somebody is doing something that they shouldn't be able to do, right? I know personally with websites that I have worked on, I'll typically take a look at things like what people are searching inside of the search bars, for instance, because they might be putting in malicious payloads into those. I'll take a look at what URLs people are visiting because they might be putting payloads into the URLs as well. We're taking a look at all the different places where someone could be injecting data to determine if they're trying to do something malicious. So that means like anywhere where you print out output to the screen, anywhere where you take in an input for a database or something like that, those are very prime targets for attacks. So you should be logging that information and potentially setting up rules to say, hey, something here looks a little bit sketchy. Maybe take a look into that. So for me, logging sort of goes into sort of a few different pieces. So the first piece is having active monitoring and logging, and the way that you can do that is through like database logs. You can do that through firewalls. You can do that through like intrusion detection systems, intrusion prevention systems. Those are all great. And then you also need the human aspect of this. So you need people to actually respond to those problems. You need somebody to take a look at them and say, hey, this doesn't look legitimate, or, to determine whether or not they should take action on those actual attacks, right? So that's the sort of idea behind what we're doing here. So something that falls into this is the idea of like security incident responses. If you have like a team of people who are dedicated to security response, they can take a look at any sort of problems that might occur on the server, anyone who reports in any sort of problems, anything that's detected like before a product goes to market, for instance, and they can be sitting on those lines to be able to respond to any security events that may occur. So not only are preventing security events important, but also detecting any potential security events is very important as well. We want to make sure that people aren't able to just exploit things without anyone knowing. We need to ensure that we can see any attempts of attacks, any successful attacks, and we need to make sure that we notify people if a successful attack has occurred. So that'd be the idea of logging and auditing. We just want to make sure that we're logging the things that are happening on our server, keeping track of that information, and alerting the proper people when that is actually required. So from this, you essentially get the general idea of this. You just want to make sure that you have logs and that you're monitoring them, and just make sure that people aren't able to do things without you knowing about it. So next up, we're going to take a look at installing our Ubuntu image. I'm going to show you how to install Ubuntu 16.04. Now this is obviously an older version than the most recent version of Ubuntu. The reason why I'm using this one is because it's vulnerable. There's a lot of vulnerabilities that exist on it. It's very easy to compromise, so it's going to be easy for you to work with and attack. So what we're going to do here is, if we head over to the ubuntu.com website, /download/alternative downloads, you'll be able to scroll down here and you'll see an option here for Ubuntu 16.04.6. Now again, like with Kali Linux, you can install the 64-bit, the 32-bit, doesn't really matter. I've already got an image downloaded here. I have, I believe this is the 32-bit image, so if you want to follow along, either of those images should work fine. When we're setting up our virtual machine, it's important to remember some of the settings that we did with the Kali Linux machine as well. I'm going to set this up as an Ubuntu machine. And you'll see that it automatically fills this in as Linux and Ubuntu 64-bit, so that's great. We'll hit next. Again, I recommend giving it at least 2 gigs of memory. And then we can create our virtual disk, and I'll make it dynamically allocated. For this one, you don't need much memory space at all. Maybe 30 gigs is more than enough. We're not going to be really putting much on this. We're just going to be installing some basic operating systems and such, so we don't need much space at all. From here, we can go ahead and hit start. And like before, we're going to have to point it to an Ubuntu image. So I'll go ahead and click here, and we'll boot it up as Ubuntu and click start. Now, once we get into Ubuntu, this will just take a few minutes to load here. And we'll take a look at what we get. Now, it's important to note, if you're installing Kali Linux, like on your actual hard disk partition, you can actually set up the virtual machines inside of Kali Linux. It's basically the exact same process as doing it as a Windows. That's why I'm showing you it on Windows, because it's just easier for me to show it through here. But it's the exact same process on Kali Linux as well. You just simply need to install VirtualBox, and then you can go ahead and set up whatever operating systems you want to set up on it. So there's two options here. You can either try Ubuntu or install Ubuntu. For the purposes of this, we'll go ahead and we'll set it up to try. But what I'm going to do first is I'm actually just going to reboot the machine here. But I'm going to set the network preferences so that we're bridged instead of being on the NAT. That way we can make sure that we can actually access it and make sure that all the settings are correct. So again, to do this inside of the network here, you'll just see an option for bridge adapter, and then you can hit OK, and that will apply the settings. So we just gotta reboot this here. And once we do this, essentially it will set up the IP address and network routing so that it's on the same network as both the virtual machine and our host computer, which in this case is my Windows computer. So what we'll do is we'll get this booted up, and then I'll just show you how to make sure that everything looks to be working correctly. From here, once this is completed, in the next video, we'll take a look at how to set up XAMPP and how to set up things like DVWA, which is a purposefully vulnerable web application. And that will allow us to have a good working environment to be able to test some vulnerabilities. Now, in these videos, I'm going to be also using a Windows 7 machine. If you want to follow along with Windows 7, it's on you to acquire a version of Windows 7 and be able to get it installed. You're going to follow the same sort of steps that you're following with the Ubuntu machine in terms of network setup. So it's really no problem to do it. You just have to acquire an image if you want to follow along with that portion. If you have like old laptops that are running Windows 7, that's totally fine too. You can boot those up, leave them running on your network. As long as you got the IP address, you're good to go. So I hit on try Ubuntu, and it should just live boot us into it like it did with Kali Linux before. And as you can see, we get greeted with the Ubuntu operating system. Again, the interface here is quite bad display resolution. You can adjust this, and you should once you have it set up on your computer. But for now, we'll just work with it. What I'm going to do is I'm going to boot up the terminal, and what we're going to do is we're going to determine the IP of this machine. Then we're going to try to ping it from our host computer. If we're able to reach it, then everything's working as expected, and we're good to start testing with Kali Linux. Now you may notice the live booting is relatively slow. That typically tends to be the case with the live boots. It's one of the trade-offs is that it tends to be a little bit slower than just working with an install of it, but it's still workable, right? So if we type in ifconfig, it will tell us the IP address of the device, which is this IP address here. And what I'll do is I will go into my command line here, and let's go ahead and try pinging that address. See if we can reach it. As you can see, we can ping the address, which means that they're both communicating on the network. In addition to this, we should be able to come over to our Kali box too and ping the same IP address, right? All of these should be able to talk to each other. So 10.115.97, 10.115.97, 248. And there you go. So as long as all of these ping requests go successfully, it tells you set up your machines properly. From here, you are all set to be able to follow along with the videos once we get like XAMPP installed and all of that, right? So the fact that they're communicating with each other, though, is the most essential step. You want to make sure that you can ping between the Kali Linux machine and your target machine. And your host machine being able to reach both of them is also good. And it should be the case if you set up with a bridge adapter. So from here, we've got our images installed. Next, we're going to take a look at how to install XAMPP and DVWA. We're going to take a quick look at how we can install Kali Linux onto our computer. There are three main ways that you can work with Kali Linux. One of them would be through a VirtualBox or VMware or some sort of virtualization environment. The second would be through a live USB, which essentially means you can write the image to a USB stick and then boot it live so that you aren't like overwriting your hard drive or anything like that. You're just booting the operating system using the USB stick as a hard drive, or you can actually install it onto a partition of your hard drive. I'm going to briefly discuss each of those and show you the general way of setting up your USB and sort of walk you through what the Kali Linux install is going to look like. If you're looking for the Kali Linux images, you can head to kali.org/downloads. Here you'll find all the different Kali Linux images that exist. You'll see that there's the full images here. There's some light versions, a few other different variations. There's VMware and VirtualBox images specifically. I typically like to use the ISOs. However, you can download the specific VirtualBox and VMware versions for whatever virtualization you're using. These tend to work quite well as well, so it really doesn't matter what you end up choosing. For the purposes of this, we'll discuss installing via the ISOs. Essentially, when you download these, you can download direct or through torrent. I typically recommend using a torrent because it's just faster. There's a lot more seeders. You can get the download going faster. Once you download it, you'll have this ISO file, and usually it comes with a SHA-256 checksum if you want to check to make sure that the image hasn't been altered in any way and that it's the proper file. However, in this case, we're just going to trust it, right? So this is the ISO file that we're working with here. If we want to write this ISO file to a USB stick, we can use the utility called unetbootin. If you just look up unetbootin online, you'll be able to find it. Here, I'll just type it in here and show you. It'll be this first option here, unetbootin.github.io, and you can download it for Windows. Once you do this, it's really simple to do. You're just going to go ahead and click on disk image. And what you'll do is you'll give it the location of your disk image. And then what you're going to do is you're going to select the USB disk that you want to write to. In this case, I'd be writing to my D drive, which would be this USB stick here. And then you just hit OK. And then it will reformat your hard drive or reformat your USB stick into the proper format. It will write the ISO files onto it, and you'll be ready to go. So if you're planning to boot off a USB stick, all you need to do is just plug in the USB, boot up your computer. At your BIOS screen, just select boot into USB. However, you end up doing that through your BIOS. Every BIOS is different, so just if you want to figure it out, you can just look up your specific BIOS version and say boot from USB. You'll be able to find guidance on how to do that. But once you do that, you'll be able to boot on the USB, and you'll be greeted with the Kali Linux startup page. I'm going to show you this all through VirtualBox, because it's really hard for me to record my screen through BIOS without an operating system set up, right? So I'll show you what it looks like through VMware, and at the same time, I'll walk you through how to set it up on VMware. So I'm going to go ahead and set up a new machine. I'll go ahead and call it Kali. And when we're selecting what operating system we want to work with, typically I just go with Linux and other 64-bit. There are a whole bunch of different options here. I believe it's actually based off Debian or maybe Red Hat, but I usually just go with other Linux 64-bit. You'll be able to allocate some RAM to it. If you're doing it through VirtualBox, I would typically recommend something like 2048. That'd be 2 gigs of RAM. Just give it a lot so that it has a lot of processing power. I mean, you can give it more than that. You can give it less than that. This is usually just what I go with, and it tends to perform relatively decently. From here, we're creating a new hard disk image. Again, with the hard disk image, you can really keep all the settings the same as the default, and you can make it as large as you want. I typically recommend maybe like 50 or 100 gigs, just depending on what you want to do with it. If you're going to be storing a lot of stuff on it, you might want to give it more space, but usually somewhere between 50 and 100 gigs is more than enough for it. We'll go ahead and create that, and that will create our image. Now, there are a few settings inside of here that I typically like to tweak, primarily working with the network. I usually like to set up my VMs with a bridged adapter. The reason why I do a bridged adapter is because it makes it easier to be able to communicate between the host computer and the virtual box, and between all the different virtual boxes that exist. You'll see in the next video, we'll discuss how to install a Linux image, and I'll be using this bridged adapter as well so we can easily reach our virtual box and be able to get to it. But yeah, this is typically the way that I would recommend setting it up. You can use some of the other adapters. If you're more like knowledgeable about some of these other adapters, they might work better for you. But the bridge adapter is one that typically works quite reliably for me. And then once we have that set up, we'll just hit start and we'll pass it over to our Kali Linux image. Let me just go ahead and I'll copy this path so that we have it. So boot up and it'll ask you for a startup disk. I'll go ahead and click on this and we'll go over to our downloads and we'll select the Kali Linux disk image that we just downloaded, and then we'll hit on start. So from this point on, it's going to be very similar between the USB boot and the VirtualBox boot. So what you'll see here is that there's options for live and install. If you're looking to install it overwriting the hard drive, you're going to use the install option. If you're looking to boot live, so that it just uses the USB stick as its hard drive, it doesn't overwrite anything, then you want the live option. Let's select the live option so that I can show you what this will look like. This will get us booted into Kali Linux the fastest and allow us to just be able to take a look at what the actual image looks like. So it's just going to take a minute for it to actually load up. And eventually we'll end up booting into the actual Kali Linux operating system. As you can see, we're booted in now. You can see that my screen resolution is really bad. You can always adjust this through the settings of the VirtualBox or through the settings of the Kali Linux image. So we won't really go over that, but this just gives you a general idea of what the actual Kali Linux image looks like. So this is what the image is going to look like. Once you live boot it, you'll be able to get access to all of the tools. If you aren't live booting and installing, it will be the same sort of story. You'll be able to get access to all of the tools here, and you won't have to worry about anything else from that point on. Once you've got this installed, you're good to go. So what we'll do is in the next video, we'll take a look at how we can set up an Ubuntu machine, and we'll take a look at some of the things that we might want to install on it to be able to work with it. So we're going to discuss a little bit about some of the vulnerable web applications that we're going to use throughout these videos. I will post this code online so that you have access to it. It's just some very good sample code that we can work with to be able to practice and try to compromise a vulnerable web application with things like SQL injections or command injections, for instance. Now, a lot of these things will require a relatively specific setup. Essentially, you're going to want to have a Linux machine that runs Apache, or maybe a Windows machine that runs XAMPP or something like that. It's relatively simple to set up that sort of thing. If you're working on a Linux machine, all you really need to do is just do sudo apt install Apache 2. Once you do that, you'll end up with this var www html folder, and you just put any sort of files inside of there, and you'll be able to access them through the web browser. You'll just go to something like localhost, and it will display out the directories that you have, and you'll be able to access those files without any sort of problem. What I want to show you is I want to just give you a bit of an example of the type of vulnerable applications that we'll be working with. Specifically, we're going to have a login page that has a vulnerable SQL injection, and we're also going to work with, I've got another command injection one here that's nice and simple. So I want to show you these just so that you have a decent idea of what sort of stuff exists and how it can be set up. So when we're working with these sort of things, we have a login page. That's our first thing that's available. And essentially, the way this login page works is it includes a config file, which has the database username and password and the database table that you want to be able to connect to. And essentially, we have this simple HTML form down here. And it's essentially just like a post of the username and password. We come up here and we take that post result. We concatenate it to the SQL query. We run the query up against the database. We check if the count is greater than or equal to 1. If it is, we redirect them to the welcome page. Otherwise, we say that the username and password is invalid. This is obviously vulnerable to SQL injection because the username and password are thrown directly into the query rather than being parameterized. So this being the case, you can input any sort of SQL syntax into this and be able to compromise the web app without any sort of problems. So this is an example of the first type of vulnerable web app that we're going to be working with. The second type is very similar, which is a command injection. The command injection works very similarly. It basically just has a simple post from an HTML form with value IP. It comes in here, it takes the post value. We aren't actually going to want this regular expression matching. This is actually a way to fix the problem. So we really don't want that. We just want this system command, the system ping IP. So what this will do is it will concatenate, again, the IP to the ping command. Obviously, this is insecure because it's going to execute everything the user inputs as a command, meaning that it's ripe for command injection. You'll see that I'll use a little bit of DVWA as well. And this is possible to install on your computers too. It's just simply a matter of cloning the Git repo and placing it into that same directory. And yeah, you'll be able to access that as well. These would be the main things that you would be able to use to be able to compromise web applications. They're good to practice with because they don't require any sort of authentication. You can just place them onto your server and run them, and you don't have any sort of problems. So these are quite nice to be able to use rather than using something like DVWA. However, both of them will work totally fine to be able to show these examples. So it's really up to preference. Again, I'll make sure that this code is available so that you're able to access it. You will have to set up a MySQL server on whatever computer you're working with, but that's the general idea. You'll have access to the code, so you should be able to run it without any sort of problems. So the first set of tools that we're going to be taking a look at in information gathering have to do with DNS analysis. The idea of DNS analysis is to be able to use DNS records that exist for a website or application and be able to resolve them to gain information about that actual web page to give us an idea of what the actual attack surface is for that web page. So some examples, some of the information that we can get off of this, the big thing that we can really get from this is we can resolve a domain name to an IP address and possibly find other servers or services that exist on the same subdomain or within the same sort of like IP range of the server that we're targeting. The other thing that we can do is find specific things such as mail servers, or perhaps look at things like the TXT records to be able to find information about what sort of services are running on the website. So I'm going to show off the 3 tools that are included with Kali Linux, and those 3 tools are inside of information gathering under DNS analysis. There's DNS enum, DNS Recon, and Fierce. Those are the 3 main tools. We'll go through them and discuss what they do well, where to use one over the other, and just sort of get an idea of what these tools are and how they can be used. A lot of them will give you very similar pieces of information. However, some of them will give you slightly different pieces of information. Some of them are better in certain situations. I'm going to be showing you how to use this against my own website so you can get an idea of what a typical live website looks like, and we'll discuss what the actual results mean. So we'll start off with DNS enum. So you'll see when we first open this up, and if you type in the command at all in command line here, so like DNS enum, you'll get the whole help file that will give you all the information about all the parameters and such that exist. I'm not going to go over these all like one by one or anything like that. I'm going to discuss a few that are useful, and from there you should be able to apply that and be able to try some of these different commands out. So if we just want to do a base scan of a web page, we're going to start by typing in DNS enum and then the domain that we want to scan. So in this case, I'm going to scan scprogramming.com. And you'll see it will start to push out some information. So what it's gotten for us so far is the host address. So you'll see it shows my domain name here, and then it shows the IP that it resolves to. This would be the IP that actually resolves to this domain name. So what happened to DNS is essentially DNS registers IP addresses to domain names. This is how when you type in a domain name, you're able to get to a specific website or server. Because what happens is when you type in that domain name, it gets looked up against the DNS server. The DNS server looks for that domain name and then returns back the IP address associated with them. So This would give us the actual IP address, which is nice because some tools look for specifically an IP address rather than a domain name. They don't want to resolve the domain name, so they ask for the actual IP address itself. This is a good initial check to get that information. We can also see the name servers that are used to get this information. So this shows us what DNS servers are actually being used to resolve our domain name. And this can give us a bit of intuition or idea of who the domain name is registered with and possibly who's hosting the domain name. As well, it will show us if a mail server is running on the domain, and this is the MX records. In this case, I don't have any webmail running on my server, so you won't see any results for MX servers. If you scan something that has a web server on it, you'll likely see that MX record appear there, and it will show you that there's a webmail service running. What happens next is it will try to zone transfer in the name server. And basically what this means is that when we do a zone transfer, we're able to sort of get to related servers in subdomains. So when we're looking for SC programming, it looks for just that one. A zone transfer would allow us to sort of branch out a bit further and look at a more broad range of IPs. Oftentimes we aren't really able to find this sort of information. A lot of DNS servers don't allow for this for various reasons, mostly security related. But it will also try to brute force its way in as well. And in this case, it tries, but it just gets us the same host record that we saw before. However, what it will give us is it will give us a net range, is what this is called, and it shows the essential range of IP addresses that the domain name exists in. So you see 155.138.130.0/24. You can see that my domain name is at 0.210. That means it's sort of between 0 and 255, right, on that last digit. So it gives us an idea of where it's registered. We could look for similar services as they would probably be registered like one after the other, so they would have similar IP addresses likely. Now, we'll also attempt to do a reverse lookup on the IP address, and this essentially just looks at things like whois to determine information about who owns the actual IP address or the domain name. In this case, I do a lot of information hiding, so it doesn't show any sort of information there, but some sites will. So this is the general idea of a basic scan. And again, we get some very good pieces of information from this. We get things like the host address and the name servers that it's running on. This tells us a bit of information about our attack surface. Now we can do other things with DNS enum as well. If we want to, for instance, stop with the reverse lookup, in this case, the reverse lookup didn't give us anything. If I don't want to do it again, I can add on a flag here to say no reverse. And if we run this again, it will do everything that it just did, just removing the perform reverse lookup on the 256 IP addresses. A few other things that we can do is we can output the results to an XML file. So if I type in -o, I can go to say output.xml, and it will output all the information into an XML file. So I'll go ahead and show you this as well. We'll just discuss a few more arguments first before we do sort of like a final one to show you what the output looks like from this. Something like -s will scrape Google to try to determine if it can find some subdomains for this specific domain that we're searching for. And we can specify how many pages we want it to scrape using the -p argument. So we can scrape, like, by default, I think it does 5 pages, but we can go for like 10 or 20 or whatever we want to do. So let's go ahead and run this with the scrape option so you can see what this does and see how it actually outputs the data there. In this case, I want to give it a number for the scrape as well. Essentially, it will look for a specific number of subdomains. By default, it would be 15, but we typically want to provide a value, so I'll just give it a value of, say, 10, for instance. So you'll see that it attempted to search the Google for subdomains, right? And in this case, it didn't find any information. So it's saying maybe Google blocks the query and you should check manually. In this case, there actually isn't any results on Google. So if you were to check manually, you wouldn't actually find anything. But this is just an example of what it would show when it's trying to scan for that information. So we'll let this continue to run and it will show the output and it will save it to wherever we're running this command from. So in this case, I'm essentially just running it in the root directory. So you see there's this output.xml file that's slowly being generated with information as we continue forward. It will slowly continue to put that information into the XML file until it's completed processing. Now, the other thing to note here is when it's brute forcing the domains, it's using this, this dictionary that exists. This is a default dictionary that exists in the directory that it posts there. We can actually go into that directory and add other DNS information into that file, just in case we want to actually add some different information or sort of, attempt to attempt to brute force specific things, we can set specific things inside of that text file to look for. So this will just take a few more minutes to process. While it's processing, we'll discuss a little bit about the other two programs that exist on here for DNS analysis and what they do differently from this one, DNS enum. So there's DNS Recon is the other one that exists on Kali Linux. It gives a lot of very similar pieces of information as DNS enum does. One of the things that it does well is it gives you the TXT records, which we'll take a look at once this is completed here. And essentially, that could tell you some information about some of the services that are actually running on the domain. So you'll see in the example when I run my web page, you'll see the Google Analytics information inside of there. So it'll show you that I'm using Google Analytics to see information about like where my website shows up on searches and that sort of thing. It's used for verification in the TXT record. So this is something that we're able to see and gain information about, right? Using that, we could potentially maybe, I don't know, send a phishing email to say, hey, I'm a part of Google Analytics. I'm here to give you a new report. Check out this email, and then they click on the link and go to a phishing site, something like that, right? So that's an example of something that we could do. So I'll show you that afterwards. Let's just take a look at DNS enum's output in the XML file. You'll see here it just sort of formats things in a bit of a cleaner way so you can easily see the information that you're looking at. That way you can sort of like collapse and expand things as required. So that's the idea of the XML output. So understanding that, let's take a look at DNS Recon and see what that can do for us. So what we'll do is go ahead and open this up here. I'm just going to minimize this other one so that it doesn't show in the background there. So with DNS Recon, the base scan is going to be done like this. We'll do DNS Recon -D. D stands for domain, scprogramming.com. When we do this, you'll see it will scan. This scan is a lot quicker than the other one because it doesn't try to brute force anything. It'll show us a lot of the same sort of information. You see it still shows us the name servers that are resolved. It still shows us our domain name and the IP address, but you see it gives us that extra TXT record that I was talking about, this Google site verification. So it shows that it actually is a Google site that's being verified, and it's something that I'm actually using for Google Analytics. So that gives you a little bit more information about the web page. Now with this, we can do similar sort of things such as searching Google. There's also options to search Bing and crt.sh. This is a certification website that will show you certificates associated with the web page. To do like Google searches, you just use -G. Bing is -B. And then for the certs, it's -K. So those are the three sort of options you have for searching for subdomains and additional information. And then aside from that, we can also just save in different formats. So I'm just going to go ahead and show you the help file so you can see what different formats are available for this. You'll see here we can save to database files. Any SQLite 3 file can save the records. We can save to XML formats. We can save to CSVs, JSONs as well. So you see we have a bit more diversity in the way that we can store the information as well. And we can also discuss which type of enumeration we want to do. So we can look at standard ones, which will look at these sort of records here, the like NS name server, right? The A records, the MX records, the SRV records. But then you can also do other ones to do like reverse lookups and brute forces and some of the similar stuff that we were working with our previous example. So this sort of just shows you the different types of scans that exist. By default, it will default to STD, which will be the standard one. So that will just give us some of the standard information that exists. So this gives you a little bit more customization in terms of what you want to actually show. It gives you a few more options to actually save the data. But in general, it's going to give us very similar information, which is why it's grouped together with the DNS enum. And then the third tool that is typically used for DNS analysis is known as Fierce. So essentially what Fierce does is it again allows you to scan DNS servers. It does it very similar to the other two tools, except it's a bit more lightweight. So it runs a little bit faster, a little bit less space it takes up. The other unique thing about this one is it allows you to scan a range. So you see that there's this -range option, which allows you to specify a range of IPs to scan rather than just scanning a single domain name. So you could do a bit more with this, such as resolving IPs back to domain names or scanning different ranges of IPs. So that's a good example of how we can use Fierce different from the other two tools. So if we want to just do like a simple DNS scan, we can do like Fierce. We do -DNS, and I'll type in my domain again. And this will just give you an idea of what sort of information gets outputted. You can see we get the DNS servers for it. It attempts the zone transfers like before, and then it will try a whole bunch of different brute forcing to try to get into it. Now, these tests are going to take a really long time. I'm not going to show you these because in general, they're probably all going to fail anyways. But if you do wait, it will essentially just show you the results of these tests to see if any of them succeeded. Again, just trying to do zone transfers similar to what DNS enum was doing. So again, you can take a look at some of these fields and arguments to see what sort of things we're actually able to do. In general, again, this is very lightweight, so most of the stuff really just works with base DNS scans. So this would be the example of the different DNS analysis tools that exist inside of Kali Linux that we can use. Again, these are great for information gathering and learning things about your target to sort of get an understanding of the attack surface before you commit to any sort of attacks. Another detail of a target that we can gather information about is whether or not it's using an IPS or an IDS. An IPS is an intrusion prevention system and an IDS is an intrusion detection system. The differences are essentially an IPS will prevent somebody from being able to commit an attack against the actual target. It will look for specific signifiers that are typical for attacks and actually prevent them from happening. Whereas an intrusion detection system will simply flag that an intrusion has likely occurred based on some characteristics of the interaction with the actual web application itself. So there are a few tools that are built into Kali Linux that allow us to detect this information. We can find these under the information gathering tools under IDS and IPS detection. There's two tools that we'll talk about here. There's LBD and there's WAF-WOOF. LBD is essentially a way of detecting load balancing on the actual server itself. Essentially, what load balancing is when you send requests to a server, they get routed to a backend server, which is going to take care of the actual request itself. Most large applications are going to have multiple different backend servers that will be able to handle these sort of requests. When we have load balancing, it essentially takes all the requests that it gets and balances them between all the backend servers that can handle the requests. This essentially allows the server to be able to prevent any sort of DDoS attacks. So if someone attempts a denial of service, it will be able to route all the requests to different backend servers and be able to help mitigate that attack. So when we're looking for load balancing detectors, we're trying to determine if load balancing exists in a specific location on the server to determine if we can easily do like a denial of service attack or anything like that. The usage for this command is fairly simple. We just type in LBD and then the domain that we want to check. So again, I'll do my domain here just as an example. You'll see that it looks for DNS load balancing first and then HTTP load balancing. So DNS load balancing is essentially a way of load balancing on the DNS server end, and then it will check for HTTP, so actual like checking for HTTP requests to see if they're load balanced. And as you can see, there are a few different instances here. We actually get some load balancing found. So DNS load balancing isn't found on the server. However, when we check for HTTP load balancing, we actually do find something that looks to match some sort of HTTP load balancing. And it will show you the method of load balancing that's used so that you can better target attacks for this web app to be able to determine which ones will be effective, which ones won't be effective, and that sort of information. Now we can specifically target towards a specific port and say whether to use HTTPS or not through different arguments. So for instance, I could have done this over, say, port 8080, for instance. I could have done it through HTTPS by adding HTTPS after the port number. So we were able to do both of those pieces of information as well. So you see here, I'm not really accepting any sort of requests over 8080. So we're not going to get any sort of useful information out of that. However, if I was opening to requests over 8080, we would see some sort of detection for load balancing or potentially not, depending on what's being done on that port. So the load balance detection is fairly simple, and again, it just allows us to determine how effective a DDoS attack will be if we want to commit one up against the server, just by checking if load balancing exists. So the technical tool that we're going to take a look at here is called WAF-WOOF. What WAF-WOOF does is it looks for web application firewalls. What web application firewalls are is they're essentially a firewall that's an intrusion prevention system, and it sits between the server and the user. When a user sends a request, it goes to the firewall. The firewall uses rules to determine if it's a valid request and then sends it to the server if it is, otherwise it drops the packets. Now, the way that we can detect this using WAF-WOOF is essentially it will try a whole bunch of typical things that get filtered and determine if WAF exists on the actual web app. So again, I'll show you this on my server first. So we'll say WAF woof, and then we'll type in the domain name that we're targeting. You'll see in this case it scans through and it says there's likely some sort of WAF or some sort of security solution that exists because it got a response that differs from what it was expecting. You'll see though, if we try it with something that definitely has one, say Kali.org, which is the Kali Linux website, you'll see it tells me the exact WAF that it's behind. And this can again help you target specifically, well, now we know it's behind that specific web application firewall, so then we know what kind of attacks will typically work, which kind of attacks won't work, and it gives us that sort of information so that we can better target our attacks. And of course, there are a few different commands that are helpful for us. One that's particularly helpful is this find all command. What this will do is it will continue testing even once it finds a web application firewall in case that there are multiple ones sitting on the server. We could have more than one running, which could stop more than one different type of attack. So we want to be able to detect all of the web application firewalls. So this could be a good option. Aside from this, you just have your typical sort of options. You can make it verbose to give it a bit more information. We can test against a specific firewall. And we can also list all the firewalls that we're able to test. So I'll just show you that command as well. If I type in -L, you'll see it lists all the firewalls that it is able to test against successfully. So you can see it will detect all of these different firewalls. If we have a suspicion that one of these firewalls is running on a system, we can target that specific one and determine if it is running or not. The most effective way really to use this is to just run it with the URL and see what pops up. You can try running all as well if you do see something pop up to determine if it really is the only thing that's running or if there is more that's running. So this gives you an idea of ways that we can do intrusion detection and intrusion prevention system recognition using some tools in Kali Linux. So again, the LBD tool as well as the WAF woof tool are good tools to be able to scan a URL to determine, is there anything that's going to stop us from committing an attack? What is that thing? And then better format our attack to be able to get around those firewalls. The purpose of live host detection and analysis is to be able to determine if a host is currently active on a network that we're targeting, as well as determining what kind of data we're able to send to that host. So what packets it will accept, what ports it's listening on, this sort of general information. Kali allows for a few different tools that come pre-installed that you're able to work with to be able to determine whether a host is listening on specific ports on specific protocols. So you can find these inside of the information gathering section under live host identification, and we'll go over most of these here. The first one that's available is called AR ping. Now to show off these, I've got two virtual machines running. I've got an Ubuntu machine here and I've got a Windows 7 machine here. They're both running on my network, so I'm able to target them to try out these attacks. So with AR ping, the idea is that we're able to ping over the ARP protocol. Now the ARP protocol sits on layer 2 of the network, and essentially what it does is it helps resolve IPs and MAC addresses for anything that's on the same network as you. What this allows you to do is it allows you to determine if something is listening on the actual network that you're on through ARP. It'll also allow you to resolve information such as MAC addresses from the IPs. So we can ping an IP through here and it will show us the MAC address that corresponds with it, show us that it's responding, that sort of information here. So to give you an example, I can type in AR ping. I'm going to ping my Windows machine here. We'll just take a look at the IP here, 10.115.97.129. So we use that exact one, 10.120 or 115. 0.97.129. And what you'll see here is it will show that the device is responding, and it will show the MAC address of it here. It'll also show how much time it took for it to respond. So it gives you all the typical information of a ping, just over the ARP instead of the ICMP protocol. There are a few adjustments that we can make with this, of course. We can change the number of pings that are happening using the -C. So we can say -C5, for instance, and that will send 5 pings. So we can lower the amount of pings if we don't want to do a consistent one, just to quickly check if it responds or not. So again, this works really nicely when you're on a local network and you want to check specific devices responding over the ARP protocol. The next tool that's available to us we'll take a look at here is going to be fping. Now, fping is essentially just like a sort of extension of the ping protocol. And the main distinguishing feature between this and the regular ping is that this allows you to ping multiple IPs at once rather than just pinging one IP. So, for instance, again, I have two devices on here, so I can do fping. And what I can do is I can put in the first address and the second address, and it will ping both of them to tell me if they're alive. So let's take a look at that now. The two IPs that I have is 10.115, 97.129, and then we have 10.115.97.194. So you see when we do this, it simply tells us both of them are alive. So you see it pings both of them, tells us that they're both responding to the ping request. We can also add in again a count like before, -c, and then we can give it, say, 5, and it will send continuous packets. I put it right there. I should have put a space between these. So you'll see it will send it through multiple times to tell us if they've received or lost all of the packets that we're sending. So this is the idea of fping. It's basically the same idea as a ping request. However, you can send it to multiple IPs rather than just one IP. The next tool that's available here would be hping3. hping3 is fairly complex, so we're just going to go over the general idea of what's available inside of it. Essentially, what this does is it sort of gives us all of the options that we would want. We can send pings over the IP protocol, we can send them over ICMP, we can send them over UDP and TCP. So this allows us to check if it's responding on a specific port or responding through specific protocols such as TCP and UDP. If we're going to work with TCP or UDP, though, there are a few other tools that are a little bit more intuitive and helpful. This one is a good option if you want to get a bit more customization. However, we're going to focus more on the next tool, which is mass scan. And mass scan allows us to check TCP ports rather easily. The idea of mass scan is essentially it will take in an IP as well as a port or range of ports or list of ports, and it will tell you if the target is listening on those ports. So for instance, I can do a mass scan of one of the IPs that we had before. So let's go for one of these, let's say 127 or 115.97, 129. So we're going to scan this for specific ports. I'm going to pick ports that I know are open on my device. So for instance, 135 is open, so we'll go -P 135, for instance. So this will scan specifically the port 135 and tell us if it's available or not. So you'll see here it discovered an open port. That means that it's listening on that port. Now, if I want to check a range of IPs, I can do that as well. I can say like 135-137, or let's say 139, why not? And it will scan between 135 to 137 and tell you all of the things on that range that are currently available and open. So as you can see, there's two ports there, 135 and 139. If we want to scan a whole device to determine if all of its ports are open, we can go between like 1 and 65564, whatever the max port number is, and it will scan all of those and tell you if they're available. So this is a really good way to check if a port is open and listening on a device, which is something that we really want to be able to do because it can give us hints about what services might be running, what kind of protocols might be running, and what kind of attacks we might be able to send over these ports. So this gives you an idea of how we can do live host identification and how we can essentially determine if hosts are listening on specific ports to be able to understand which ports we can attack over and what protocols we can attack over. So we're going to take a look at an information gathering tool called Nmap. Nmap is an extremely popular tool because it has a huge amount of commands and power included inside of it. It can actually do a lot of what we talked about in the previous videos, all with one tool. So that's typically why Nmap is so popular. It's a great way to be able to gather information about your attack surface without having to utilize all these different tools and sort of aggregate all the results together. So Nmap is accessed through the command line, as with most of the other tools that we've taken a look at. You'll see that there's a lot of different options that are available here. We're going to discuss a whole bunch of them, as many of them as we possibly can, mostly the ones that are most useful, and sort of give you an example, an idea of when they're useful and what they do and when you'd want to use them. One of the big things is talking about whether an attack is loud or quiet. Loud attacks are ones that are easily picked up by a system admin checking the logs or a firewall or something like that. And quiet attacks are a bit less conspicuous. They're a bit easier to get away with. They don't get captured as easily. So to start off, if we're doing a simple scan of something, we can say nmap, and then we're going to provide a set of flags. And I'll explain these flags once I type them out here. So the first flags that we'll do is ss. And then we put in the URL. In this case, I'm going to use one called scanme.nmap.org. This is actually a public domain created by the creators of Nmap that can be used to test your scanning for Nmap. I also have a few servers that are running on my network that I'm going to test it with, but this is one that you can easily test with to see what will happen. So let's try running this command and see what we get as the output. As you can see, what this tells us is it tells us what ports are currently open and what services are running on those ports. So this gives you information about what is available in terms of what we're able to send packets to, what's running on those ports that are open, and what protocols are being used with them. The important point to note here is that ss command. What the ss flag is essentially telling it is it's telling us to do what's called a SYNAC, or a SYN port scan, as it's commonly referred to. What this essentially does is it sends an SYN packet to the port that it's scanning for to tell it that it wants to set up a TCP connection. From there, it just stops and doesn't reply again, and the connection is dropped. Essentially, once it gets the response back, it knows that that port is open and accepting connections, so it's able to log that detail and then just stop. This is great because it's a very quiet attack. When we attempt to set up a connection with the TCP port, it doesn't actually complete the connection request, meaning that less information is logged about our attempt. Now, we can try to do a full connection using a different flag, and that different flag would be ST. And you'll see when we run this, we're going to get very similar results. The main difference is that this completes a complete connection of the TCP protocol, so it goes through the whole three-way handshake rather than just testing one and getting a response back. This tells us a different set of information. It tells us that we're able to actually actively make a connection to these ports rather than just being able to send a single packet. You might be able to send that single sign packet, get a request back, but then not necessarily complete the whole handshake. Whereas in this case, we've completed the whole handshake, which means that we know that we can, do a little bit more with this. This is, however, a louder attack because once we complete a connection, there's a lot more detail about the person scanning being logged. So in turn, someone looking at the logs could learn a bit more about us just through that actual scan being completed. And then there is another type of TCP-related scan that we can use that we'll take a look at here. And this one is SA. And what this is it's a TCP ACK scan. What this does is it simply sends a request to the port, and it just checks if it gets a request back. It doesn't actually try to set up a connection or anything like that. It just checks if the response is actually filtered by a firewall or something like that. So you can see here, all of the ports were reachable without a firewall intercepting or stopping our connection. So that tells us information about, what sort of ports we can access in general, not necessarily just ones that are listening with services. Now, these are all TCP type of requests. We can also take a look at UDP requests. For the UDP requests, I'm going to use one of my servers, and I've just copied the IP here so that I don't have to keep typing it out. So what we're going to do here is we're going to go to TCP, and then we'll do -su, and then again, we'll just put in the IP that we're working with. When we do this, it's going to check all the UDP ports instead of the TCP ports to see what kind of services are running on them. They'll both be running different services potentially. And the reason why I'm running this up against my server is because when I run against the scanme.nmap.org, it takes an extremely long time. So I'm choosing to do this because it's a little bit less time, so it's a little bit easier to see the results immediately. You'll see in this case we have one UDP port that's open, which is 137, which is running the NetBIOS NS. So you can see it gives us very similar pieces of information, just two different protocols. Now, there's a lot more that Nmap can do compared to just scanning for open ports and seeing what services exist on them. And some of these features are the very interesting ones that tell us some very valuable information about our target systems. So this is what we'll take a look at next. So in terms of like port scanning, just to give us a little bit more context, there are certain arguments that we can do to specify specific ports if we don't want to scan like the whole system, all of the ports, that sort of idea. So for instance, if we're doing PN, this will specify just to do a port scan. So this means it will only scan the ports. You'll see that when we scan based on UDP, we got very different sets of information, and comparatively to this, we'll get a very different set of information as well. You'll see that we get all the information about the TCP ports that are open on this actual device. So you see it scans through all of the ports and returns back that information to us. In terms of specifying a port range or a specific port, we can do just -p like this. And what we can do is we can say scan, let's say 135, because we know that one's open. And you'll see it only scans port 135. So again, this is just the idea of a loud versus a quiet attack. If you scan every single port, it's going to look suspicious. If you scan just a specific port that you're targeting, it looks a little bit less conspicuous. So this is something to keep in mind when you're scanning. You can scan specific ports or ranges of ports rather than just scanning the whole set of ports. Now, in contrast to this idea, we can do some other scans that will tell us a whole lot of information about the system that are very loud. So these are the kind of scans that are a little bit dangerous in the sense that they're going to reveal a lot of information about you scanning the system, but in turn they're going to give you a lot of information. So if someone's actively looking for attackers, this might come up as a bit of a red flag, but if they aren't, then you're going to gain a lot of information that's very valuable and useful. So the first thing that we can take a look at is an operating system detection. If I put -o as my flag, it will attempt to detect the operating system that my server is running. So what those will do is essentially just send a whole bunch of packets. You'll see in this case it gives me the ports that were open again. And then it looks through and tries to do the OSS scan, and it sees that I'm running maybe Windows 7 or 8 or Vista or 2008. And it gives me some information about the CPE and the OS details and the distance in terms of network hops that this is from us. Now, this detection is quite good. I am running Windows 7 on this device, so it did detect Windows 7 as one of the possibilities, but it wasn't quite sure which one it was. But this at least gives us an idea that we're likely dealing with Microsoft Windows. And at most, it could be Windows 8, but it could be older versions as well. So this gives us a little bit more information. Now, if we want to be a little bit more aggressive, we can use the aggressive flag, which is -a. What this will do is it will do what's called an aggressive scan. It will aggregate as much information as it possibly can about the operating system, about the ports. It will try to gather everything that it possibly can in the most aggressive way possible. It won't try to be quiet about it at all. It will just get in there and start trying everything and see what it figures out. So we'll give this a minute to run, and then we'll take a look at the actual results that it gives us. So you'll see that essentially a lot of the information that we're getting from Nmap is extremely valuable for planning our attacks. It will tell us basically everything we need to know about our targets. We can understand the ports, the services, the states of the ports. We can get MAC addresses. We're getting operating systems. This is really just giving us everything that we got before in the previous videos, just even more information than that, including that information, right? So you can see why Nmap is such a popular tool. It gives us a lot of very valuable pieces of information. In general, when we're working with Nmap, the main things that we want to be able to do is distinguish the operating system and the ports. So those are the two main things that we're really interested in doing. So here's the results of our aggressive scan. You can see that when we're looking at the services compared to the actual the previous attempts, so you'll see here like this one says 135 over TCP is open and it's in MSRPC. You'll see that this actually gives us like versions and pieces of information, right? So it tells us that this is actually Microsoft Windows RPC. It tells us that this is from Windows 7 Ultimate Service Pack 1. So at this point, we know exactly what operating system we're working with. There's no question about it anymore. And you'll see as we move down here, it still gives us that same operating system information that tells us what we could possibly be running. Of course, from here, we've already exposed that information, so we know exactly what we're running. So there's no question about it anymore. Now, we also get some other pieces of information that are relatively interesting. One piece of information that's interesting here is the clock skew. The clock skew tells us how different the system clock is compared to our clock on our computer. So it tells us some information about like how many days, hours, minutes is different between us and the device. It can give us a bit of insight about where the device might be located, for instance. So that's sort of what we can get out of that. And of course, again, it tells us the SMB OS discovery. So it tells us what sort of information we have available in terms of the computer name, in terms of the operating system, in terms of the work group, the system time. It tells us all this information about the security, all the different modes that exist, the SMB time. Just to note, of course, the time and date on this virtual machine is a little bit wrong, and that's why you're seeing such a differential and skew in the clock, is because the actual date and time is wrong in the machine, but it gives you a good idea of what kind of information you might see if the time and dates are different. And then one final thing it gives us is a trace route. It shows us how many hops we had to make to get to that device and how much time it took. So in this case, this device is on my local machine, so it takes no real hops to get there. We just get straight there. But if we were somewhere else, it could show us the path that we take to get to that location. And this is the general idea that we're able to get from Nmap. We're able to get a whole lot of information about our attack surfaces just with a few simple commands. So if you're looking to use Nmap, I would suggest that using it for scanning ports is a really good way to use it, and using it to get operating systems is really great too. Just keep in mind the differences between, again, the loud and quiet attacks, and know what's appropriate for your target. If your target is something that you suspect is going to be monitoring for these kind of attacks, then using a loud attack is probably not a great idea. But if you use a quiet attack, you'll get a little bit less information, but you'll be a bit more conspicuous. You won't have to worry about getting logged as much as if you were doing a loud attack. So this is the idea of Nmap, and you can use it for any sort of hosts, either virtual machines running on your computer. You can use it for servers running somewhere, web pages. It will work with pretty well anything that works in a server turbo architecture over the network. So in this video, we're going to be taking a look at OSINT, or open source intelligence. This is essentially the methodology of gathering information that's publicly available about a person or a domain or an email or a handle or really anything associated that we want to gain information about. There are a lot of different ways to do this. Of course, Google searching and just like running through different social media networks and different search engines is something that we're able to do ourselves to be able to gather this information. However, there are built-in tools in Kali Linux that allow us to gather this information as well. One of which is called Maltego, which we'll be going over now, as well as the Harvester, which is another one that is used to be able to gather this sort of information. The way that we access these is through the Start menu. We can go to Information Gathering, OSINT Analysis, and then Maltego will be the first one that we'll take a look at here. Inside of Maltego, we can go ahead and create a new graph just by typing or clicking on this icon here. Once we do this, we're able to create a new what's called a graph of information about whatever we're targeting. So for instance, the first thing that we'll do is we'll target a specific domain, and it will essentially show us the way that this domain is associated with different things and sort of keep going down the levels until we get to the last sort of endpoints. So as an example, I'm going to grab a domain here from the left-hand side and click and drag it into the graph. I'm going to double click on it and I can type in whatever URL I want here now. So as an example, let's do kali.org, which is the Kali Linux distribution website. When I press OK here, I can right click and there's a number of different transformations that exist. These transformations are essentially different queries that we can run to determine information about the kali.org domain. Usually there's information like DNS servers, email addresses, files and documents, domain owners. We can run all transformations that will give us all the information that possibly exists just by hitting the Run All button. When we do this, it will load all the information and then display it to us here. So you can see here there's a ton of information that's available to us from the Kali Linux domain. When we click on something here, so for instance, if I click on this RDS here, you'll see that we'll see the actual information on the right-hand side that's associated with it. So each thing that we click on, we can see information about it as we zoom in and out. So when we get to these endpoints here, we can click on these and see that there are typically people associated with things. It'll try to map people to the domains. It'll try to map people to the email addresses. It'll try to map people to devices and that sort of idea. So you can see we really get a lot of different information from this actual query itself. We can understand what DNS servers exist, what different servers in general exist on the domain, what email addresses are associated with it, what users or people are associated with it. And there's a lot of different value that can come out of this. Different phone numbers, for instance, that are associated with it. Even external sort of addresses that are used for support, for instance, can be found from this. So the reason why these things might be valuable, there's a few different reasons, right? For one, we're getting a really good picture of the things that exist in terms of servers that are running on the back end or DNS information, which is something that we've tried to gather in the past as well. It gives us a lot of information about the actual attack surface. It gives us emails that are associated with Kali, which could be useful for things like phishing attacks. We could, for instance, email people posing as one of these email addresses, or find a target that we can email to try to convince them to do something, for instance. So those are the sort of things that you can do. And in addition, it gives you things like people's full names and such. We can look up these people then and determine information about them. So a lot of this is very helpful and useful information. So this would be an example of how you can resolve a domain through Maltego. We could do more things than just domains. For instance, let me go ahead and start a new graph here. And there's a few other ones here that are very interesting and useful. Let's take a look here. Alias is one that's relatively useful. We can look up an alias as in like a username that somebody uses, and then we can determine any services that are registered with that username, therefore telling us where they might potentially be registering their users. So we can really pick any sort of username here. For instance, let's say I'll just put my full name here, Scott Cosentino. When I go to resolve this, you'll see that again I get a whole bunch of different information that exists. So to social accounts is probably the best one to do. It'll give you sort of all of the general social media accounts through namecheck.com. I think it's namecheck.com. And this essentially just queries all the social media domains to see if a username is available or taken. So let's run this. And you'll see it will run it and it will eventually return back where this name is registered. You'll see it was registered to, we see the domains here, Facebook. This one's Pinterest. This one's Twitter, PayPal, Bitbucket, GitHub, Flipboard, and SlideShare. So all of these have a user registered with my full name. That could potentially be me. It could be somebody else with a similar name who took my username. But this gives us a bit of a picture of where this user exists. So again, if we're looking to target a specific user, we could figure out what services they use. Say, hey, we're looking at your Facebook account with this username. Click on this link to reset the password, and that will give us a little bit of credibility. A similar sort of idea exists for email addresses. So we could put in email addresses, for instance. I'll put in one of my email addresses here. So using this email address, again, we can do different transformations like related email addresses. We'll try all transformations and see what it gives us. You'll see in this case, it just maps to gmail.com and says that the email exists. This might seem like trivial information, but it is fairly useful. You know, at least tells us that the email actually exists, that it's a valid email and it's with Gmail. We might not always know the domain that something's associated with, so this is a good way to be able to figure out that information. So there's a lot of different information inside of here that's very helpful for us, and you're able to go through and try out some of these on your own. For now, I'm going to close out of Maltego and we'll take a look at another application that exists on here called the Harvester, which gives us sort of similar information. And again, this is under OS int and it's called the Harvester. So you see that the Harvester has very similar information that works specifically with domains. So we could take a domain and we can do port scans on it, sort of similar to Nessus. But we can also scan for specific like searches, say like Baidu or Bing or Google. Let me give you an example. So I can say the Harvester, and we'll give it a domain that's my domain. And let's go ahead and we're going to search it on Google. You'll see what this will do is it will search a certain number of results from Google. The number of results is customizable by the limit parameter, this -l or -limit. And essentially it will default to 500 and it will search all of Google to see if there are any emails associated, any IPs associated, any hosts associated. Mine isn't very interesting. Oh, mostly because I spelt it wrong. So let's spell it right and try that again. And then after this, I'll show you one with cali.org because it's got a bit more interesting information associated with it. So we'll just wait for this to finish here so you can see exactly what the results look like. And as you can see here in this case, it just found the one host and resolved it to an IP address sort of similar to what our DNS resolutions were doing. Now, if I look at something like cali.org, for instance, you'll see that I'll get a lot more interesting information. It will actually associate it with some email addresses, with some hosts, very similar to the information that Maltego is giving us, but not quite as in-depth, I would say, as Maltego, but a bit quicker. It's mostly free, whereas Maltego has licensing involved with it. So this is a good one to use for sort of like a free, quick alternative. You'll see it finds a whole bunch of associated hosts. It finds a whole bunch of emails that are associated with it. So this is really good information. So just going back to the help page here, taking a look at the different sources that exist. Some of the ones that might be of interest are things like LinkedIn, for instance. If I search up Kali Linux on LinkedIn, I might be able to find people who are associated with Kali, who work there, who work with them, who do things involving it. So that could be very useful information for us to have. And then again, the rest of these are just different search engines, right? Like Bing and DuckDuckGo. You can take a look at GitHub to see if they have any code associated with them. Google, of course. Yahoo, right? VirusTotal will tell us if any viruses are associated with the domain or anything like that. So yeah, just really a whole bunch of different sources that we can look up basic information from. So this is a really good alternative if you just want a quick and simple search on a domain of some sort. The Harvester will work really well for us. So this gives you an idea of the two different types of open source intelligence tools that are existing in Kali Linux. Again, these give us a good ability to sort of expand our attack surface and understand things that are associated with the service that we're attempting to attack. We're going to be taking a look at a tool that's called enum for Linux. And what this is it essentially an enumerator for the SMB protocol. The SMB protocol is a special type of protocol that allows you to gather information about a server, typically a Windows server, and it will gather information such as printers that are available, network shares, password policies, the general sort of Windows server information that might exist on a device. So I've got a Windows machine here, and we're going to attempt to scan it using enum for Linux and take a look at what the results look like. So to start, we can access enum for Linux through the Start menu. Go to Information Gathering. It's under SMB Analysis. It's called enum for Linux. When we open it up here, you'll see that we have a whole bunch of different options, and we'll discuss some of those options as we go through. For now, let's just do a simple basic scan and see what sort of information we get. So to do a basic scan, we're just going to type in the command name and then the IP address. And then we can hit enter, and you'll see we'll instantly get a whole bunch of different results that are relevant to this scan. So some of the results that we get out of this, we get information about some of the known users that exist on the device. We get information about the domain or work group that the device is on. We're going to get information about the NB stats, so discussing like information like the file servers, the workstation, the work groups, that sort of information. It will check for sessions. It will check for SID information. It will try to get operating system information. It will try to find users. It will try to find network shares that exist. It will try to find the password policy. It will try to find the groups, the users that exist, as well as the printer information. Now, all of this information is extremely valuable to have if we're able to access it. The only trouble is that sometimes SMB requires authentication, and by default it requires authentication, so oftentimes a lot of these results might not return with anything. But if we can get information like the password policy, for instance, we can easily attempt to brute force accounts, knowing what kind of password they likely have set up. Share enumeration will tell us what sort of content might exist on the actual device itself. Again, OS information is really nice to have to determine information about the operating system. Things like the work group could be interesting because when we log onto a device, oftentimes we might have to provide a work group or domain. So knowing the domain that the device is on will tell us some information about how we log onto the device itself. So this is the general sort of basic information that we can get out of this command. Let's go back to the help quickly here and take a look at some of the arguments that exist here. So you'll see a lot of this information in the options we got by default running the application. So things like the user list and the share list and the password policy information, it attempted to gather that automatically when we ran it, just like a general command. However, what I want to show you is that if we run it with those specific arguments, we'll just get that information back. So for instance, if I say -p for the password policy, you'll see in this case it gives us the password information as well as some other generic information, but it doesn't give us all the other things that we got in the previous report. So the reason why we might want to do this is because maybe we're looking for a very specific piece of information. Scanning the whole server for all of the information is going to be loud. Scanning it for one piece of information will be a bit quieter. So a few other things to note here. If we happen to have a user that exists on this server, we can provide the username and password for it, and then we might be able to get authenticated and then in turn gather a lot more information. This is a bit more of an advanced sort of attack or scan that we can do. If we already have access to the server, it's probably something that we can just log on and see. However, it could be easier to run this scan to get that information when required. So in general, most of these arguments will be looking at things that are just like limiting the scope of the search rather than broadening the scope of the search. So you'll see a lot of these are different options like the operating system information, the printer information. So really, we've already seen what the information can give us. This just shows us that we can limit our search to just those values. And this would be the sort of things that you could do with enum for Linux. So it's a good way to gather general information about Windows servers, a bit more general than a lot of the other applications that we've talked about so far. This gives you a bit more of a specific view of what that server is actually utilizing and the information about the users and how they log on and what they can access. We're going to take a look at another information gathering tool called Dimitri. Dimitri is a relatively powerful tool that allows us to scan an IP or a web host to tell us a variety of different pieces of information, mostly relating to the ports that are open on the device and what services are running on those ports. You'll see that the information is a bit more detailed than the Nmap scans that we were doing before, so it allows us to get relatively quick information on the ports that we're working with on these servers. So to get to it, we're going to go into information gathering, and right here you'll see Dimitri. So Dimitri has a number of different options that are available to it. We'll go ahead and run the sort of default setup right now. The default setup would be to do Dimitri-I if you're giving it an IP address and -W if you're giving it a domain name. So I'm going to go ahead and give it my domain name here, and let's go ahead and see the information that gets pulled up. You'll see here a lot of the information here is stuff that's gathered through tools such as Whois, and those sort of tools that will show who registered a domain, what information the domain is registered under, that sort of information. So you can see here like the domain name, who it's registered with, for instance. You'll see like the name servers, you'll see contact emails, you'll see expiry dates of the domain. That's the general sort of information that you're going to see here. That sort of information sometimes will expose to us very useful stuff, such as emails and phone numbers. Those are people that we could potentially call to try to get information out of, or email to try to trick them into clicking a link, that sort of information. So this can be relatively helpful to look at. Aside from this, Dimitri will give us a couple of other tools that are helpful for us. Netcraft is a specific way of scanning a host that sometimes it aggregates some different information from the Whois scans or other scans that we've been doing so far. We won't take a look at this one right now because it doesn't really show information for my domain, and in general, most of the time you can get that information through other tools or through other options in Dimitri. So one other thing that we can take a look at is things like subdomains and emails. So we can go ahead and search for subdomains using the -s argument. This will search through Google and Alta Vista in order to find any subdomains that might exist. In this case, there are none, so it doesn't return any values. Same sort of idea with emails. It will search for any like @scprogramming.com email addresses, typically through Google. And again, it won't find any because I don't have any of those email addresses, but if it did, it would just display them onto the screen. One other interesting thing that we can do, so we can do port scans, which were fairly similar to like the Nmap scans that we were doing before. It will show us what ports are open and listening on the server. So we'll just give this a few minutes to do a scan so you can see the information. By default, this will scan all ports, so it will give you all the information related to a specific server. If you want to be able to target specific ports, typically Dimitri isn't really the best thing to use for that. You would want to use something like Nmap for that sort of idea, but Dimitri will give you a good sort of like overall scan of the information. In general, I don't really like using Dimitri as a port scanner as much. I prefer to use Nmap. It's a little bit faster. But the nice parts about Dimitri is that it's able to do it sort of in one quick command, and you'll see it gives us very similar information. So let's say, for instance, port 22 over TCP is open. So it will give us that same sort of information. And similarly, we can look for filtered ports using the -f argument. This will just go through all the ports and enumerate whether the request is filtered or whether it's accepted. So you see like ports 1, 2, 3, they're all filtered. Once we get down to like things like 22, you're going to see that they aren't necessarily filtered. They're going to be probably open or listening for a connection. So this will just sort of give us an idea of what's filtered, what's available, what has a service running on it. And you'll see when we use the other argument -b, we'll actually get information about what services are running on those ports. So I'm just going to let this run until we sort of reach the 22 point, so you can see exactly what it shows when we get to a port that's actually open. Of course, all of these ones are filtered because they don't have any services actually running on them. They're not really common ports, so we don't expect to see anything running on them. But you'll see 22 shows open instead of filtered. So the last argument that I want to show you on here is the -b argument, which shows the banner received from the scan port. Now, oftentimes this can give you some pretty interesting information about the service that's actually running. When we did this through things like Nmap, we would see the service as something very generic. So for instance, on port 22, we have typically SSH, right? And it would say, SSH is running. This will actually check for the banner that gets returned back to it, which will show you a bit more specific information. So we'll show things like Open SSH version 7.1, for instance, is running on this port. So it'll give you very specific information of what's running, which gives us really good idea of how we can attack, because we'll know the version number of the service that's actually running, which sometimes you don't get from other scanners. Sometimes you do. Dimitri is typically quite good for that sort of information. You'll see here SSH 2.0, OpenSSH 7.6 P1, Ubuntu. So again, this exposes to us the operating system, the actual service that's running, and what version the service is running on. So overall, Dimitri is a great sort of general scanner that works very well for determining what services are running on ports and being able to do a full scan of the ports on a domain name without too much work in terms of like generating out long commands. Nmap tends to be a bit longer commands, there's a bit more options. Dimitri is just sort of gives you the general options. You can save it to an output file, and you can scan and you'll get your information. So it's fairly easy to use, which is a good advantage of it.
The tool Recon NG is a good all-around scanning tool that can be used to gather information about hosts and servers. The idea of it is essentially it has a marketplace of plugins and utilities and tools that can be installed through the application, which will allow you to have sort of all your tools in one place, be able to install whatever tools you want to be able to work with, and be able to use those tools within Recon NG. To find Recon NG, we go into the Start menu, and under Information Gathering, there'll be the option Recon NG. When it first loads up, we'll see a screen that looks similar to this. So I'm not going to show you like every plugin in detail or anything like that. I'm going to show you a general idea of some of the plugins that exist, how to install some of the plugins, how to use the plugins, just to give you a general idea of how how Recon NG actually works. So to start, let's take a look at what the marketplace looks like. The marketplace displays all of the plugins and tools that exist inside of Recon NG. So we'll say marketplace search. And this will give us a nice table of tools that exist inside of Recon NG. And essentially, what we can do is install specific ones using the marketplace install. So in this case, for instance, I've already installed a tool here. It's called Hacker Target. But if I wanted to install it, I would just say like marketplace install Hacker Target, and this would install the module into Recon NG. Now, from here, now that it's installed, I'm able to use it. And the way that I'm going to use it is just by loading the actual module itself. So we'll go ahead and do that. we say modules load hacker target. You'll see once we do this, it will show hacker target here beside the Recon NG default. This essentially tells us that we're now working with the hacker target module. So now everything that we type in is typing into that actual command module. So for instance, we can do a few different things with the hacker target module. Essentially, it's a scanning utility that's going to allow us to select a domain and actually do some scans against it. So to start off with, we're going to say show options. Show options is going to show you all the things that you can sort of set using this framework. So it shows you all the different options that exist here. What we're going to start with is we're going to start by setting a domain that we're going to scan with. So go ahead and do that. To do that, we'll say just options set source. I'm going to put in my domain name, scprogramming.com. So essentially what this does is it just sets the source to be my current URL. If we do an info now, it will show us what options have currently been set and essentially the information about them. It will say whether it's a required option, a description of the option that's been set. It will show us a description of the actual tool itself. So the info gives us all this sort of general information about the things that we can set, what we can do with it, and all that sort of information. So we do show options. It shows us the different options that exist with our framework. But when we do info, it shows us the current ones that are set and just sort of general information about the actual command itself. So after this, we can take a look at other aspects of the module itself. For instance, input. Input just shows what inputs are currently being given to the module. Again, just the domain name at this point. So it's a good way to be able to briefly check, like if you've set up a command and you forget if you gave it a specific input, you could type in input. It will show you all the inputs that you gave to it. And then we can run the module just by typing in run. And you'll see when we do this, it runs the scan up against my host. In this case, what it does is it gives me all of the subdomains that exist on my host, or all the different domains that are associated with it. So I get my main scprogramming.com and then the www.scprogramming.com. Both of those redirect to the IP address associated with the web page. So this is essentially how we're able to get that sort of information through this tool. And again, as we discussed before, the marketplace has a lot of different tools that are available. A lot of these tools might give you similar information to other tools that already exist on Kali Linux. Some of them might not. Some of them involve different things, such as looking for information on Twitter and YouTube, doing whois searches like we've done before, looking at virus total to see if there's anything associated to it, GitHub commits, GitHub repos, doing name check. A lot of these things we've seen already before, so we're not really going to go into them too much, but Recon NG is just sort of like a general one-stop shop for everything that you need, right? So it's a good way to sort of install a whole bunch of modules and just run them through a simple interface that is consistent, rather than having to load up like 10 different tools and having to run them all at different times. This allows us to do it in just an easier way.
We're going to be taking a look at a final information gathering tool known as Sparta. Sparta is a good transition into the next section of vulnerability discovery and like actual active exploitation of servers and web applications, because it allows us to not only discover information about a web service, but also determine any weak points, and it can do some basic sort of attacks on them, such as brute forcing, which we'll take a look at in this one. For this example, I've got my Ubuntu machine. It's running a number of different services on it. It's got Apache running on it with a few web apps, but it's also just a general network connected device that we could attack. So in this instance, I've got an SSH user set up with a really bad password, and we're going to take a look at how we can use Sparta to brute force onto this device. So this will sort of just give you a full picture of how we can apply our tools to be able to try to attack an actual web server. So to get to Sparta, we're going to go into the start menu here, and under information gathering, you'll see at the bottom here, Sparta. And when we launch this, Sparta is actually a GUI. It's not a command line interface, so we can actually see a nice little interface here to work with. And what we're going to do is I'm just going to move this over so I can see the IP address here, because I'm going to add it here. So we just click on this menu here, and then we can enter in the IP of what we're targeting. So in this case, mine's 10.115.97.194. And you'll see here there are options to run an Nmap host discovery and staged Nmap scan.
We'll leave those checked off because we want to run an actual nmap scan on this. Essentially, it's going to run an nmap scan to discover any sort of services that are running on the device, and then it's going to allow us to attack those services using different built-in tools with Sparta. So essentially, this combines nmap with a few other tools that are able to help attack the web server. So we'll click Add to Scope, and we'll let it run. You'll see here once we add it to the scope, it's going to start scanning using nmap. Now, this is going to take a little bit of time, so I'm not necessarily going to let it run through the whole scan, but we'll just sort of let it go for a bit here and see what we discover. You'll see that we discover over port 22, there's the SSH. Over port 80, there's Apache. So both of these are running, as I discussed before. So we can discuss potentially connecting through port 80 and attacking it, or port 22 for SSH. You'll notice that other things have run on here as well. Specifically, we've got information about the actual device as well, to say like the open ports, the closed ports. I can write up notes inside of here if I want to. Another thing that ran was Nikto. We're going to discuss Nikto in a later video, but essentially it discovers any sort of vulnerabilities that are running on the web server. In this case, I have a very vulnerable web app on here, so there's a lot of things here that are available that can be attacked. But again, we'll discuss this in one of the future videos on Nikto. And then it tries to run a screenshot of the actual web server itself. So you see it connects up to the index of it, which it was able to do, and it shows what's inside of the index. So it just gives us an actual screenshot of the web server, which is interesting. It shows us exactly what's on it. If you recognize DVWA, it's a vulnerable web app that's made for the purpose of testing tools like this. So again, we'll dive deeper into that when we take a look at vulnerabilities and attacks. For now, we're going to focus on actually brute forcing using the SSH login credentials. So we'll take a look at what this looks like. When we go to services here, we'll see, so port 22 is available on port 80. Port 22 is the SSH one, which is used to remotely connect to the computer. So when we right click on this, you'll see that there's a few different options to open with Telnet, open with SSH client, open with Netcat, and send to brute. Send to brute is what we're going to do. And it will bring it over to this tab here that has brute force options. So you'll see it will allow us to attempt to connect through SSH, and it will allow us to try different usernames and passwords. So in this case, we could say like, look for the username root, look for the password. If we don't know the username and password, we can actually go to a username list or a password list and utilize those. In this case, I'm going to say that we know the username. In this case, on the commands, you can say it's Ubuntu target is the username that I picked. I don't think that there's really any sort of username list that's going to capture that. But oftentimes, if they're using something common like root, you can often find username lists that will capture it. Now, the password we're going to attempt to find using a password list. There's a number of different password lists that come pre-installed on Kali Linux. When we click on browse, it will take us to that directory. It's some user share word lists. I'm going to use the nmap word list. Just to give you an idea, let's actually browse to that directory and take a look at it. So let's come over here to our file system. And I said it's under user, it's under share, and then there's the sections inside of here. Sorry, let me just... right, it's word lists is what we want. So it would be word lists right here. And you'll see that there's this nmap.list. So let's go ahead and open this up with mousepad, and you'll see all the different common passwords inside of here. So this is a huge list of some of the most common passwords that might exist. As you can see, there's a lot of them. You can find these word lists everywhere. There's a lot of applications that have them and a lot of applications that have these sort of passwords in them. You can see there's a lot of very common ones inside of here that are done through like research to determine what the most common passwords are. So you'll see a lot of things inside of here that hopefully they don't look familiar as your passwords, but they might look familiar as passwords that you've seen before, like 1, 2, 3, 4, 5, 6. It's a very common one, password, obviously. All of these are very common, so they're all included inside of here. So essentially what this will do is it will try to log in using the Ubuntu target username and all of the passwords inside of this password list. And it will only stop once it finds the password or it runs out of things to check. So let's go ahead and run this and see what happens. You'll see in this case I have this checkbox exit on first valid. It means that once it finds a valid username and password combination, it will exit. This actually uses a tool called Hydra, which is one that we'll discuss later on as well when we discuss password crackers and brute forcing. This is just a good example of an application of it that we can see. So you see here, it says that it found it. It sees login Ubuntu target, and password is 123456, which of course we saw inside of that word list was one of the ones that I pointed out, right? So obviously we were able to find this really easily. This might seem like a really trivial sort of attack, but you would be surprised at how many servers have a default password like 123456. Honestly, it happens more often than it ever should, and a lot of people don't really think about it. So this is always an attack that we would try to see if we can break onto the server. In this case, it works. So just to show that this works, let's go ahead and try to log on to the SSH and see what happens. So we'll say SSH 10.115.97.194. I'll just put the username in front of it. So we'll say Ubuntu target at that. And the password was 123456. And as you can see, that logs me onto the system. So now I have a shell into the system through SSH. So this is a great example of how we can apply our information gathering that we had throughout this section to be able to attack a vulnerable web server. In this case, using a tool called Sparta, we were able to do nmap scans to get information about the server and then pass them along to other tools, which were able to break onto the server. As we discuss more and more tools in Kali Linux that are used for attacking servers, we'll take a look at more practical examples like this, and we'll take a look at how we could use information gathering to even discover that these things exist to begin with, because we always want to drive back to the knowledge that we have from this section. So this is the final video for this section. In the next section, you're going to take a look at how to actually do some vulnerability analysis. So we're going to do analysis of vulnerabilities that do exist on systems, and then we'll take a look at specifically web applications, and we'll do some database assessments and sort of go from there and see how we can break onto different systems. So we'll get some really good practical experience before we sort of test out these tools in more realistic environments. Again, this is a great way to be able to penetrate test your web applications as well. If you have a web application that's running, you can try to brute force it, check if your password exists in some of these built-in word lists, because then you'll know that, well, it's easy to hack, right? So this is a really good way to be able to harden up your services and be able to penetrate test your apps. When we look at vulnerability analysis, we're looking at situations where we can analyze a specific target to determine if vulnerabilities exist on that target or not. Essentially, any sort of vulnerabilities will give us locations that we can specifically attack. We looked at information gathering, where we were looking at ways to be able to gather information about a server, like understanding what ports were open, understanding what services run on it. Now we're moving into the realm where we understand what services are running on it, but we want to see what kind of vulnerabilities exist on those services. So like not only discovering that a server runs Apache, but maybe it runs an older version of Apache that has these specific vulnerabilities in it. So there are a few tools that we can use for this in Kali. You'll typically find them in the start menu under vulnerability analysis. And the first one that we're going to take a look at is called Nikto. The idea of Nikto is that it can allow us to essentially do an automated scan against something that exists, typically a web server, and look for common vulnerabilities on that web server that we can then exploit. So to take a look at an example, we can do something like this. We'll say nikto-url. And then we'll go ahead and type in the URL of our target. So I'm going to target our Ubuntu server here because, well, actually, we'll target the Windows server would be better. This one has more stuff on it that we can target. So we'll go ahead and use this IP address here. It'd be, let's say, HTTP, backslash 10.115.97.129. When we do this, you'll see that it will scan for a whole bunch of preset parameters, and utilizing these parameters, it will attempt to find some information for us that we can then exploit later on the server. So I'll let this scan complete, and then we'll discuss what exactly we've found and what it means. So some places here that are already interesting to look at, things like it tells us what the server is actually running in terms of Apache version. It tells us about the OpenSSL version, the PHP version that's running. It takes a look for anti-clickjacking X-frame options. Essentially, clickjacking is when you load up a web page and then you could potentially load up like a second web page, and that second web page could do actions on the first web page using the authentication that already exists.
It's typically common in things like banking applications where you log onto a banking service on one tab and then you're browsing the internet on another tab, and then that tab sends a malicious request to the authenticated tab. That's essentially what clickjacking typically involves. So it's looking for options that could prevent that. It's looking for options that could prevent XSS. XSS is a type of injection that allows you to write JavaScript code into an HTML file. So it's looking for protection on that. Again, similar X content type origins, which allows you to use different types of origins to access the web page. And then it will look for more specific sort of vulnerabilities. So for instance, this one here, it will always give you like a sort of ID here. What happens is with these IDs here, you can actually look them up. So if I go into my internet browser here, I could actually look up these vulnerabilities and you'll be able to find them on different databases. So you'll get a description of the vulnerability and how to solve the problem on your server. So for instance, since directory indexing has been found on the web server, it might allow you to get to sensitive or hidden files. To understand exactly what this means, if I were to take the IP address that we worked with here, for instance, this one here, we can copy this address and paste it in. And what you'll find is that we'll list the whole index, the whole piece of information of what's actually hosted on this server. This is a directory indexing. Essentially what this allows us to do is move through basically the whole web server looking for specific files. We typically don't want this because if we have like a password file hidden somewhere, it's rather easy to find. And if we don't lock it under permissions, then someone can easily access it. So that's what this is alerting us on. Some other things that we're looking for here and that we're finding here, it's looking for information about Apache, and it's not finding anything, but it also looks for things for the relevant like PHP version. So it shows that it has like get, post, options, head, and trace enabled. So that means that we can access the files through that. There's HTTP trace enabled, which means that it could be vulnerable to XST attacks. There's more directory indexing. We're going to find a whole bunch of these because obviously I have it enabled, so it's going to be available. And then also this PHP config file is actually available that could potentially contain the IDs and passwords. So if we go to this config file, we can take a look at it to see what's actually contained in it. So for instance, it would just be backslash config.php. You'll see in this case it doesn't really load. Possibly it could be hidden behind permissions, or it could be in a slightly different directory than that. Actually, no, it's shown right here. Yeah, but it doesn't actually display the contents of the page, right? So you can see it right here. It doesn't display the contents because this is actually executing server side. If we take a look at the page source, I don't believe we'll see anything. Try inspecting the element as well. Yeah, we won't see any content in it. However, if we were able to download this, let's see if we can do that here. Let's just save this as, we'll save it to our home and see if it reveals any sort of information. Just to give you an idea of what exactly we're seeing here. I saved it to the home directory here, config.php. Let's open that with mousepad, and you'll see that it's empty as well. If we had some way to get to that config file, I know for a fact it shows the database login information because I was using that inside of here. So it does reveal information, however, it's not easily accessible through here, but it tells you what sort of files might be available that you might want to target later on, right? That might be accessible to us. So that's another piece of information that we do have available. So then from there, there's more directory indexing things. And there's a few other default files that are found inside of here, such as this one. This default file doesn't really give you a whole lot of information. However, something that it does do is it reveals the actual server, like the type. So you'll see what I mean by that inside of here is that if we look here, it shows Apache, right? So it reveals that we're using Apache. And the information inside of this README file could also help identify the version if we didn't know it before. So that's an example of what we can do with those default files found. Then it's flagging the login.php file that it's saying that it could be like an admin login. In this case, it is sort of an admin login that I've created. So it tells you that that's available and that you could try to access it. And then again, it's asking us here at the end if we want to submit information to CERT to ask for like an eco update because it found things that aren't necessarily available. I'm just going to say no there, but you could send that off and potentially get new features into the program later. But this gives you a good idea of what this exactly shows us. It shows us a good basically summary of some of the low hanging fruit that exists on this web server. So things like directory traversals, things like telling us if XSS protection is enabled, any default files it will find, anything with the name like login or config that's exposed, it will locate. And this can just give us information about potentially the setup of the server, what vulnerabilities might exist sort of off the bat that we can easily exploit and use to gather more information or potentially expose sensitive data or even compromise the web server as a whole. So that'd be the idea of Nikto. There's a few other things that we can do inside of here. One of the more important things that's possible is that we can actually specifically target our scans towards specific types, and that's done using the tuning setting. So doing this, you can say like something like this, like hyphen tuning, and put in like a parameter like 1 or 2 or 3. I've got all the options typed out here. So for instance, 0 is looking for file uploads, 1 is looking for interesting files, 2 looks for misconfigurations, so on and so forth. So the idea here is essentially, if you're looking for more specific information, you don't want to blast a server with a whole bunch of different requests because that's rather loud. You can pick one of these to look for very specific vulnerabilities, and it will try to pick them out for you. So this is a summary of how Nikto works on Kali. Again, it allows us to discover vulnerabilities that exist on a web server in order for us to be able to exploit them later on. Another common type of discovery that we can do for vulnerabilities on specifically Unix servers is looking at files that we can access through URLs or any sort of similar method, and looking for things that are exposed publicly. So either ways to connect to the server or ways to access files that are located on the server. Anything like that can give us a lot of information about the server, about the contents of the server, and potentially expose something valuable like passwords. A good tool to be able to do that with is included here in vulnerability analysis, and it's called Unix Privisec check. It's very easy to use this application, but I'm going to give you a few sort of tips and tricks to make it a little bit easier to read the results. So when you first do a Privisec check, there's two options, standard and detailed. I'm going to do a standard scan for this one first, and I'll use the IP of my Ubuntu box. And what you'll see is that it will scan it to determine common things that are valuable that could be exposed, essentially. So you'll see it's looking at a lot of different things here. It's looking for information such as like, can anyone except for root change this directory? Can anyone except for root change all these different directories? It could tell you if you could maybe log in as a standard user and change things that are privileged, for instance. That's the sort of information that we can get out of this tool. We can also get information such as things like processes or scripts that are typical in terms of like startup or things that are relatively valuable to be able to access. Things like OpenVPN, for instance, PostgreSQL if it's running on the server. Really any sort of common things that you might want to try to access without a root access to be able to compromise the system. Now, as you can see, it's a little bit difficult to read through this and determine what all of this is telling us. Essentially, what we want to look for is we want to look for any instances where warning appears rather than error or something else. So the easiest way to do this is to write the contents of this command out to a text file. The way that we do this is we put this angular bracket, and then we write the name of the file that we're going to write to. I'm going to call it test.txt. And you'll see instead of displaying the contents to the command line, it will just display them to the text file instead. So we'll just write them there. In some instances, you might get errors like these. These are okay. Just some of the scans might not successfully complete or might cause some problems. Maybe the files aren't available on the server. That's typically a common cause of this, but it's something to be alarmed at when this happens. Once this is done, I can now go to that test.txt file, which is just in my root directory where I'm running my commands from. And now we've got everything sort of written out here, so it's easier to read through. And you'll see here it says, search the input for any word warning. If you don't see it, then there's no problems, but if you do see it, then there are problems. You'll see it gives us very similar sort of information, so you can see like you can get like IP address information, which we can get through other methods as well, but this shows us it. And it looks for very common files that we might want to try to attack, like the password files, the shadow files. These are important files that contain login information, users and passwords, checks for account settings, it checks for configurations of sudo, it checks for, again, common files that you might try to access. So we're going to look for warning. and let's see what comes up. This first warning comes up on most of the scans that I do, and it's not really anything particularly to be concerned about. It just says that sudo is configured and we should check for unsafe operations. Sudo is just the super user mode, obviously. It's typically authenticated behind some form of password. In really good secure setups, you should have a typical user account with minimal privileges and then an admin account that you can escalate to with a password. So it's mostly just warning you that the super user is configured, and you just want to check to make sure that your configuration is something that's secure. And that being that the user doesn't necessarily log in directly as root, they log in as each user, and then they can enter the root password to do root things. The next warning we're going to get here is that the SSH agent is running on the system. Again, it's not really something to be like overly concerned about. However, it's telling you that there is the SSH agent or SSH agent, and it is available and it can be accessed, right? So it tells us SSH is running on the server, which is, it's fine to know that, right? And obviously we can access it with a proper authentication. However, it's telling you that if you don't typically use SSH or if you don't need it available, then you should probably disable it. That's sort of the idea of this warning. And similarly, we'll see a warning for GPG. Again, GPG is fine to be running on a server if you have a valid reason to be running it. However, if you don't have a valid reason to be running it, then you might want to try disabling it, because otherwise it's just sort of available and able to be brute forced, or that sort of idea for both the SSH and all the other protocols, right? So you want to make sure that if you're running something on the server, you're running it for a reason and that it's properly secured. So those are the warnings that come up in the standard scan. We can as well run a detailed scan. And I'll give you an idea of what this runs. It takes a little bit longer, but that's okay. When we do the detailed scan, we're going to see a lot more information about, specifically one thing that you'll see a lot of is instances where a root user is set to run a task or access something when another user could do it without root being enabled. So oftentimes people will just like run, say, scheduled tasks as root always, just to give it the most permissions possible. We always want to try to follow the principle of least privileges. We don't want to have the root user always running something if there's another user that can run it perfectly fine that doesn't have root permissions. So this will allow us to see instances where we have, say, a user, maybe like for the MySQL setup, right? There might be a user called like SQL user that has access to the SQL database, but everything might be running as root when it could run as a SQL user and have a lower level of privilege while still getting the task completed successfully. So those are the sort of things that you'll see here as well. Now, what it will tell essentially an attacker is that you're running specific processes as root. So they know what processes to attack, because if they get access to those processes, they'll get access to a root account rather than getting access to a standard account. So that's the whole idea, is that we can get privilege escalation through things that require root privileges. So any instance where we're running something as root when we shouldn't really be running it as root, we want to try to avoid as much as possible. So you can see this is still running here. It's going to take a little bit to run. So we'll just wait. I believe if we open up the test file now, we can see some of the stuff that's available here. Let's see if anything here has come up yet. So you'll see this here is a good example. So there's a cron job that runs for Apache 2 that's being run as root. However, the files that are being used in it are essentially accessible by this www.data user. So what this is telling us is that when this cron job is running as root, if someone were to compromise, say, this cron job, they would have access to root, essentially. They would be able to run this as root. We don't want this to be running as root necessarily, because we already have a user that can access the data, so there's no reason for it to be running at a higher level than that user. So this is an example of how this shows. And you're going to see like a whole bunch of these, because a lot of this is just default setup. And if you really want to harden down your server, you probably should remove a lot of these root accesses. You want to have as little root use as possible. Whenever you use root, you should authenticate as root. You shouldn't ever be running a whole bunch of processes as root, because it just gives more of an attack surface for someone to be able to get root on your server. So these are the general ideas of what you're able to do with this system. It does a really good job at scanning a lot of common directories to sort of determine, one, if they're accessible openly, two, if they're accessible through some sort of password or not accessible, and for three, determining potential places where a root user is running, where we might be able to compromise that system and be able to get a root escalation. When we're looking at web application analysis, we're looking at ways to be able to analyze specifically web applications. This can range from anything from like websites to actual like web apps that are written in like MainStack or Node servers, or even just like as simple as WordPress websites, which is what we're going to be taking a look at with this example. There's a tool in WordPress or in Kali called WP Scan. What WP Scan does is it essentially scans WordPress sites to try to find vulnerable plugins or vulnerable themes that might exist on the web page. Now, the thing about most open source software, things like WordPress, things like Node, is that they come with a lot of components. A lot of these components have vulnerabilities tied to them, ones that typically people don't necessarily know about or don't necessarily look into, because a lot of these tools are marketed towards people who don't necessarily have the best technical know-how. They just want to be able to plug in and go. So oftentimes they're going to have insecure software that they don't update or can't update because of some sort of other constraint. So we're going to take a look at how we can scan for those sort of vulnerabilities and determine where they exist. So to find WP Scan, we're going to go into the Start menu, and underneath Web Application Analysis, under CMS and Framework Identification, there's WP Scan. So WP Scan has a number of different options available to it. Now, the only tricky thing about WP Scan is that it actually requires an API token. Using this API token, you can do, I believe, 50 scans per day. So you have to actually register for an API token if you don't already have one available. When you run the application for the first time, it's going to ask you to sign up with an API token. And what you do is you essentially just go to the website that it links you, you sign up with your email, it will email you a confirmation, and then you'll have an API key. Once you have the API key, you can just do WP Scan, and then you're going to put in the API key with your scan. So you'll do something like API token, and then you'll put in the actual token itself, and then you can put in the actual URL that you're looking to scan. Just to show it without it though, if we want to take a look at a specific URL, all we're going to do is put in -- URL, and then I'm going to put in my URL here because my website currently is a WordPress site. So essentially when we scan this, in this case it's going to ask me to update the database. I'll just say yes to update it, since we might as well have it to the newest version. And as you can see, it's going to scan against the database to determine what things actually exist inside of it. If you haven't set up an API token, you're going to get this error here that's just going to say you haven't signed up with an API token. And essentially all this API token really does is it allows you to check if any of these plugins or themes are vulnerable. For the time being though, I'm just going to show you the actual like discovery portion of it. It's quite easy to just look these up yourself and determine if there's any vulnerabilities right into them. You can just look up the thing with vulnerabilities, and they'll show up as like CVEs typically, or just as releases on their web pages. Most of the time when something isn't up to date, you'll see here it shows like up to date, for instance. If something isn't up to date, then typically there might be vulnerabilities associated with it, or at least some sort of problem associated with it that you might be able to take advantage of. So let's just take a look at some of the examples of what sort of stuff we get back from this actual scan. So you'll see here, for instance, it discovers my actual like server information, the NGINX. We've seen a lot of different scans give us that information back, so that's not really the interesting part about this. XML RPC is another thing that gets detected by it. So you can see here it actually gives you references to actually look into these specific components to determine what they are. You'll see that it actually finds a README as well. So this is rather interesting. Let's go ahead and open this link and see what we get. In this case, it authenticates behind a password. But when we go to this, you'll see that this is just the WordPress README file. So you'll see it discuss like the first things first to say like all those things, all the different install components, updating, migrating, system requirements. None of this is particularly bad to have on. You could easily delete it if you wanted to, but obviously they have to authenticate to get to it. So it doesn't really matter if it's available, because if you don't have the authentication, it doesn't really matter. So aside from this, we have the must-use plugins, which is another sort of plugin component, as long as like the cron portion. A few other things that we have here available, the theme that is actually used by the web page. In this case, it's Vuelux. So this is the theme that's actually being used by the website itself. You get the GitHub for it, the description of it, the author of it, the author's URI. You get a lot of different information about it in general, which is great. So it tells you the actual version number as well. It tells you how confident it is, how it discovered it. The nice part about this is that we can go to this GitHub, for instance, and a lot of the times when we go to these GitHubs, you'll be able to see like issues, right? And this will tell you information about the actual problems that exist in this. You can see what's been closed, what's been opened. Essentially, if you look through the closed issues, you could typically locate things like, I don't know, vulnerabilities and that sort of stuff, or any sort of problems you'll be able to find here. So you can quite easily locate vulnerabilities, see what versions they're fixed in, check what version is currently installed. If there's an older version installed, then you know that it's vulnerable and you can exploit it, right? So you don't even really have to rely on CVE databases or the APIs from WPScan. Realistically, if you put in enough work, you can just figure it out yourself without really having to rely on anyone else, which is the best way to really do everything. If you want something done right, just do it yourself, right? So the other things that are installed on here, there's plugins, for instance, WP Quick Latex, which is a latex plugin that allows you to put in like math font formatting, right? So again, it will give you as much information as it can possibly find on it. In this case, there's no GitHub. I don't think that Quick Latex is open source, but I'm not entirely sure on that. But regardless, it will give you information about like the README and that sort of stuff. Again, a lot of these things will be locked behind logins, so they're not particularly important. If you don't have the login, you can't access them. So that's just something to keep in mind, though. This is a pretty reliable detection, right? It detects everything that so far is correct. I have these plugins. It hasn't missed any plugins, so it's a quite good detection. So the other thing that I found here is the WP Statistics, right? So WP Statistics is just a statistics tracking web page that tells you what kind of people are visiting your site, that sort of information. So again, that's available on the site. It tells me the version and all of that. So this is the idea of what WP Scan does. Essentially, it just gives you this nice aggregate scan to say, if you're targeting WordPress website, here's all the stuff that's installed on it. Here's all the themes. Here's all the plugins. So it tells you what sort of content is available. It lets you look for specific vulnerabilities in them, and then allows you to attack based on that. So it's a nice little information gathering tool that's a bit more specific than a lot of the ones that we looked at. Again, we're looking at a specific service and scanning for vulnerabilities on that service. We're going to take a look at a tool called Burp Suite. Burp Suite is an extremely valuable, I'd call it like a man-in-the-middle proxy server. And essentially what it does is it intercepts packets between you and a website or web application that you're interacting with. And it allows you to do one of two things. For one, it allows you to understand the information that's flowing from you to the client. So this gives you an idea of the actual information that you're sending to the client. And for two, it allows you to alter that information. So not only can you see what you're sending to the client, but you can also alter that information to potentially do something malicious to the client. Now, this can work in a lot of different ways. There could be very simple ones where there's an authenticated check that's set to like 0, for instance, that you can tweak to a 1. That could be an example. Potentially, it could be doing like length checks on the client side, for instance. It could be saying like max length 100, and you could alter that to be like 1,000 to cause it to overflow. In the example that I'm going to show you today, which is an example from one of the over-the-wire capture the flags, is that you can use it to alter information about a file that's being uploaded, for instance, in order to maliciously alter it so that it will upload like a code file instead of an image file. That's what we'll take a look at in this video. So the first thing we need to do with Burp Suite is actually get it set up on our computer. And in order to do that, we need to set up our web browser to be going through a proxy. For the purpose of this video, I'm going to be using Mozilla Firefox. It's my browser of choice. And we're going to set up the proxy on here. So the first thing we're going to go ahead and do is we're going to go into the Start menu. We're going to go to Web Application Analysis under, it's right here actually. It'll be Burp Suite. And we'll go ahead and launch that. So in my case, I get this JRE error. It hasn't caused any problems for me so far, so I'm just going to go ahead and click OK. And we'll hold off on updating for now. You can actually save your projects on your disk, or well, actually you can't in this version, only in the professional version. So we're just gonna have to live with a temporary project for now. The professional version includes a lot of different features, such as saving your projects to a disk. as well as being able to do some automated scans that are sort of nice. But the Community Edition still has a ton of power, and it does everything that we sort of want to be able to discuss here. So we'll go ahead and create a temporary project, and we'll use the defaults, and we'll go ahead and start burp. When we start burp, we're going to get this interface here. Essentially, the main areas that we're going to be working with is going to be the dashboard, the proxy. The repeater is also useful, and I'll show you some details about the repeater, but those are sort of the three that we're most interested in. So you see that our intercept is on. Our proxy is going to be on, we'll expand this a little bit here, on the local host through port 8080. If we want to set this up on Firefox, what we do is we head into the menu here and we go into Preferences. Inside of Preferences, I'm just going to go ahead and search for proxy, and then we'll go into the settings here. Inside of the settings here, you're going to want to set it up so you have a manual proxy configuration, and you want an HTTP proxy that's 127.0.0.1 over port 8080. Now you can use this proxy server for all protocols, which is what I've done here. I think you only need the HTTP proxy in order for this to work, although I like to put them all consistently just to sort of capture any traffic that flows through regardless. But this is the setup that you want. Once you've done this and press OK, you're all set to go. So to give you an example, let's say we open up this web page. You'll see Burp Suite pops up. If we head over to the proxy, you'll see that we get the actual request that we're currently sending, which is a GET request. So you'll see all the information here. Now with this sort of thing, you'll see the parameters that are being sent, and these are all sort of weird parameters that I don't really know what they are. You can see the headers. So this gives you the general information about the actual person who's sending the content, right? It gives you like the authorizations, it gives you the user agent, it gives you the host, it gives you the type of request, right? And then it gives you a hex of the actual header itself. So this is sort of information that you'll get out of this. And then if I hit forward, it will send the packet. If I hit drop, it will drop the packet and not let me send it. And then there are a few other options. For instance, I can right click on this and send it to the repeater. When I send it to the repeater, it essentially saves it here so that I can send it back to the server multiple times. So I can sort of like tweak different things and continually send the request. For now, we'll just go ahead and forward this. Now I'm going to show you a few examples of Burp Suite in action. Again, it's a really powerful tool and it has a lot of great uses. The first use we're going to take a look at now is the file upload task here. I'm going to go ahead and turn off my intercept just so that I can show you the general idea of what this file upload is doing. With this file upload, we're able to upload any sort of JPEG image. And the idea is I want to be able to upload my own PHP code so that I can do something malicious like print the contents of a file on the server or run a system command, something like that. Right now, if I go to upload a PHP file, what happens is I hit upload file, and you'll see that it changes the extension to JPEG because it's expecting a JPEG file. If we go to this, you'll see it will just give us an error that it can't be displayed. So obviously it saves the PHP content, but it just doesn't upload it as a PHP file. So the way to solve this problem is utilizing Burp Suite. We'll go ahead and turn on the intercept. And now when we browse for our file and select test.php, we'll go ahead and hit upload file. And it will show the data that we're actually sending to the server, which you'll see here. What we really are interested in is going to the param section. And you'll see here we get these same ones that I saw before that were like really weird. But then we get this max file size of 1,000, right? So that tells us what the file size is. We get the file name and the uploaded file. The file name is the thing that we're most interested in. I don't really care about the name, but if I change this to be a PHP file, then it will actually upload as a PHP file. So we forward this request, and you'll see I'll get your file blah blah blah.php has been uploaded. Now when I click on this, I'll just forward this request so that we get it. You'll see it goes to my PHP page and executes my code. So this is a great example of how we can use Burp Suite to intercept packets in order to be able to execute some malicious code or change some code. So there's a lot of different examples of how this can be used. Another example that we'll take a look at here is an example of SQL injection, which is a really simple, basic one, but it's still one that is pretty valuable for using Burp with. For this one, you don't necessarily need Burp, but there are certain situations where it actually is either easier to do or only possible to do using Burp. So let's take a look at an example here. I'm going to go ahead and go to one of my localhost servers. Let's go to 129 login.php. So in this example here, if I type in a username and password, it will try to log in, and you'll see that it will put the parameters into the URL and attempt to figure out, that the login username or password is invalid. So this is an example of a login page that uses GET requests in order to determine the username or password. So it will check it from the actual URL itself to be able to capture it. Now, we don't necessarily always have this sort of situation, actually. So for instance, inside of here, rather than having like a get setup, we could also have a post setup. So I'm going to go ahead and show you one like this. I'll just make a few small changes here. If you're curious about the code, you can see it here, that it just essentially takes in the username and password, runs a query against the database, and then checks the count. So we'll just change this method to a post method. And now when we try to log in, you'll see it's going to use instead an HTTP post, or it should use an HTTP post instead. See right here, the actual method is post. And then when it goes to the request method, if the request method is post, then it will do the actual post of it, right? So in these instances here, when we actually send the login request through the login.php, the actual parameters are going to be sent through HTTP request. So you'll see it doesn't show up in the parameters anymore. So now if I put in like a valid username and password like this, you'll see it authenticates me to welcome.php. However, if I put in a bad username and password, it will tell me that my username and password were invalid. Now, using Burp Suite, we can actually intercept this to change the parameters to something more malicious, to say do a SQL injection or something like that. Now, in this instance, I know that we can just put it into the username and password fields. However, there's some instances where the request isn't done through direct user input. It might be like a hard-coded constant, maybe on the client side. And in those instances, we can change it through Burp Suite, and this could be advantageous. So let's go ahead and see how something like this is done. I'm going to go ahead and turn the intercept on. And what I'll do is I'll just put in any username and password and press submit. You'll see here in the params, the username and password are provided here. So a sample of a SQL injection could be something like a closing quote or 1 = 1 and then a hashtag. What this essentially does is it closes the password field. So it looks for a username that's equal to 1 or a password that's blank, or a situation where 1 = 1 and then a comment which comments out the rest of the code so that there's no syntax errors. What this will essentially do is it will set it so that 1 = 1, which will return back the whole table that we're working with. And once that's done, essentially it will check to see if the count is greater than or equal to 1, which it obviously will be because it got back the whole table, and then it will authenticate us. So when we forward this packet, you'll see that we end up at welcome.php. So this is a good example of how we can use Burp Suite to be able to intercept something that's being sent to a server or database and be able to maliciously alter it in a way that it isn't expecting, to be able to, say, get authentication without proper permissions, or execute a command against the system, or change a file type, or anything like that. This is also really good for being able to request specific pieces of information from a server, say like requesting specific pages and tweaking the headers to say that we're authorized or something like that, or to put in like an authorized cookie or that sort of thing if we manage to steal one. So the Burp Suite has a lot of different functionality like that, but this just sort of gives you an idea of the main functionality that we can sort of sit between a server and a client and be able to alter the things that are sent from the client in a way that we can impact the server. We're going to take a look at WFuzz, which is a special type of vulnerability analysis tool which utilizes a strategy which is known as fuzzing. The idea behind fuzzing is that you have a user input that you can input anything into. From this user input, we're going to input in a whole bunch of known vulnerable commands or vulnerable inputs to determine if any of them are successful or not. It essentially allows us to do like large-scale testing of sort of low-hanging fruit and easy-to-notice vulnerabilities. We can find WFuzz in the Start menu here. It will be underneath Web Application Analysis. Under Web Crawlers, you'll see WFuzz here. I'm going to go ahead and use the help command to determine the different arguments that exist inside of wfuzz. And essentially, the main idea with wfuzz is that you're able to supply it with a payload, which would be a list of words to actually test with. As well, you're able to give it a method of testing those values, such as a post or get. Those are the two main things that this works well with, is posting and getting. With posting, we're dealing with situations where we're sending the data through the actual packet. For instance, you click login. With that click, it sends that data with it and then checks it to the back end and then sends back a result. With a get, it's putting it into the URL. So that's the instance where you see like appended to the URL will be like a username equals this and password equals this. And then it gets it from the URL and actually uses that to verify. So you'll see something like this similar in the URL if you have a GET request. Otherwise, you would have a POST request. And I'll show you how to actually determine that when we go through our example as well. Now, the other things that we can do with this, I just want to note, you're able to provide it a cookie. And the reason why you might want to do this is because the thing that you're attacking might be behind a login. And if this is the case, you might want to provide it an authenticated cookie so that it's able to send requests as an authenticated user. If we don't do this, then it might not be able to get through to the page that you're trying to attack. So this is always an option that's available to us. Now, when it comes to word lists to actually test our fuzzing against, we have actually a whole bunch of built-in ones that come with wfuzz. And I'll show you how to get to those. Essentially, they're underneath in your file system. You'll have a folder called user. Inside of here, you'll have the share folder. And inside of the share folder, you'll have word lists. And then inside of here, you'll have wfuzz. wfuzz has all the ones that are related to it. There's a whole bunch of different types of things that we can actually scan. The general sort of things are going to be just like common URLs, for instance, like admin panels. So like if you want to scan a URL for all the admin URLs that exist, this will check all of them. You'll see a whole bunch of really common ones. For instance, like WP login is the administrator login for WordPress. So that would be an example of one that we can scan for. And again, if it finds it, then that just tells you you're dealing with a WordPress site and you know where the admin login page is. The ones that we're going to take a look at today, though, are going to be injections, specifically SQL injections. Now, the whole idea behind this type of scanning is that determining if a SQL injection exists can actually be quite hard. The reason being is because there's a whole bunch of different SQL-based languages, things like MySQL, SQLite, there's a SQL Server. All of these have slightly different SQL syntaxes, and therefore different ways to actually attack them. So in order to determine if they're vulnerable, we have to use slightly different methods. This will allow us to scan a whole bunch of different strings of a whole bunch of different methods to determine which ones are valid and which ones are not. And this can tell us, for one, if a SQL injection exists, and for two, what kind of database we're actually working with so that we can do further attacks or even just use the ones that are found here to be able to authenticate to the server. So this would be the idea of the fuzzer. There's a whole bunch of different word lists that exist inside of here, and they're all useful for different reasons. But we're going to focus mostly on SQL injections because they're relatively easy to understand and easy to detect. Now, the SQL injections that we're going to work with here, I have a web page built up that's just like a vulnerable login page. And we're going to work with this to be able to test our SQL injections. So I'll go ahead and navigate to that. And now that we're here, we're going to go ahead and try like a few different usernames and passwords just to show you the general idea of how this application works. If I type in an invalid username and password, you'll see I'll get this error message that says the username and password is invalid. This is a valid sort of return, but it just like doesn't authenticate us or anything. If I type in a valid username and password, it will authenticate us to actually direct us to a different page, and this is the welcome.php page. So it's important to note that when we aren't successful, we're going to get an error and stay on the same page. When we are successful, we're going to be redirected to a new page. And essentially, when we get our results back, we're going to see either that we're redirected to a page, which tells us that the SQL injection was successful, or we just get back an OK, which means that we did something, it took us back to the same page, but it didn't actually allow for a SQL injection. So those are essentially the two outcomes that can come out of this. Now, the other thing we need to understand with this is what kind of request we're actually working with. Are we working with a GET? Are we working with a POST? Are we working with something completely different, right? And I said that I'd show you how to determine this. The best way to determine this, well, there's really a lot of ways to determine this. I can't really comment on what's the best way to do it. I can comment on which ways that I prefer to do it. When you're looking at a GET request, you're obviously going to see something appended to the URL when we click on the submit. So you'll see something like username equals this and password equals this. But a more reliable way to do this is actually to use something like burp to intercept the packet to see what gets sent to the server. So let's go ahead and launch up burp and see what that looks like. So I'll launch up burp suite here. And just while that's launching, I'm going to go ahead and set up my proxy server here. Again, just going through the preferences, we'll go to proxy. I'll go ahead and turn that on. So once we've done this, I have lost the burp suite window. Here it is. Go ahead and launch up burp suite. We'll set up a temporary project. And essentially what's going to happen is we're going to be able to see what actually gets sent to the server through this scan, right? So we've got our proxy running. So let's go ahead and send out a valid username and password. And as you can see, we get this this header here, right? Or this raw piece of information. If we're looking at the header, it shows that it's a post, right? Or in the raw, you can see that it's a post as well. So that tells us immediately what we're working with. We're working with a post. And right here shows you what data actually got posted. So it says username equals 1 and password equals 1. So we're going to need this format because essentially what's going to happen is we're going to tell wfuzz the format of the username and password. And we're going to allow it to say like password equals and then placeholder, and let that placeholder change to the injection-based vulnerability word list as it goes. So now that we know this information, we can go ahead and run a wfuzz command and see what we get. So let's get started here. Now what I'm going to do here is I'm going to use -c. -c just gives us an output with colors. I just prefer that because it's easier to read. And then the first actual flag that is going to do something is -z. This is going to determine what the actual payload is. So this is where we specify what we want to use in terms of like file. So I'm going to say file. Then I put a comma, and then I'm going to put the actual directory of the file that I'm working with. So in this case, this SQL injection file. So go ahead and copy that, and then we'll paste it. It's very important to note, don't put a space between the comma and the file path. So don't have a space here. Every space is seen as a separate argument by this. So don't put the space in there, otherwise you'll get a too many arguments error. So you don't want to do that. From here, we'll put -d. What -d is essentially determining what data is sent in the post. So if you remember, we had something that looked like username equals 1, ampersand password equals 1. And what we want to do is we want to tell wfuzz where to input the stuff from the SQL.txt file. And we do that by typing fuzz in all capital letters. So what happens is it's going to give it a username that's equal to 1, and then the password equals fuzz. That fuzz is going to get replaced with all the things that are inside of that word list, and it's going to keep trying all the different things and tell us what the results are. Finally, we're going to give it the page that we're actually attacking, which will be the IP with the login.php. So it was 115.97.129 login.php. And this is what a simple wfuzz command will look like. So again, we provide it with the type of payload that we want to use and where it's located. And then we provide it with the actual data and what to replace with the payload information. You'll see when we run this, we get this big table of results. And the reason why we tested some different usernames and passwords is because it's going to help us interpret these results. So what exactly is this telling us? It's telling us that with this 200 command, it means that or 200 response, it means that it responded with OK, that this was a valid response. It didn't error out or anything is what that tells us. It then tells us that there were 49 lines on the page, 156 words, the number of characters on the page, and it tells us what it actually tried. Now, what we can get out of this essentially is that when we do a regular command that doesn't actually have any sort of problems associated with it, the number of words that are displayed on the screen will remain consistent. So let me give you an example. Let's try that, the double quote one. You see, when we try the double quote one, it gives us the typical username and password is invalid. If we try the single quote, though, you'll see that we get these errors displayed on the screen. This tells us that we managed to do something different, right? That's why the word count is higher here than here. It tells us that more things displayed on the screen, which can indicate that there's a problem, right? In this case, it shows us some errors that indicate that there could be a potential SQL injection. So this is one way that we can determine that there's a problem using the WFuzz, right? The other way that we can determine a problem is these 302s. A 302 response means that we got redirected. Now, if you recall correctly, when we authenticate successfully, it redirects us to the welcome.php page. So what happens here is when we type in one of these commands, we actually authenticate successfully, which means that we redirect, right? So for instance, if I copy this command here, I'll go ahead and copy this, and then we'll paste it in here. You'll see when we do that, we redirect to the welcome page. So that's a successful SQL injection. So this is another way that we can determine that there was a success. So the two ways that we're determining success is a change in the word count or line count or character count, or a change in the response. Both of these indicate that something different from the normal happened. So these are the ways that we can determine that there was actually a problem. So this gives you a good idea of how WFuzz is actually used and how fuzzers in general are used. They essentially try a whole bunch of different inputs against a web application and then record what the output back was. And essentially by looking at that output, we can determine if an attack was actually successful. And from there, we can determine what attacks are actually valid and what attacks aren't without having to manually test them all on our own. So this gives us a nice automated way to test different types of common vulnerabilities and detect them on our applications. We're going to look at a tool called Comics, which is sort of similar to a fuzzer. However, it works specifically for command injections. And what it's essentially looking for is the ability to run a command injection. And if it finds one, it actually gives us a sort of reverse shell into the device that it finds the compromise on, which allows us to effectively take control of the machine. And using this, we can gain access to be able to do things like adding files to get like an actual full administrative reverse shell, or we can do a variety of other things. Primarily, we want to get a reverse shell onto the device so that we can get administrative access and do whatever we want. But this gives us sort of the first step in to be able to get in and potentially do further exploitation. So the first thing I'm going to do is I'm going to give you an idea of what an actual command injection is, and we're going to take a look at how it can be detected using Comics. So what I'm going to do is I'm going to go ahead and I'm going to go to the vulnerable website that I created here. So let's go ahead over there. We'll go into command. So this command essentially does a ping up against any IP that we input. So I input in something like this. It tells me the result of the ping request. Now, what can happen is inside of these commands, if we don't properly sanitize the data, we could potentially put in a character, and I'm trying to remember what it is for Windows. I know for Linux, it's a semicolon. I believe for Windows, it's an ampersand. And we can put in another system command and essentially chain them together. So as you can see here, it chains together the directory command as well to show me everything that's inside of the directory. What happens here is essentially, let me go over to the Windows box here so that I can show you exactly what's happening. When we run a command in Windows, right? So suppose that we run that ping command, right? So we're doing ping 127.0.0.1, and it does the ping command, right? When we put the ampersand, essentially what it does is it concatenates another command to run afterwards. So we say ampersand dir, it will ping that IP that was provided and then run the dir command afterwards. So see, it will ping, and then it will run the dir command. So this allows us to sort of chain commands together. And what happens is the person who made this essentially is expecting you to just ping an IP address. but we're going to chain in another system command, which is going to cause it to do something unexpected. It's going to allow it to run a different system command. And as you would know if you're familiar enough with computers, that you can do a lot through the command line, specifically setting up shells and SSH and learning about the system. So this is an extremely powerful and dangerous attack. To just give you a quick example of what the PHP looks like, you can see here it's using a shell exec, and it's doing ping -n1 that's saying to ping one time the IP that was provided. So you can see here how the concatenation is allowing it to sort of add another command in because it's not sanitizing that input at all. So obviously we can find the command like this, but we want to be able to get some form of reverse shell and maybe be able to automatically detect it, because obviously having to test all these different ones, it could be complicated, right? Obviously I knew in this case it was a Windows server, so I put the ampersand in. If it's a Linux server, you would have to put a semicolon in or a pipe in, or you could have to do a variety of different things. Comex sort of takes a lot of the guesswork out of it and does it all for you. So you can find Comex inside of the web app analysis right here, Comex. And essentially, the way that Comex works is it's actually quite similar to wfuzz. Let me pull up the help for it. You'll see there's a whole bunch of different flags that are available for us in the sense that it's similar to fuzz, the fuzzer, right? Wfuzz, right? Is that it allows you to put in cookies if you need to authenticate. You can actually give it authentication data, as you can see here. A lot of this gives you a lot of like very in-depth information. You can see that I can attempt to do like enumerations. I can attempt to find system usernames and passwords. So there are very specific types of attacks that it can do. It can try to find file access. It can sort of customize the different types of injections. I'm just going to show you the very basic level of injection that we can do. This will essentially be the default that you can use to be able to just like check if an injection exists and then exploit it. So the way this works is we'll go comex and -u, and we're going to put in the URL that we're targeting first. So it'll be 10.115, 97.129, command.php. And then we're going to give it the data that we're sending. Now again, if you're looking to determine what post data is actually being sent, you can easily just use something like burp to show the actual packets like we did with wfuzz. In this case, I know what it is because I wrote it, right? It's IP. And we're saying IP equals, and then we can type in any IP here. And what it will do is, so different from wfuzz. wfuzz, we have to put in a specific keyword. In this case, it will just append it to the end of whatever the data is that we provide. So we'll just append the command as I did here with the ampersand, and it will be able to determine what to do from there. So this would be the idea of it. Again, just to show you quickly in terms of actually finding the parameters, let's just run through that quickly so that you see how to do that. So it's not just like I'm pulling it out of nowhere, right? So it's always better to sort of see that information as we do it. So let's go ahead and set up a proxy quickly. Logo proxy, do a manual configuration, and we'll go ahead and check. Yep, that's all running. Okay, great. So you see when I run this, you see how it has IP equals. This is where we get that information from. In this case, it has the dir command appended to it. If I was just doing the IP equals, right, then it would just be IP equals this. That's where I'm getting that from. So just that way, there's no sort of confusion about where that information is coming from. We know exactly how we get that. So that just helps clear it up. Now, from here, we're going to run this command. And the first thing it's going to do is it's going to tell us if we recognize the system's operating system. So again, from like the information gathering that we learned about earlier, we could determine this information. In this case, I know it's Windows, so I'll put in W. From here, it will ask, in this case, it's asking me to resume. It actually saved my previous session. So I'll say no so that we can see it from the beginning. And what's going to happen here is essentially it's going to try all these different command injections and determine which ones work. So it's going to take us a little bit of time here, so I'll let this work its magic. And you'll see that once it actually finds a command injection, it will immediately flag it and ask you if you want to do a reverse shell. I'll show you what it actually found to be able to do that. So you'll not only be able to do it, but it'll also give you the command. As you can see, I've got the command right here. Now this probably looks relatively abstract and weird. Of course, to get around like WAPs and that sort of stuff, oftentimes we have to sort of obscure what the actual command is. So that's why it looks so strange like this. But anyways, if we click Y here, or lowercase y, we'll get our sudo terminal. And you'll see in this case we have a few different options that are available to us. So you can see that we get all the different options here. So we can set up a reverse TCP connection, a bind TCP connection. So this gives us all the different types of reverse shells that we'd be able to set up just through doing this sort of idea. We're not going to go too much into detail with reverse shells. We'll discuss them a little bit later once we discuss some things like Metasploit and like actual active methods, and we'll revisit this with some of the examples. I'll show you an actual example where we find a command injection, we set up a reverse shell through Metasploit, we send the reverse shell through this OS shell, and then we compromise the system. All I really want to show you right now is that if we have something that has a command input and we run this, it will find a command injection and it will provide it to us and allow us to have a remote shell, just to give you an idea of how comics actually works. So and just a note here, you can do some very simple commands here to be able to see the information that's sort of available in the system. So you run things like a dir command, will give you the current directory that you're in. There's a few other commands that you can run. It's fairly limited though. Really the main power of this is going to be to be able to leverage for reverse shells, which again we'll discuss later. But this is the general idea of comics, to be able to give us simple command injections for any sort of target web page that we have. In the last video, we took a look at comics, which was a valuable tool to be able to determine command injections that exist on a web application. We're going to take a look at a sort of complementary tool to this known as SQL map, which will take a look for SQL injections on a specific web application. So essentially the idea is we provide it with the URL, and similar to comics, we can give it post information or get information, and it will scan very typical SQL injections to determine if any exist. Now, in addition to this, SQL map will also do a lot of other things for us. It will allow us to determine information about the databases, such as the tables, the columns, and it can also help us leak data from the database. In addition to this, it can also sometimes give us a reverse shell into a client. However, that's extremely rare circumstances, so we're not really going to discuss that in too much depth, but we're going to discuss the actual leaking of database data, because this is really where SQL map thrives and what it really should be used for. Most of the reverse shell sort of stuff can be done a lot easier through Metasploit or tools like that. If you have a SQL injection, really the main thing that you want to do with it is leak a database and potentially attack it in some other ways, such as inserting, deleting data. So we'll take a look at how we can use SQL map to give us the tools to be able to do that. For this example, I have DVWA installed on one of my devices, and this is essentially a purposefully vulnerable web application that has a whole bunch of different examples of different types of attacks, such as command injections like we discussed before, and SQL injections like we're going to discuss now. And the idea is that this web application can be used to test our tools against in a way that we don't have to maybe like have a live vulnerable web application or attack somebody who we don't have consent to attack. So essentially the idea of this is when we type in like IDs, we're going to get the information for that ID. If we type in something like this, for instance, this is a classic sort of SQL injection. You'll see when I do this, it spills all of the data inside of that table. So in this case, we know that a SQL injection exists, obviously, because I can do this. Where SQL map will come in handy is in instances where maybe one, we don't know what we're actually working with in terms of database. We aren't able to just like plug in something like I just did there and immediately get a response back that we know is vulnerable. So that's something that SQL map really helps us with. It also helps us go further from here. So just because I discovered this single SQL injection doesn't mean I necessarily know how to gather data from this database now. SQL map will allow us to automate the process of finding database information. So allow us to figure out tables and columns and data without having to play around at all with the user input. So we'll just do it in an automatic way. So in order to use SQL map with this web app, we're going to have to provide it with a few different pieces of information. For one, I'm going to have to provide it with a cookie for the login, because essentially this actual web form here is hidden behind a login page. So in order to get here, you have to log in first. So since you have to authenticate, we need to provide it with a cookie. As well, we have to get an idea of how this data is being sent to the server, whether it's a post or GET request, and that sort of general information. To get that information, it's best to use something like Burp Suite. So like we discussed before, we can figure out how packets are sent to the server using Burp Suite. So I'll go ahead and set up my proxy and we'll take a look at that. So now that the interceptor is on, I'll send a simple request. And the main information that I want to get out of here is, for one, this is a GET, which means that the parameters will be sent in the URL. You'll remember from comics, we had a post request, which was slightly different. Things were sent in the actual packet itself. This will give you an example of one that's sent in the URL. The way that this is used is very similar to the way that things like comics and WFuzz are used. So this will give you sort of a different perspective when you have a GET request. The cookie here is the information that we want in terms of our login. You'll see there's two pieces of information. Security equals low is just the setting of the actual web application. It comes in a few different levels. Low is just the easiest, so we tend to set it to low just for learning purposes. And then this session ID is my current session ID, which means that it can act as an authenticated user as long as I provided that information. So I'll go ahead and paste that here for further use. And then we'll go ahead and turn off this intercept, and I'm just going to turn off the proxy as well, just in case it interferes with anything. We don't want that to happen, so we'll turn it off now. Now, the other piece of valuable information is this URL here. This URL is the URL that we're going to be attacking with our SQL injection. You'll see it has the ID inside of it, ID equals 1. I can tamper with this ID to put in whatever I want. If I put in like a single quote, for instance, you'll see I get this error message that, there's an error in my SQL syntax, right? So this shows us that this ID can be used to give information. So like ID equals 2 will give us the second ID. Again, when I put in something like a single quote, it gives us an error. And that's how SQL map is going to be able to determine if SQL injections exist. So we'll replace this ID with a whole bunch of different commonly used vulnerabilities and essentially determine if one exists. So now that we have the information that we need, let's go ahead and load up SQL map and take a look at how it works. It can be found inside of the web application analysis right here, or inside of database assessment as well. We'll go ahead and go into web application analysis and load up SQL map. So there's a lot of different arguments here. We'll discuss a few of them in detail. Let's start off with a very basic scan. The very basic scan will look like this. We'll say SQL map, and we're going to provide it with a cookie. Remember, the cookie is just our login authentication, which is this first piece of data that we gathered here. So go ahead and paste that in. I put it in quotes so that it knows that it's all one argument. Otherwise, it interprets the space as a separation of arguments, and it will give us an error. The second thing we need to provide is the URL, which we can do using the U flag, and that information is given right here. Again, I'm going to put it inside of quotations, just that way it's clear towards this being an argument. And you'll see it will run through and it will give us some results here. So let's take a look at these results in a bit more detail. Essentially, what it's telling us here is that it attempts to inject through the parameter ID, which is a GET request, right? There's a few different types of injections. A Boolean-based blind injection, which essentially puts in some sort of simple Boolean request that is either always going to be true or always going to be false. And by checking the results of that, it's able to tell if the thing is vulnerable to a SQL injection or not. Again, we also have an error-based one. If you noticed before, when I typed in that single quote, it sent us to an error page. So sort of information can be sort of taken out of it just through, finding different errors that could exist. If we get an error that pops up, then obviously we know that there's a problem.
in this case, you'll see that the actual query is very confusing and long. There's a very specific reason for this, and that is that when you have web application firewalls or intrusion detection systems, they might take a look at queries that just cause errors and immediately filter them out. If we do something really long and complicated like this, it might not get filtered out by the firewalls, which is why we pick stuff like that to make it a little bit more obscure so that it doesn't match like a pattern. Timing-based attacks are really nice. Essentially, this sleep 5 allows us to sleep our request for a specific amount of time. I'll show you when we type in an ID here, you'll see that the response back is instant, right? Now, if we put in something like sleep 5, it will automatically stop and try to load for 5 units of time. And essentially that will take a lot longer than our typical request, which will tell us that it's actually doing the sleep, which means that it interpreted our code as SQL, right? Rather than interpreting as a parameter. And then the final type here is a union. Sometimes some of these other requests might get filtered out. Unions sometimes don't. So a union is another way to be able to determine if there's actually a SQL injection that could be possibly implemented here. So from this, we've got a lot of different information already. We know that the server is a MySQL server. We know the version of Ubuntu that it's on. We know the Apache version that it's on. We know the MySQL version that it's on. Using that information right now, we could do plenty of different attacks because the Ubuntu version is out of date. The Apache version is possibly out of date as well. I'm not actually sure about that one. MySQL version might be out of date, so we can determine different attacks just by utilizing those version numbers, right? We can easily look up vulnerabilities for Linux 16.04 and attack based on just knowing that version number, right? But of course, that's not the most valuable thing that we can do with this. Now that we know that there's SQL injections available, we can add in a few more arguments to determine specific pieces of information. The first piece of information you might want to figure out is the databases that exist, which you can determine using the DBS argument. So when we type this in, you'll see that we get back the database names that are actually existing inside of the database that we're attacking. So of course, there's a whole bunch of different databases inside of the actual like MySQL client itself. So we can essentially see now that there are a whole bunch of different databases that exist, so we can specifically target ones that are of interest. So the next thing that we can do here is determine the tables that exist inside of a database, and we do that using the tables command. And I'm going to provide it with a database using the -d argument, and we'll go ahead and go into the SQL injection database. Sorry, I think it's a capital D. Yeah, it's a capital D. My apologies. So you want to use a capital D, not a lowercase d for the argument. You'll see when we do this, it lists all the tables that are inside of the SQL injection database. In this case, there's one table, and it's called login. Now, when we see a login table, obviously that would be very interesting to us. So let's go ahead and take a look at what's inside of that table. And the way that we do that is by listing, first we're going to figure out the columns that exist. So we'll say column. I think it's columns. And the table that we're working with is going to be the login table. And the data that we're working, or the database that we're working with, is a SQL injection database. And you'll see here when we do this, we get the columns that exist inside of the login table. So in this case, the username and the password. So of course, now we're thinking that this login table contains username and passwords. That's very interesting to us. So we want to dump the data to the actual screen here. So in order to do this, we can just use the command dump. And once we've done this, you'll see that it will just dump out the whole table, all of the data that's inside of it, right? Username equals test, password equals 1, 2, 3, 4, 5, 6. This was actually data that was used in previous videos for the SQL injection login page that I was showing. So as you can see, we've actually leaked the whole contents of the table. So SQL map can take us from detecting SQL injection to determining the databases that exist, determining the tables that exist, determining the data that exists inside of those tables, the columns that exist inside of those tables. So it can pull a ton of information out of these databases with very little effort. You can see that took us almost no time to do. So this is very valuable to be able to utilize a tool like this. Now, if we're taking a look at the help section here, there's a lot of different things that exist inside of here, obviously, that might be interesting to us, right? So we can leak things like the schema. We discussed leaking columns. We discussed leaking tables.
This will attempt to enumerate the DBMS users for password hashes, as well as the users. So when we're doing something like this, it will essentially tell us the username and password hashes for the user that is querying the database. One of the things that is valuable here is using the all command to just determine as much information as possible. Let's try that here and see what happens. So we'll go -a. As you can see here, what we get from this is a lot of the general information that SQL injection exists. Again, we discussed all the server version numbers that we get out, the banner that actually is returned back. And as you can see here, it determines the current user, which is root at localhost, the current database that we're working with, which is DVWA, the server host name, which is this here. It checks if the current user is a DBA, which means that they can essentially work with pretty much anything in the database. And it tells us all of the different users that exist, right? So these are all the database management system users, all of the people that can actually touch the database. So as you can see, we can determine very easily which users actually exist on the database. Now it's going to ask us, do you want to store hashes to a temporary file for eventual future processing with other tools? Let's go ahead and say yes. And then it has written it to this temporary file here. So let's go to this URL just to take a look at this. So we'll go into our Finder here. You'll see inside of here it retrieved username and password hashes, and you'll see it got it for all of the different ones that existed on the system. And it will actually go one step further and ask if we want to do a dictionary attack on these. So yeah, why not? Let's give that a try and see what happens. There's a few different dictionaries that exist. We'll just go ahead and use the default one and see if it can figure it out. We won't do that. We'll just do a simple one. And as you can see here, it's actually okay, showing a lot of information here. It's cracked the password for the root user, which was 1234556. So it easily cracked that through a dictionary. What it's doing now is dumping literally all the information that exists in the database. So literally everything is being dumped onto the screen right now. You can tell that this attack is very likely an extremely loud attack. It's not something you particularly want to perform up against a database. You would probably want to do a more targeted attack, finding out the databases, finding out the tables, the columns, all that sort of information. Doing something like this is much more dangerous because we're just going to hit the server so many times. It's going to show so much information about what we're doing. It'll be very easy to figure out that they're being attacked, right? So you can see all the different information that you're gathering from here. This is just a good idea of what kind of information you can possibly gather from SQL Map. You can see it's really a ton of information. It's very valuable in terms of being able to not only attack, but information gather as well. So I'm going to go ahead and stop this because it's going to keep going on forever, and it's going to do a lot of stuff that we don't necessarily need it to do. Taking a look at some of the other things that we're able to do inside of here, I want to sort of touch on the operating system access. You can potentially get an operating system shell or pwn the operating system in general. The way that this is done is essentially there are certain SQL exploits that exist that allow you to potentially upload PHP files or really whatever file the server is using. And then from there, you can access that file. And then typically we upload a payload that just lets you like upload a file. And then the server will process the file that's uploaded. And then from here, it can run some sort of malicious code that will give us a reverse shell back into the server itself. That would be how this attack works. Now, it relies on the database user having access to be able to write to directories, specifically the server directory. It's very uncommon for something like this to be actually enabled. But if it is enabled, you just put in the OS shell and it will guide you through the steps of actually attacking a server in this way. So it's very easy to actually utilize if it exists. I know for a fact on this server it doesn't, and on most servers I've tried with, it doesn't. So your mileage may vary, but it's something that you can try as well. Most of these other options here are just sort of specific information that could be provided, such as the cookies.
This data can be used if you have a post instead of a get. If you recall some of the previous tools, we did the data and then we gave it the post request. That can also be used here instead of using the URLs if you're using a post instead of a get. So this gives you a general idea of how SQL Map works. Again, a ton of valuable information that can be gathered here. We can completely exploit databases using this. It gathers all the information that could possibly exist on them. So it's an extremely powerful tool and definitely really valuable for not only locating SQL injections, but also exploiting them. We're going to take a look at Metasploit. And what Metasploit is it's a tool that's used to be able to take vulnerabilities that are common, and it generates actual exploit payloads for them that will allow you to run the exploit up against a target, compromise their machine, and get access to the machine, typically in the way of a shell that has a root privilege on the machine itself. This is one of the most well-known tools inside of Kali Linux, and it's one of the best ones to use to be able to compromise devices sort of from start to finish. So there's a few different types of exploits that exist inside of Metasploit. There's a lot of different things that are inside of there. I'm going to give you sort of the idea of the tools that you can use inside of Metasploit. We're also going to walk through a few examples of exploits that we can do, just to show you essentially how the program works, give you a few live demos, and give you some resources to be able to use it on your own. So in order to get to Metasploit, we're going to go into the Start menu here. We're going to go under Exploitation Tools, and we're going to open up the Metasploit framework. Actually, in this case, it didn't launch it. You can also launch it alternatively by typing an MSF console, and that will load Metasploit. Not sure why that link in the Start menu doesn't launch it. It might only be launchable through this MSF console now, but this is how you can get into it. So MSF console is essentially the console to interact with the Metasploit framework. There's a lot of different things that we can do inside of here. One of the first things that I'm going to show you is that there's a search functionality. Well, actually, let's start off with help. Help will show you a lot of the different commands that exist inside of Metasploit. So essentially the main things that we're going to discuss here is ways that we can see jobs that are currently running, view and interact with sessions that exist, and also how we can find exploits for particular products that we're looking at, right? So in terms of the search method will allow you to search specific keywords inside of the exploit database to find exploits that work on specific targets. So for instance, if I were to search something like Ubuntu, I need to close the double quote. You'll see we'll get this whole list of exploits, and these are all exploits that have Ubuntu inside of them, in that they've been tested and confirmed on Ubuntu. So you'll see that most of these involve specific actual products, things like Adobe Flash Player, for instance, or WordPress, or those sort of products, right? So essentially, if we can identify that we have a Ubuntu machine that is running specific versions of WordPress, then we can potentially compromise them. And the compromise is actually shown here. So this is how we load the exploit. It's using this path here. And we'll see a bit more of that in a moment. What I want to show you here is if you take this and search for it online. So let's just go ahead and we'll go to Firefox. You'll see that there'll typically be a Rapid7 link available. And Rapid7 are the people who actually manage Metasploit. If you go into products, you'll see Metasploit here. So they're the ones who actually run Metasploit. And you'll see inside of here, they'll give you a bit more of a description on the actual module itself. So it says here that this module exploits an arbitrary file upload in the WordPress Ajax load more, version 2.8.1.1. And then it just shows where it's been successfully exploited, what operating systems, what WordPress versions, and which plugins are actually being exploited. Now, if you remember, we discussed WP scan and Nmap. Nmap allowed us to determine operating systems in terms of the versions and the services that were running on them. And then WP scan allowed us to identify plugins and such, as well as versions that existed on a WordPress server. So as you can see, hopefully this all comes together now. If we have a vulnerability like this, we know that it works for WordPress. We know that a site is running WordPress. We can scan it to see what plugins it has. If it has this plugin, we might be able to exploit this module. And it sort of gives you a bit of an idea of how to actually to start use the module and actually be able to load specific aspects of it. So we'll get a feel for how this really works in a moment here. The two exploits that I'm going to show you one for Ubuntu, I'm going to show you one for Windows, and I'm going to show you two different sort of vectors of attacking. One's going to be a vector of having a vulnerable file that we can use to exploit a machine, and the other one's going to be through way of having a vulnerable web page that someone can visit and they'll get attacked through that. So let's go ahead and get started with that. The first attack that I'm going to show you is going to be one for this Ubuntu machine here that I'm running. I'll just go ahead and log on to it here. This is a default install of Ubuntu version 16.04. And essentially, one of the things that comes typically on Ubuntu is OpenOffice or LibreOffice. Depends on what versions you have and what versions of Linux you're using and what you have installed. Typically, LibreOffice or OpenOffice will be available on Ubuntu machines by default. The reason why this is important is because we know that there are some OpenOffice exploits that exist, and we can utilize those OpenOffice exploits to be able to compromise most Linux machines since they have OpenOffice available. So the first thing let's do, let's go ahead and search for OpenOffice and see what kind of exploits exist. You'll see here there's three different exploits that happen. There's one that happens here for a very specific version of LibreOffice. There's one here that is for OLE, which is for Microsoft versions. And there's one here that's malicious macro execution. Now, if you work in security or work in IT, or even if you just work in an office, really, you've probably seen some scam emails that take advantage of likely this vulnerability or other ones similar to this. What this does essentially is it creates a document with a macro embedded in it. And if the person loads the document with macros enabled, it will execute the code inside of the macro and send back to us the actual session. And from this, we can take control of the computer. So this would be the idea of the exploit that we're going to look at. If I want to use this exploit, all I need to do is copy this name here. Okay, I missed the E. I'll just put that in. And we'll just say use, and then we'll paste in the path. So now we're inside of the actual module. Now there are a few things that we can do in here. We can say show targets. And what this will do is it will show you all the different targets that we can target. We can go after Apache OpenOffice on Windows, or we can go over Apache OpenOffice in Linux/OS X. So you see it works for all the operating systems. And we want to set the target that we're working with. So we're going to say set target 1, because I want to deal with a Linux/OS X machine. Now, I just want to note that this sort of flow of logic is going to be consistent with almost every single module that you're going to work with. So you'll see it with the second one that we do. We're going to go through a very similar type of logic. Once you know how to use one module in Metasploit, you probably know how to use pretty much all of them with some small differences, but they're pretty well all the same. So this would be an example of how to set the target. Now, as well as setting the target, we can also do show options. What this will do is it will show us the different options that exist for us to be able to customize in the exploit. So we can add a message to the document body, we can change the file name, and then we can set up the server host, the server port, we can do SSL, and a URI path. Now, you'll see that some of these are required, some of them aren't required. The name of the file has to be required. It will essentially allow us to name it something that might seem legitimate to the person who is actually accessing it. The reason why this is required is obviously because it has to save the file somehow, so it has to have a name for it. Serve host is one that's also required. This would be the IP of the attacker. So we want to have the attacker's IP so that it can set up a server for the compromised machine to communicate back to us. In addition to that, we need to pick a port to listen on as well. Now, I just want to note that it doesn't really matter which port you choose as long as it's a port that is open on your computer. So we'll go ahead and set each of these. And the way we do that is we just say set, and then we put in the option name. So I'll set file name. I'm going to call this something like finances.odt. And I'm going to set the serve host. In this case, it's set default to localhost 0.0.0.0, which would be my IP. I just want to show you how we can change it, just in case you ever need to. And the reasons that you might want to do this is because you might want to listen on a different computer and use a different one for generating out the exploits. For whatever reason, you might want to do that. Sorry, this needs to be lowercase letters, not uppercase. And then we're going to set the port. And whenever I deal with ports, I always like to use something like 4444. This is one that tends to typically be open, and it allows us to actually ensure that the port is open. So I just use a consistent one that I know is going to be open.
Now, what I'm going to go ahead and do here is I'm going to type in exploit. Once I type in exploit, this module will start to run, and it will essentially generate out this malicious document with the name finances.odt, and then it will start to listen on the host's IP and port that I provided to it. And what it's listening for is it's listening for someone to open up the file. Once someone opens up the file, it establishes a connection and gives us the connection to control. So we'll go ahead and hit exploit. In this case, it says that the IP address is already in use, or the port is already in use, so it's not available. When this happens, typically it might be because there's another job that's running, or perhaps a session that's running. Sessions. In this case, there's neither, so we'll just set a different port. We'll say 4445. Might have just been something left over from when I was testing this earlier. You'll see once I pick a valid port, we'll actually get the exploit generating. So you'll see here, it creates the malicious file and it places it in this directory here so I can access it. And on top of that, it just starts listening. So right now it's listening for someone to connect to it. So I'm just going to show you, I'm going to go ahead and load up MSF console here, because I just want to show you how we can see that this job is currently running. And the way that we do this is by typing in jobs. Or typically we type in jobs. You know, it might be based on instance itself. So I would probably have to close this off and rerun it to show the job that's actually running. So I'll show you that in a minute once we actually run through the exploit then. So now all we really need to do is on this computer here, we have to somehow get the file onto this computer. Now, I'm going to sort of ignore the whole song and dance that you would have to do typically to get this onto somebody's computer, because obviously you're going to have to convince someone to install the application or to install the email or the document. And one of the ways that this is typically done is people send it an email, maybe posing as someone from the finance department, and say, hey, here are my final finance numbers, take a look at them. And someone will go and open it and obviously get compromised, right? So that's sort of the idea behind it. In this case, I'm just going to transfer it over with TeamViewer. So I'll go ahead and do that now here. So go ahead and connect this. I'll say 81.5. Okay. And what I'll do is just open up a file transfer. So you'll see it's stored in this directory here, root /.msf4/local. Now, one thing to note, you don't see that file in the root directory. It's because since it has the dot in front of it, it's a hidden file. There are probably settings that you can tweak to show that, or you can just get to it through command line, but this is the actual directory itself. So I'm going to go ahead and send this over to my other computer here. You'll see now it's on the desktop, and or rather it's not on the desktop. Sorry, where did we send that to? Home/target. So it's under the home and then in target. So you see finances.odt. Once we go ahead and launch this, you'll see it looks relatively normal, right? Now I have macros enabled here. If you didn't have macros enabled, it would warn you, there's macros in this file. You need to enable them through this option setup thing here. So you might have to go through a little bit of extra step to get someone to enable macros, but trust me, there are probably a lot of ways to convince someone to do that. But for now, I'm just saying, okay, assume that they already have macros enabled, which also isn't necessarily an uncommon thing. A lot of people use LibreOffice or even Microsoft Office macros, right? So they might have it enabled by default, which could lead to this sort of attack happening. So you see, from the user perspective, it doesn't look like anything really happened. I don't see anything wrong with this. I got the content of the file. This file could have been filled with all sorts of stuff, right? We could have altered the contents completely. Doesn't really matter. It looks totally legitimate. It doesn't seem like anything really happened here. Maybe the file got sent empty or something like that. But if we come back here, you'll see that we get this command shell session 1 opened. So this tells us that we, in fact, did get a compromise. We did get access to the machine. So now I'm going to hit Control-C, which will take me out of the command. And let's go ahead and take a look at sessions. So you'll see here we have one session where we're connected to the target machine. Now, this type of shell actually isn't one that can really do any harm yet. We have to escalate this to make it slightly worse, to get a root shell, for instance. So just to show you here, we can do sessions -i and then put in the ID.
and this will allow us to interact with it. But you see when we interact with this, nothing really happens, right? So we'll go ahead and abort that. And in this case, I lost the session because I interacted with it. We'll just go ahead and open up the file here again just to get it back. Yeah, you see, now we got another session open, right? So just like what I was talking about before there, when we take a look at the jobs, right, you'll see it shows that it's still listening on that port. So it's going to keep on listening on that port until we essentially tell it to stop by killing the process. And I'll show you how to do that in a moment once we actually have to do that. But anyways, so once we get back to our sessions here, you'll see that we have the session running here. And you saw that when we tried to get onto the shell, there really wasn't much that we can do. What we have to do is we have to escalate this to a more privileged type of shell, which is typically known as a meterpreter. The meterpreter shell allows us to basically do everything that we would normally be able to do with like a root shell on the device. So once we have that, it's basically game over. We have access to the full computer. We can do whatever we want. So the way that we do this is by using a different module. And we'll go ahead and type it in here. It would be post multi manage shell to meterpreter. And you see from the name, it seems pretty obvious what it does, right? It turns a shell into a meterpreter, which means that it takes that shell and it elevates it to something more privileged so that we can actually do an attack. So all we really have to do with this one, again, we can do our show options to show us the options that exist inside of it. We can do show target or show targets, right? In this case, this isn't an exploit module. It's actually something that's done after exploit, right? So there aren't really any targets to be shown on it. All we really have to do with this one is we have to tell it what session to run the module against, and then we have to give it a unique port as well as an IP address if we want to. This one tries to auto-detect it, so we can just leave that blank and not really have to deal with that. So essentially, all we really have to do here is set the session. We want to set the session to be the same ID as what it is here, which is 2. So set session 2, and then we'll go ahead and run it. And as you can see, it will start to work its magic. It will attempt to escalate the shell. And here you can see a meterpreter session opened on session 3. So let's go ahead and quit out of here. Let's take a look at our sessions. And now you see that we have this meterpreter shell, which gives us sort of like the UID and the GID and the EUID that it's running as, right? So now if I do an interactive session with it, sessions-I3, this will allow me to interact with the session. And as you can see, I get a shell that is the same as a root shell, right? So you see I can get to pretty much anywhere. I can run any sort of commands that I normally would be able to, right? So some of these are empty, some of them are not. I can transfer files over here. I can create a user. I could potentially run any sort of command here. So at this point, again, it's game over. We've compromised the machine. There's nothing that the target can really do now, well, aside from like rebooting or trying to remove our actual virus. But we have full access to the machine. And I want to make it really clear that when you look at the target really has no idea. They can close this file. They can close this. They're still using this the same way as normal, right? If I close out the team viewer here, for instance, it's going to look essentially like nothing happened, right? You can see that they can use their computer as normal. There's no sort of problems here. They have no indication that they've been compromised. However, I have the root shell, so I can do whatever I want. So this is a very sneaky and devastating sort of attack, and it can be done quite easily through just like a little bit of social engineering, right? You just convince someone to open the file, they open the file, they're compromised. It's game over, right? So this would be an example of how we can attack someone using Metasploit. Now I'm going to show you one other type of attack that's nice to know about, and this one we'll do using our Windows machine here. And essentially what we're going to do is we're going to exploit Foxit PDF Reader. It's a very specific thing. It's just something that I could find an old version of lying around. So it's easy enough to exploit, and it exploits through the browser. I want to show you it because the browser exploits are a little bit more interesting than the file exploits. The file exploits are a little bit harder because you have to convince someone to run your file and maybe disable macros. That's a bit tricky, right?
With the browser-based exploits, you just have to get them to go to a web page, and there's a lot of different ways that you can do that, right? You can try to trick them. You might even really not even really need to trick them if you use something like a sniffer or spoofer, right? So let's go ahead and take a look at that now. Now, typically I like to end my sessions, and you do that using -k, and then you put in the ID. So that just like kills the session. I also like to kill the jobs as well. Again, jobs -k and then the ID. This just clears up the jobs in the session so that nothing really interferes with each other. That way it's just like a little bit easier to avoid like any sort of problems with like port allocations or anything like that. And we're going to use a different module this time. I'll go ahead and load it up here. It's going to be Windows, browser, Foxit, reader, plugin, URL, BOF. So with this exploit here, again, we can show targets. There's two different types. There's automatic and specifically Windows 7 with Firefox 18, with Foxit Reader 5.4.4. You'll see these are very specific versions. A lot of the time, these exploit modules are very specific to the version, which is why it's important for us to be able to nmap to figure out what versions of things are running. Then you can look up the versions using the search, and then you can generate out the exploits and attack, right? So in this case, I'm just going to leave it as the default, which I believe is automatic. And let's go ahead and show our options as well. So with our options, we can set up the local host and port that we're listening to. We can give it SSL information as well. I'm going to leave these all as defaults because we don't actually have to change anything, really. We just can hit exploit. And what you'll see here is that there's now a server that's running on this IP address at this path. And essentially what happens is if we go onto our Windows machine here, let me just make this so that we can see both at once. I'm going to launch up our vulnerable Firefox, and we're going to go to HTTP 10.115.43:8080/847 YKGS-EQWX4QD. And you'll see this is trying to load the plugin container for Firefox. And in this case, it actually fails, and the container crashes. So this is something that could potentially happen when we try to load this. It might potentially crash the plugin instead of actually running successfully. You'll see the second time I ran it here, it ran successfully. So this is the thing about some of these exploits. Some of these exploits are a little bit finicky. Sometimes things load successfully, sometimes things don't load successfully. Not all of them are 100% error free, right? Obviously, they're exploits. They don't always run perfectly, right? We're basically making programs do things that they really shouldn't be doing. Sometimes they'll crash. So you'll see here, all the user really sees is that the plugin crashed and there's no report available. So doesn't really tell them much information like before. They wouldn't really realize that they've been compromised. It would be very easy to sit on an open network and redirect people's traffic to this URL. They go to this page, they see this plugin crash, they go, what the heck happened? They close it off, you end the sniffer, you have a shell onto their device. They don't know any different, so they keep on using their computer as is, and then you can compromise their machine. So this is sort of an example of how we could potentially leverage this sort of attack. Now, like before, we have the sessions available. In this case, you'll see that we actually just have a interpreter session right off the bat. We don't actually have to do anything more with this. We are already in. If I do an interactive shell with the ID 4, I've already got access to the machine. As you can see, I can see everything here. Just one interesting fact here is where it drops you in terms of directory. You'll see that it dropped us in a very specific location, right? Oftentimes, it will drop you into the actual program files of the application that you exploited. So in this case, we exploited Foxit Reader. I think it puts us right into the Foxit install directory or run directory. So this is the sort of thing that will happen when we do these exploits. So you might have to CD up a few times. And just like as an example of things that we can do, we have access to the XAMPP directory. And inside of there is htdocs. So obviously this is running a web server, right? And then from here, I could potentially
maybe make a separate page like hello.html. I don't know. Oh, it actually won't let me launch Nano. You would have to actually just write it on your computer and then upload it. There are commands to upload files, right? So you can just copy the file over. And then you could potentially add web pages or modify web pages just through this, right? So this is a great example of an instance where we can basically attack a machine. This machine has a web server on it. We could compromise the web server, change the HTML files, delete HTML files, modify them. We could really do whatever we want here. This is a very intense, really bad attack to have happen to you, right? All the more reason to keep everything up to date on your computer and not have old updates. So this is a good example of why you would want to do that. But hopefully this gives you a really good picture of how you can use Meterpreter, right? We ran through two different types of attacks, one that involved files, one that involved web browser. Essentially, the moral of this is that you want to understand how you can find what you want to find in Meterpreter, right? So you can find things through the search command, right? So you can search for things like, where if XAMPP has any. Oh, sorry, I have to exit out of that shell. That's why that's not working. Right, you can search for things. In this case, it cached our open Office one. And then you can find specific vulnerabilities based on the information gathering that we did previously, right? So you can search for specific vulnerabilities. And then once you get into the vulnerabilities, really it's just a matter of doing like show options, see what kind of options we can set, show targets, see what kind of targets we can attack. And then setting up all those that we need to, hitting exploit, and then you're done, right? So it's very easy to use Metasploit once you understand those few pieces. But yeah, this should give you a really good idea of how you can essentially learn any of the modules and be able to pull off any of these attacks. Now, one thing that I wanted to note here before we end this video off is when we have these descriptions here, I discussed how we can get to the Rapid7 links. If you're looking for a bit of a better way to search vulnerabilities or look at vulnerabilities, I often find that the Rapid7 site is a really good way to do it. So let me just show you how we can do that. So let's go to the Rapid7 webpage here. And we're going to go to the vulnerability and exploit database, which is just one path up from here. If you select module are all of the Metasploit modules that exist. And you can see here, it's showing all the different ones that exist. So you see if I'm looking for like OpenBSD, for instance, this one exists. And the disclosure date will tell you when this sort of came into existence. So the sooner the disclosure date, like the closer it is to the current date, the more likely it is to work on more devices because it won't be like completely out of date. Like for instance, this Chrome debugger one, right? If we take a look at this one, it will impact Chrome. And it will allow you to read files off of the remote system or make web requests from a remote machine. So we're able to essentially gather information off of the machine in terms of files that exist on it and web requests. This sort of thing works on Chrome. Very likely most versions of Chrome will be vulnerable to this given that it was just disclosed now. It's probably fixed already. However, a lot of people don't pick up the updates immediately, right? But anyways, as I was saying, if you wanted to search for something specific, like say Windows 7, right, you can search for that here with modules. It'll show you all the modules that apply to Windows 7. So for instance, like Foxit Reader. I think this might be the one that we were working with actually. Let's see. Oh no, it's a slightly different one. So it's on version 9 in this case. It will show you the version that's actually impacted. It will show you where it's been tested. And one thing to note, just because it's been tested on specific operating systems doesn't mean it only works on those operating systems. Feel free to experiment a bit. Try it with different operating systems. Try it with different versions. You might get lucky and find something that works on multiple different versions, multiple different operating systems, right? So this would be how you would be able to search for those. You can search specific version numbers, and yeah, you can get a lot of really great information off here. So this gives you a place to be able to get the vulnerabilities that exist, and also a place to be able to write the exploits and execute them against targets. So this gives you a good idea of how to use Metasploit to be able to compromise targets.
To start things off, we're going to take a look at how we can set up a testing environment for us to be able to try out all these different techniques that we're going to be using for Android vulnerability testing. This sort of setup is going to be something that will be able to be used with any sort of application that you're trying to test or do vulnerability analysis on. Most applications are going to work in emulators through Android Studio. So if you don't have an actual Android device, you'll be able to access it through Android Studio to be able to at least emulate it. So you can download Android Studio from developer.android.com/studio, this URL right here. And you're just going to go ahead and download the Android Studio version that corresponds to your operating system version. In this case, I'm using Windows. So once that's downloaded, you're going to get this application that you'll be able to run. And essentially, we'll just walk through the installation in this video, and I'll demonstrate how we can set up some emulators that we'll be able to utilize throughout these videos. The Android Studio IDE is also going to come with a lot of different tools that are very valuable for us that will allow us to interact with our emulators and our applications. So we're going to go ahead and hit next. We want to get Android Studio and the Android virtual devices, so make sure both of these are checked up. It will take up 2.3 gigs of space. It doesn't really matter where you install it to, just install it wherever you would usually install your stuff. And then hit on install, and it will go through the installation process. So once this installation process is complete, you'll have the Android toolkit that's like ADB and those sort of tools that we'll be using throughout this. And as well, you'll have access to write your own code as well as run emulators. So if you ever want to test specific concepts, Android Studio is a good way to do it because you're able to actually write code inside of it. In addition to this, you'll have some emulators set up and you'll be able to access and work with those. So we'll discuss a bit about working with emulators as well to get an idea of that, and that will be sort of in future videos as well. Once this is completed, we can hit next and finish to launch Android Studio. So now it will ask you whether you want to import any settings or not. In this case, I do have an older install that I can import from, or I could choose to not import settings. For your first time, you probably won't have to import anything at all. So in this case, again, because I had an older installation, it's going to ask me about things with system files, and I can sort of delete those directories just to clear up some of the data that's there. And then from here, we'll launch Android Studio. Now, launching Android Studio will take a little bit of time. It's an application that typically is a little bit slow, I guess you could say, on a lot of computers. It really depends on your computer. It might take a little bit of time to actually boot up to begin with, so don't be alarmed if it takes some time to start up. See, once you get here, we'll load in the components, we'll load in the modules, and then once this is done, we'll be able to access what we're really looking to get to, which is the emulators. Now, I don't necessarily think that you have to install all of Android Studio in order to get to the emulators, but I think it's good to have the whole thing available. Just that way you're able to have all of the features that come with Android Studio, because there's a lot of helpful stuff inside of it. So you'll see that you'll load into the Android Studio page. Yours might not look exactly like mine, because mine has a current application that's being developed. So yours might look slightly different. However, you should have all these toolbars available to you. And the main toolbar that we're interested in is this one here, which is the AVD Manager. If you don't have access to it through here, I believe we're able to get access to it through the view. There's a few different tool windows that are available inside of here. And you just want to make sure that each of your toolbar and navigation bar and main menu and status bar are all enabled so that you're able to access this. When you click on this, what it will do is it will load up a page that will show all of our Android virtual devices. And you see in this case, I have none available, which means that I can just create a new virtual device in this case. So these virtual devices will have a little bit of customization. You'll essentially have access to be able to create things that mimic the hardware of any of the Google devices. See that there's phones, there's TV, there's the tablets, the watch OSs, the automotive OSs as well, so you can emulate any of those. And you can pick really any of these that you like. Let's just say I'll pick a Pixel 3 for this example. And you'll see inside of here there'll be a whole bunch of different operating systems that you can pick. And you'll have to download them the first time that you want to utilize them. But you'll see on here, you can see which version it is. So there's Android 10, Android 9, Android 8.1. So you can really pick whatever Android version you'd like. For this one, we'll just use Android 9.0 because I have it downloaded and available. There aren't really too many major operating system differences when we're working with vulnerability analysis of applications, but in general, you just sort of want to pick operating systems that are supported still. So whatever's supported by the application you're looking to pen test would be what you're picking out of here. But in this case, we'll just pick 9.0 for this example. And you'll see we'll be able to give it a name. So I'm going to call mine Pixel 3 vulnerability analysis, just to give it a unique name so I know what it is. And we can customize other details about it, such as the startup orientations and the performance pieces. Usually I just leave these all as default and click finish. And now we'll have the device available to us. So you'll see from here, we can just click on the play button, and this will actually launch the device for us to be able to use. So let's go ahead and try that and let it run. Again, it might take a few minutes for it to launch. The emulators as well tend to be a little bit slow to start up, but once things are started up, then it starts to run pretty well, and you'll be able to work with them relatively flawlessly, depending on how fast your computer is. I think most modern computers would be able to run emulators fairly well. Of course, emulators aren't really computationally intensive for the phones because the phones themselves don't use a huge amount of hardware comparative to computers. But yeah, again, your mileage may vary depending on what kind of computer you're using. And just while this is loading here, I'll also note that if you have an Android device, you can utilize it for this testing as well. The reason why I use emulators myself is because we're going to be installing purposefully vulnerable applications onto these devices. So we don't really want to do that on a live device. We mostly want to do that on emulators so that we aren't impacting the performance of our actual devices themselves. But if you do want to utilize it, you can simply just plug in your USB device. And then you'll have to enable USB debugging, which I'll talk about in a future video, to be able to actually get onto the device through ADB. And then from there, you'll be able to follow along just as if you were using an emulator. So just keep in mind, you don't necessarily always have to use the emulators. You can use things such as devices as well. So those will work too. So we can tell that this is working and running because the size on the disk is increasing. As the emulator launches, the size on the disk will slightly increase. I think usually they end up taking about 9 or 10 gigs. And then as you install more stuff, they'll start to take up more and more space. So that's just something to generally keep in mind. You'll notice down here it also says that it's indexing. A lot of the time Android Studio is going to be working through different things to index and get things set up. So again, just be patient with Android Studio. It will eventually start to run the things that you need it to run. So this always gives you a good idea about how we can install the environments that we'll be able to test with. In the next video, we'll take a look at how we can use ADB to shell into a device. And we'll also take a look at how we can then install the applications that we want to work with in these videos. And then from there, we'll dive right into the vulnerability analysis and take a look at the different types of common vulnerabilities that exist. Take a look at how to analyze applications and figure out what common vulnerabilities we might want to look at. So that will be what we take a look at in the next video. For now, you've got your emulator set up, you've got your environment set up, so you should be ready to progress on. So now that we have an emulator set up, we are able to start to work on building our test environment on the actual phone itself. And for this, I'm going to discuss a little bit about how to use ADB to give you a little bit of fundamentals on that. And we'll also take a look at installing a purposefully vulnerable application. Now, the vulnerable applications that I'm going to be using in this, one of them is going to be this one here. It's called Diva. And I'll include these links inside of a resources section at the end of the course, and that way you'll be able to access all of these links as discussed, and I'll discuss which videos the links are actually utilized in and that sort of thing. Just that way you're able to access them without having to type this out word for word. So once we download this, we'll be able to get an APK, and that APK will be able to be installed on the device. I have another APK, which is Insecure Bank V2, and this is another APK that we'll install. It's another insecure application. Again, I'll place the link for this inside of a resources section in this course so that you're able to get access to that and download the APKs as well. So the very first thing I'm going to discuss is if you're following along on your own Android device and you aren't using an emulator, you're going to first have to enable USB debugging. And to do this, you're going to go into your settings, and you're going to have to get access to the developer tools. To do this, it's a little bit tricky. You have to go into your system, and then you have to go to About, and then you're going to scroll down to Build Number, and you're just going to tap on this until it says you are now a developer. Once this is done, you should now have a developer tools option in your settings. And on this one here, let me restart my settings to make sure that it shows. If you can't find it, you can try typing it in here. You'll see developer options. It's under system and then developer options in this case. So yeah, under system, and then there should be developer options under advanced. It will be in different locations depending on your device. The easiest way is just to search it in your settings to find the developer settings. So inside of here, you'll be able to get access to a lot of different things that are commonly used by application developers, and a lot of these settings may be useful for you while debugging applications or trying to test them. But the main one that we're interested in right now is USB debugging. You want to make sure that USB debugging is enabled. Enabling this will allow you to access your device through the command line of your computer using the ADB tool. So that's just one thing to note. If you're on like an emulator, you won't actually have to do this step because it comes enabled by default. So from here, we can launch up our command line and we can take a look at how we can access our device through the command line. So there is a tool called ADB, which is installed typically with Android Studio. And it has a whole bunch of different tools that allow us to sort of manipulate our device and be able to install different APKs, for instance. Querying content providers is another common thing. There's a lot of things that this is very useful for. One of the main things is getting a shell into your device to be able to navigate through it and to download pieces and all that good stuff, right? So if you type in ADB devices, in this case, it just had to kill off the client and then start it again. But you'll see it will give us a list of devices that are currently attached to our computer. So in this case, we have one device, which is the emulator. So if I were to type in now ADB shell, what this will do is it will create a shell into the device itself. So you can see now we have a shell on the device. If I type in something like ls, for instance, it will list the directories. So this is like a classic sort of computer shell, just on a mobile device instead. So this is one thing that's very nice to be able to do with ADB, is to be able to shell onto the device to gather information, for instance, to be able to like find out where an app is installed or navigate to a specific directory that we're trying to access, or just see data that's on the device. A lot of this you might not have permissions to. If you have a rooted device, you'll be able to escalate yourself to root and get permissions to these aspects. But typically you won't have permissions to everything. If we're trying to do this as a legitimate user, we typically don't want root because we want to be able to do things that any sort of user would be able to do. So that's one thing that we're able to do with ADB. And if I type in exit, it will take me out of the shell. Now, what I really want to do is I want to install these two APKs that we have downloaded. So one way that we could do this is I'll cd to the directory. And then what I can do is I can type in adb install, and then I type in the name of the APK. And you'll see it will say performing streamed install and then success. And now you'll see on my device, I should have I have the Diva app available now. So you can see that installed the application for us. And then I can do the same with the Insecure Bank. And you can see that will install the app as well. So that's the main thing that we're looking to do with ADB, is just get these two applications installed. And now that you have these two applications installed, you'll be able to now follow along with all the different tutorials that we do with those two apps. So these two apps, again, have purposefully insecure setups, which will allow us to sort of manipulate through them and attempt to attack them as we would maybe attack a legitimate application. So using these, we'll be able to discuss a bit of like the ideology of attacks and be able to actually practice it on legitimate applications, right? So this will get you set up with all of the things that you need to be able to follow along on the emulator. So from here, we'll be discussing the actual concepts related to Android vulnerability analysis and Android penetration testing. One of the things that will be very helpful in terms of analyzing Android applications for vulnerabilities is the ability to decompile the application back into its source code. With Java and languages that are similar to Java that compile into a bytecode that is run against a virtual machine, it's possible for us to reverse the compilation process to turn the bytecode back into something that resembles the original source code. Now, the matching won't always be perfect. You will lose some information typically from it. However, most of the important pieces are going to still be there. And since those pieces will be there, we'll be able to not only understand what the application is doing, but actually be able to see the source code and be able to pick out specific vulnerable aspects that we want to be able to work with. So in this video, I'm going to demonstrate how we can reverse engineer essentially, or decompile an application. So there's a lot of different ways that people will typically use to do this. There are tools like APK tool and JD that will allow us to essentially decompile the application and then reverse it back into Java code. I actually use one called JADX. And again, I'll put links to these inside of a resources section. But inside of here, there's essentially in the bin, there's a GUI that we can launch. When we launch this, we're able to actually decompile any APK that we may have on our computer. So I'm going to come into our directory here, and I'm going to grab the Diva application that we installed, and I'll run this through the decompiler. And what you'll see here is that we'll get a set of source code and the set of resources that are used inside of this application. When you're first looking at an application, there's a lot of different information that's valuable to us. The manifest file is one that's going to be extremely useful. It's going to tell you a lot of different things, such as the permissions that are used by the application. It will tell you what activities exist inside of the application. It will tell you about intents. It will tell you about things like content providers and such, if they exist. It will tell you what versions we target. It will give you a whole plethora of high-level information that will allow you to better understand the attack surface that you're working with. So this is one file that would be very useful for us to be able to look at. Resources are going to be a lot of like the graphical interfaces and such that you're going to be working with. A lot of this really isn't particularly useful. I don't think most of the time this is just sort of like sort of trivial information that comes from this process. The meta inf will tell you different informations. There's some certificate details that are sometimes potentially helpful, as well as the manifest file, which could tell you a little bit of valuable information. Potentially it gives you a bit of a layout of all the things that exist inside of like the res folder, and it'll allow you to get a bit of an understanding behind like the contents of the manifest, for instance. And then we also have this lib folder, and this lib folder has any sort of shared object libraries that are used inside of the application. These are typically written in C or C++ and compiled. These can't be decompiled. What we can do with these is we can analyze like strings that may exist inside of them. We might be able to break it down into something that might be able to tell us some information about the shared library or shared object, but a lot of the time, these are things that we won't be able to necessarily dig into too deeply. But you'll see in a few examples, we actually can go through these and gain some form of relevant information. And then finally, we have our actual source code files, which are the actual source of the application itself. If you take a look at these, you'll be able to see like each of the different pieces that goes into building the actual application itself. So you can pull up any of the code that actually exists, and you'll be able to see exactly what code is being used. You can do this sort of thing with I would say basically any Android application, and you should be able to get source code unless it's like heavily encrypted or obscured in some way. This will typically be possible. So a few other things that are useful for this, we can search this for specific keywords. So for instance, if we find like an error message or something like that that we want to look up, we can try looking that up. We can try looking up common things like password. So you want to check off like what you actually want to search. You could search classes, you could search methods, fields, code, for instance. And you can see here, we can sort of like pick out pieces of information that might be of interest to us. So here's an example here where we're inserting into SQLi user a username and a password, it seems. So this, for instance, would be some information that we might be able to gather from decompiling the application. So this gives you a bit of an idea of how we can actually decompile Android applications. And from here, we sort of have all the tools that we're going to need to have to be able to analyze different applications, to be able to look at common Android vulnerabilities. So that's what we will take a look at next. We're going to take a look at the idea of insecure logging. When we're actually working with applications on Android devices, we're able to log things into the logcat logs of our device. Now, when we log things to these logs, we have to be careful of what sort of information we're writing to them, because we could potentially expose information that is sensitive. So we're going to take a look at what this would usually look like inside of an application and how we can sort of find these vulnerabilities and determine if they exist. So first, I want to explain a little bit about what this vulnerability is and why it's important. So there exists a general logging area on Android devices that is typically referred to as a logcat. Now, if I open up Android Studio here, you can actually see the log here. So you can see here that consistently information is being logged to this log, and this log is shared by basically all of the applications on the actual device itself. And you can write things to the log fairly easily using some built-in functions inside of the Android the Android development modules, right? So you'll be able to actually write information to these debugging logs. Not only can you write to them, but you can also read them to see if a specific error has occurred. The reason why we don't want to log any sensitive information to this is sort of twofold. For one, as you can see here, I can easily access the logcat logs just by having the device plugged into my computer or by having the device running through an emulator on my computer. But more so, that what's important to this is that somebody can actually create an app that can read this logcat log. That means in turns they can read any messages that are logged to here. So if you, for instance, are logging information about a user's password or something like that, if I have an application that's like sniffing the log file on this person's device, I'll be able to see that information as well. So this gives you some context behind what this vulnerability really is and why it's important. So it's not really just a matter of like logging information that is sensitive, such as like an API key or something like that someone might see from, looking at the logs. It's also a matter of someone, a third party sort of like sniffing the logs of a random device to grab information about the user. So to give you an example of this, let's go ahead and open up our Diva application. And we'll go into insecure logging. And I'm going to demonstrate to you what exactly this could look like. So you see here, we want to enter in our credit card information. So I'm going to put in my credit card information and press checkout. When I do this, you're going to see right here that there's an error message that gets processed. It says error while processing transaction with credit card, and then it prints out the credit card number. So this is something that we want to avoid. This would be an example of insecure logging. And the reason being, again, is because if we have a third-party application that's, say, sniffing this log, if they see this error message, it exposes the credit card information of the user. So this is extremely bad because obviously then people can potentially have an information disclosure. They could end up showing information to someone else that shouldn't see that information, and they'll be able to compromise them with it, right? So we can take a look at the source code of this that we've decompiled to get a bit of an idea of what this is actually looking like in the code, just to give you an idea of what sort of things you can look out for this. So we have this log activity. This method here, log.e, is what happens when we're trying to log an error message. So there's like log.e for error, I think log.d is debug, and there's probably a few other ones that are very common. And as you can see here, it gives the actual error message, and you can see it actually writes in whatever is inside of the text box of the credit card field. So you can see this is what the actual log message looks like. So if we're looking for these sort of instances, we can look for like log.e or log.d, and these will show us where logs are being written to the actual to the device log itself. And then from there, you can try triggering these or looking at what is actually being logged to determine if that information is sensitive data or not. So common sensitive data would include things like passwords, even usernames, credit card details, obviously personal details, anything sort of related to that. API keys of the application would be a common one, even database table names, databases in general. This sort of information leakage is the kind of stuff that we want to make sure isn't happening in our application. So this would be an example of insecure logging. So this gives you an idea of what this vulnerability looks like and how to actually detect it in an application. Another common class of security vulnerabilities on Android applications are known as hard coding issues. With hard coding issues, they're mostly the act of hard coding information into our source code that is potentially exposing information about how the application runs, or maybe exposing something like a username or password or some sort of sensitive data. So we're going to take a look at two types of hard coding issues in this video. The first one is sort of the classic hard coding issue where we've hard coded a password into some Java file, and since we compile it, we figure no one is going to be able to decompile it and be able to get to that password. However, that's not the case, as we can see through decompiling. And then the other one will be a little bit more complex, which will involve actually shared libraries and shared objects and discussing how we can potentially extract passwords from those as well. So you'll see in this, we need to enter in some sort of vendor key in order to access this section. So if we try to access it, we'll say access denied if we enter the wrong values. So in order to extract the password for this, we need to find first the activity that corresponds to this login page. And in this case, it would be hardcode activity. Now, a lot of the times it might not be named exactly like this. It might not be as easy to find the activity. If you need to try to find this as well, you can also take a look at the log messages or the displayed messages in the alerts. So as you can see, this one has that same access denied message, so we know that we're probably in the right place. Now, looking at this code, we can see that we're taking a look at the HC key text field. We're getting the text and we're checking if the string equals vendor secret key. So as you can see, we've hard-coded in the password, and this means that it's very easy for someone to decompile this application and figure out the password for this. So now from here, we can just type in vendor secret key and press access, and as you can see, access granted in this case. So this is one type of very common hard-coded activity problem where we hard-code a password in plain text rather than doing something like obscuring it or encrypting it or hashing it or putting it on a server or something like that. There's a whole lot of different things that we could be doing that aren't this. Primarily, we would be wanting to potentially hash the password in order to protect it, but even then, someone could get the hashed password and try to brute force it with an offline attack. So that's not really the best way to do it. Typically, what we'd want to do here is sort of verify it on server side or place it somewhere that someone wouldn't be able to access it if they decompile our application. So that'd be the key idea. So let's go ahead and discuss the other type of hard coding issue. And this one is relatively similar. Again, we have to enter in a password. If we get the wrong password, it will give us the access denied message. And if we enter in the correct password, it will say access granted. When we look at the hard-coded activity, which is hardcode 2 activity, you'll see that things are slightly different here. You see it's grabbing djni.access. So this is a method from the djni object, which is this one here. So what we want to do is we want to find this class to determine what the access method is actually doing. So if I go into this class here, which I have here, diva.jni, you'll see that there's a static load that happens. So it's loading a shared library, and the SO name is diva.jni. So as we discussed, we can find shared objects under resources, under library, and you'll see that it's compiled for every different type of processor, but each of these shared objects are going to be the same, the main difference being the assembly language that it's targeting. So really any of these are going to be able to give us information. So these shared object libraries, as we discussed, they can't really be decompiled in the traditional sort of way. We can't go from a shared object to source code. However, what we can do is we can search these shared objects for strings. So what I mean by this is that any sort of static text, we're able to extract from these shared object libraries. There's a number of different ways to do it. I like to use a utility called strings. And what strings does is it essentially allows us to search the whole library for these static strings. So you can see here, I've grabbed a copy of the library. If you want to grab a copy of the library, what you can do is you can change this APK to a zip folder. And then once you do this, you can open up the zip, and then you can go into the libraries folder like before, and then extract the value from there. So that would be the way that you would be able to extract it if you're looking to extract it onto your device. And then utilizing strings, we're able to search it for any sort of text that may exist. So let's go ahead and open up command line. I'm going to go ahead and cd to this directory. And then the way that it works is we just go strings.exe, and then we type in the name of the file that we want to search. So it would be the libdiva.jni.so. And you can see here we get all the text strings that are existing inside of that .so file. Now, from here, we have to do a little bit of thinking to be able to extract out the ones that are important to us. You'll notice all these dot ones here. If you have some familiarity with assembly languages, you'll know that these dots will typically correspond to labels or points to jump to. So these dots, text files text data, they aren't really as important to us because they're just divisions of the file itself. So we aren't really interested in those. You can see that these GNU and GCC are probably telling us what this was compiled with. So this information, again, isn't necessarily relevant or interesting. The gold 1.1 looks to me like a version number of something. And we can see here GNU :version. So this is probably just a version number. So that's not necessarily important. You can see these are other shared objects that are being used. So again, these aren't really particularly important. These again are mostly labels. So it's indicating the end, the BSS start, the E data. So those aren't really something that's going to be interesting. Similar with these here for the same reasons. str copy is a C function that's likely being used inside of here. These appear to be just like information about the actual library itself, which will leave us with these three pieces of information as well as this. So when we're taking a look at these, we sort of want to extract which ones are relevant to us. So from these, we can sort of essentially just trial and error them to see which one is the correct input. There are some other ways that we can sort of like look at these and be able to decode information from them. Usually when they have like the $ character inside of them, it means that there's some sort of scripting thing related to them. Potentially it could be like an argument in a bash script or something like that. A lot of the time these will correspond to like code lines, for instance, which means that this is probably the only one that's just general text. So if we think that this one is the right one, then we can bring it over here and try to input it in and see what will happen. So OLSDFGAD semicolon LH. When we try to access, you'll see that we get access granted. So obviously this is the proper password for it. So you can see from here that even though we can't necessarily decompile the shared objects, we can still search them for the strings that exist in them. And if we have a hard-coded string inside of there, we're going to be able to extract that string and potentially leak information such as the password. So this video gives you a bit of an idea behind how hard-coded text is able to be utilized to potentially expose data about Android applications. So these sort of vulnerabilities do happen every so often, and a lot of times the shared object ones are maybe a bit more common because people are a bit less careful when they think that the thing can't be decompiled. But also if they obscure the files at all, if we can sort of like manage to unobscure the code or unencrypt the code, we can potentially figure out these passwords. So not only are plain text information necessarily a bad idea, but also even just like putting hashes into the code could be dangerous, because then you can do like password-based attacks to try to decrypt them. So this gives you a general idea of the sort of things that you can look out for these types of vulnerabilities. So now you can take a look for these in any applications. For the next section, we're going to be taking a look at different ways of saving data and which ones are potentially insecure. And one thing that's going to help a lot with this is actually having access to a rooted device or a device that we can use super user with. And in order to do this, we can do it using emulators inside of Android Studio. So this doesn't require you to root a device or have your own rooted device. There are actually a few that are built into Android Studio, but the way of accessing them is not always particularly clear. So I'm going to show you how to set up a rooted device and access it through ADB through Android Studio. So we're going to create a virtual device as we typically do. And the devices that I like to use for these are any of the ones without the Play Store icons on them. And usually, for instance, I would pick one that is just sort of like a generic device. The generic devices are usually just like more compatible with the different images, but it doesn't really matter in reality which one you pick. Really, any of these will work, but I think without the Play Store icon is typically what we want to stick with. So I'm going to pick the 5.4-inch FWVGA, and we'll hit next. Now the image that we're using is also very important. Instead of using the typical recommended images, we want to use an x86 image, and we want to use one that will not have the Google API included. Or, well, you can pick any of the ones with the Google API as well, but you want to pick one from here that doesn't have like the typical play setup. And what I mean by that is essentially like when you're taking a look at these ones are produced specifically by Google Inc. And these ones are through the Android open source project. So to give a little bit of background, Android is an open source operating system, which means that anyone can build images of them. The images that are in the x86 images are more generic. And essentially the benefit of this is that we're able to do things such as like accessing the root permissions on them, rather than the ones that are built by Google, which they have locked down to the point where you aren't able to access them without finding some form of exploit to be able to do that. So in this case, I'm using the Pi one, which is 9.0, the x86 build. So once you've selected the one that you want to use, you can click next, and then we'll give it a name. I'll just call this one, I'll call it rooted 2, because I already have one that's rooted. and we'll press finish. Now, when we boot this up, we'll get the typical sort of Android emulator device. This specific one that I picked has a bit of a larger resolution compared to the original one that we were working with. So I'm going to go ahead and let this boot. And while that's booting up, I'm going to launch up my command line. And what I'm going to do is I'm going to demonstrate to you how you can enable the root permissions and the root aspects of Android through this device. So once you have the device booted up, you're able to still utilize like ADB in the same way. So you could do like ADB shell to shell into the device. You can also use ADB install to install the applications onto the device that we've been using. The main thing is once you're inside of the shell, typically we don't have full permissions. So you can see here permissions are denied, for instance. Now, if you want to fix this, you can just type in SU. And this will escalate you to super user, which you can tell by the pound symbol that is now on the command line instead of the $sign. Once you have this, you'll see that you no longer get the permission denied errors. This means that you are now a root user on the device. So it's really as simple as this. Now, again, the reason why I want to show you this is because there are specific folders, such as the data folders here, that will store data for all of the applications. And as you can see, as a root user, we can access these files. So a lot of the times when people are making applications, they'll save data to these files that is sensitive data. And if we're able to access it as a root user, then it could potentially mean that there are vulnerabilities. For instance, if they're storing things like their API keys or something like that, or they're storing data in the database that is like confidential to them, then we might be able to access that and be able to exploit that information. So that's what we'll take a look at in the next video. For this, I just wanted to show you how to get a rooted device through the Android ADB system. So in this video, we're going to take a look at insecure data storage. So there's a lot of different ways to try to store data in Android applications, and a lot of them may appear secure on the surface. However, with the proper permissions and setups, you will be able to gain access to them as someone who is not supposed to gain access to them, which in turn can mean that you can compromise sensitive data either from the user or from the developers themselves. So this is sort of like a two-sided vulnerability. In sense of like getting user data, it's a bit of a weaker vulnerability because it requires root access to be able to access most of these files. There may be ways, however, to get access to these files without root permissions, and that would be an indication of a vulnerability. However, if there's specific like developer secret data inside of these files and we're able to access them, then this would be a vulnerability whether or not we have root access, because we shouldn't be able to get access to those sort of secret data pieces such as API keys and passwords and that sort of good stuff. So in this video, we'll take a look at a few different types of vulnerabilities like this. So the first one is the insecure data storage part 1. With this, we can enter in, say, a username and a password, and we can save it onto our device. So we enter in the username and password, and then we hit save, and it will say third-party credentials saved successfully. When we take a look at the code for this, we can see that when we save the credentials, it's using what's called a shared preference. Now with shared preferences, they're essentially specific types of files that exist in a standard directory, and these files will be able to store different pieces of information in them. And the idea is that when we're trying to access data, we can access it from a known location that is sort of local to the application and not accessible unless you have root permissions. This works very well for trying to store data that isn't sensitive. So I don't know, just like data that's generally used by the application, maybe like locations of images or like a set of questions for like a survey or something like that. These sort of things wouldn't be sensitive because they're accessible by the user through the application. However, if we can access something that isn't accessible to the user through the application, this would be an instance of information disclosure. So how do we gain access to the shared preferences folder? What I'm going to do is I'm going to go ahead and shell into my device. And when I shell into my device, I'm going to go ahead and make myself a super user using the su command. And then what we're going to do is we're going to cd into the data folder. And then inside of here, there's another data folder. So we're in data/data. And inside of here, you'll see data for all of the applications that are on your device. So all of these applications have data associated with them. This one right here is the folder associated with Diva. The name will always match the name of the application itself. So we can cd into that folder. And you'll see inside of here we have a few different options. We have the cache, we have the code cache, we have databases, we have the libraries, and then we have our shared preferences. The shared preferences is where we save all the data that's written using this shared preferences object, right? So anytime that we do this, we're going to be saving into that shared preferences folder. So now if I cd into shared preferences, you'll see that we have this single XML file. And if I use the cat command, I can see what's inside of that file. I mean, alternatively, you could also pull it off the device and read it, but the cat command allows you to see it quickly. And as you can see, it stores the username and password that we typed in. So whatever we type in inside of there will be what's stored here. So for instance, if I change this to password 1, for instance, and save it, then we should see that this will change to password 1, which you can see right here. So you can see that this would be considered insecure data storage because I can gain access to it just by having a rooted device. The fact that I have a rooted device is sort of irrelevant to my ability to access this data. I shouldn't be able to get usernames and passwords whether I'm rooted or not. So this would be an example of insecure data storage. Right? And then you can go into the other pieces the password really should be hashed or something like that. In this sense, it really doesn't matter if it's hashed or not because you can offline brute force that password and potentially gain access to it, and you'd know how it's hashed based on the code. Since we have access to the code, we have access to the password hash. Therefore, unhashing the password or finding the hash that corresponds to that password wouldn't necessarily be hard, unless the password's extremely long. But there are certain instances where it could be a weak password, we might be able to compromise it and gain access. So this is something to note about these shared access points, is that they are accessible by root users. So we really should be favoring things like online servers if we can, or sort of hardening these down, like password protecting the files or password protecting a database, for instance. And speaking of databases, we could take a look at database storage as well. So let's go ahead and I'll go back here. And we have a second insecure data storage. So in this one, again, I can put in username and password. And again, when I do this, I can save it and it will save it successfully. So if we take a look at the code here, you can see that we're inserting the data into a SQLite database, right? So in general, most databases that you work with through Android are going to be SQLite, but you can also tell that because of the import up here that says SQLite database that exposes what kind of database is being used. So you can see that this information is being saved to some sort of database. Then we can ask, well, where can we find that database, right? And the answer is, if we cd up one directory, we'll see this folder called databases. If we go into the databases folder, we can see that there's a bunch of different databases that exist inside of here. Now, we want to determine which of these databases is the correct one. And we really just have to sort of look at the different things that are available here. You'll see open or create database, IDs2. This tells us that the IDs2 database is the one that we're likely looking for. So what I can do is I can say SQLite 3 IDs2. And as you can see, this opens up the IDs2 database inside of SQLite. And then from here, you can type in a command like .tables, and that will show you the tables that exist in the database. And then we can do just a simple select star from my user. And you can see it exposes any users that were inputted into this input field, right? So I did the test one earlier. Username and password was the one that I just did. So you can see that this very easily exposes the user. So again, since I can access this data, it isn't considered to be a secure data storage method because even though I have root access, it doesn't really mean much if I can access the data still. Whether you can access it with root, whether you can access it without root, you're still able to access sensitive data, which you shouldn't be able to do. So this is something that we need to consider as well, is that these databases, if they aren't properly secured, could be compromised. The proper thing to do here is to use a library. There are a few SQL Cipher, for instance, I think is one that's available for Android. And what they'll do is they'll password protect these databases for you through an encrypted process. So anytime that we need to access it, it needs to sort of decrypt it and then run our queries and then encrypt it again. So if this is done, then if we try to access it through the SQLite 3 command, we won't be able to. We'd have to actually crack the encryption on the database. And if that encryption is sufficiently strong, then it would be a much more secure data storage than just storing stuff in plain text out in the open, right? So this is another thing to consider. And this is even before we consider the fact that it looks like this could easily be a victimize of SQL injection, right? You could probably do SQL injection because we're just concatenating stuff into it, but that will be something for another lesson. Anyhow, yeah, so this would be another example of some insecure data storage, is if we store things in the databases that are available to us, a rooted user can still gain access to them and potentially get to those credentials. Now, the third type of insecure data storage is sort of like a more generic type of insecure storage. Again, it's the same sort of structure where we have username and we have password. And again, we can save it and get the credentials saved successfully. And if we take a look at this, really all this does is it creates a temp file. You see it has uinfo in front of it, and it sets it to readable and writable, and then it writes in the username and password and saves it. So when this sort of thing happens, we're essentially saving it local to that data folder. And you can tell that because, so it's get application info.datadir. Datadir is this data directory that we're currently inside of. So when we do this, you'll be able to see that I can, let's quit out of SQLite. And if I cd up one directory, you'll see this uinfo temp folder that's now been created. And again, I can simply just cat that folder and you'll get username and password, right? So you can see that it, again, just saves the data in plain text. Even though it's in a directory that can only be accessible by root, the data is still there and accessible, so you can still gain access to it. So this gives you a good idea of the different types of insecure data storage that exists. So in general, if you're looking at any sensitive data that is stored inside of databases and sort of shared preferences or just inside of temp folders anywhere, a root user can gain access to them. So those folders should be treated with the same level of security that someone is able to access them if they so choose to. So you have to keep that in mind and work with things like encrypted files or encrypted databases in order to ensure that people can't actually access this data, because leaving it out in the open means that if you have a rooted user who's using your application, they can gain access to that data, which could potentially be catastrophic depending on what kind of data is accessible there, right? If it's just their username and password, it's not really that big of a deal. But if it's other people's usernames or passwords or generic information about like the application usernames and passwords, admin usernames or passwords, any of that sort of stuff, then we don't want that to be stored here, because then you can gain access to it. So this gives you an idea of what to look for these sort of things. Again, when you decompile the application, you can look at things like shared preferences and file rights and database inserts to find these sorts of vulnerabilities. Or in general, you can just sort of use the app a little bit and then go to its data directory and see what kind of stuff is available inside of there. So these are some common vulnerabilities that will typically exist inside of Android applications that you are now able to find and report if you find them. So next, take a look at issues that are related to input validation. So when we ever get like input from a user, we should be validating that input in whatever way that we can. So we should be like sanitizing, make sure that they don't input anything that's vulnerable or that could potentially lead to an exploit, essentially. So there are a few different types of input validation errors that can occur inside of Android apps. So we're going to take a look at a few common ones right now. So for the first set of input validations, they have to do with database validation. So when we're inputting things into this, we can see that, for instance, if I put in user here and press search, we'll see user not found. So you can see it will echo back whatever our value that's inputted is, and it will tell us that it's not found, or it will echo back the details of the user, presumably, if we input one that is found. If we're looking for the code that's related to this, we can go into SQL injection activity, and this will show us exactly what's going on. So as you can see here, it's doing a raw query against the database, and this is the query that's actually happening. And you can actually see that when it encounters an exception, it's going to actually show the exception in the error log. So this means that if we go into our logcat, which I've got open here in Android Studio, when I input in something invalid, so for instance, a very good example of this for testing purposes would be like a single quote. A single quote is a piece of SQL syntax. If it's interpreted like code, it should cause an error. You'll see when I search this, we've got this error here that says unrecognized token. This tells us that we're interpreting that token as code rather than interpreting it as an input. So this means immediately to me that this is vulnerable to SQL injection. So let's take a look at how we can craft SQL injection with this. We have access to the query here. And again, this isn't an uncommon thing. If we can decompile the code, we can gain access to the queries. And as you can see, our input is going in right here. So it comes in right in the middle here, right in between two single quotes. What that tells me is that if I can end the single quote and then input something that's always true, and then maybe put a comment at the end, that will allow me to execute where user equals blank, or say 1 equals 1, which is always true, which will return to me the whole database back. So let's take a look at exactly what that looks like. If I put the closing quote here, this will close the user's input, and then we'll say we could say or 1 equals 1, and then we could put a comment. So those 2 dashes at the end is a comment, or 1 equals 1 is something that's always true, and the closing single quote would close off this starting quote here. So it'd be user equals blank, or 1 equals 1, and then we comment so that this end brace here, or this end single quote here, isn't interpreted as code. And in doing this, it will give us a valid query, and that valid query is going to return to us all of the contents inside of the database. So you see when I click search here, it exposes the whole database credentials, right? So you can see that this is an example of being able to leak information from a database using an invalidated input. So SQL injections are a very common type of input validation error that happens in a lot of different instances. So this would be one example, and this is one thing that you're always able to sort of test. Now, not always will you get the errors actually printing into the log. It's actually quite rare that someone would give you that. However, again, if you just sort of like search for raw query or query in general, you should be able to find instances where this sort of thing happens. So this is one type of input validation that's relatively common. I'm going to show you another type of input validation that is rather interesting and a little bit different. So with this one here, you see that we can type in a URL to view. So if I put in like google.ca, for instance, if I press view, you see it brings up the web page for Google. So this is just like a simple web browser, and if we go into the code of it, we can get a bit of a better idea of what's actually happening. So you see here, we have the input validation scheme. You see that it just does a load URL. Now, on the surface, this probably looks quite innocent because load URL would imply to us that we're just loading any sort of, web page URL. However, the interesting point here is that in Android, we actually treat files as URLs as well. So we can actually access files on the system using the URL path of them. So for instance, you could do something like this. You could say file, you go colon, and then you put 3 backslashes, and then you put in the path to the file. So we'll say data, for instance. I'm just going to pick a file that I know exists. So this is inside of the data files that we were looking at. We were taking a look at in secure storage. And we know that there's one here called seam.diva_preferences.xml. So you can see here I've just put in the whole path of the file itself. And it just crashed there. Sorry, let's try that one more time. Not sure why it crashed there. We'll give this another try. Yeah, there are some instances where this app may crash on you. It's not overly common, but it could be from some other testing that I was doing related to this app for input validation. But let's go ahead and try this, diva preferences.xml. You'll see when I click on view here, it actually displays the file below here. So if you remember, this is the file that we created in the improper storage. So this shows us how we can actually access that storage without necessarily even having root permissions. If we happen to know this path, which it wouldn't be unreasonable for us to know it, if we have a rooted device, we can find it very easily, or we can find it through the code. We can actually access it if there's ever like a browser that happens to take in these file paths, for instance. So this is a very critical vulnerability because it allows for information leaks, and we can get to really any sort of file on the system utilizing this. And we might even be able to access this from other applications if it has like a provider that allows us to launch this activity maybe, right? So this is a very common and critical vulnerability. So this is another type of input validation that you can look out for. Something is parsed like a web page utilizing this whole, this load URL. It's very possible that we'll be able to load internal URLs, which are actually passed to files. So this is another type of common input validation. Again, so we have databases and we have URL loading. The third type of input validation is a little bit different, and the way that it essentially works is by calling external libraries. So what you'll see here is this uses the DJNI class rather, and you see that it uses a very specific piece, initiate launch sequence. So what's interesting about this is that if we go to this input validation 3, what we're able to do is we're able to put in some inputs and attempt to get it to launch. And you'll see it gets us access denied in these cases. What we're actually able to do with this is, since it's loading a shared object library, it means that it's probably written in C or C++. C and C++ are relatively infamous for buffer overflows. If you can input something way too big into this input, we may be able to get it to overflow. So, for instance, if I just type in like a whole bunch of A's and I push the red button, you'll see the application crashes. When an application crashes like that, it tells us that there could potentially be a problem and it might be related to buffer overflow. If we want to get a bit more detail, we can actually go back into the logcat logs, and I'm assuming it's probably going to give us some information inside of here when we try to crash this. So let's try this again. Yeah, you'll see there we got the whole like sort of dump. So this right here is what we would call a stack trace, essentially. So you can see it gives us a lot of information here. The main things that you want to get here is that you see the parts of the stack that we've actually accessed. So we can see that we're actually overflowing the stack here. And you can see that it's giving us some errors related to that. Now, what happens here is if we can actually specially craft our input, we may be able to get the device to execute code, which may be able to get us access to execute code under the permissions of the application itself. And this would be an extremely critical vulnerability. This is like a CVS 10.0, but even just getting the stack overflow to happen creates a very critical vulnerability as well. So oftentimes, like with Java, it's not very common to see a stack overflow, but if you're using C, C++ libraries or languages similar to that where you have to do memory management, this is definitely something that's in the possibilities. So if you're able to find something like this, it's an extremely critical vulnerability. And again, the things that you want to look out for this is any sort of class that is loading a shared object. So this DJNI class, we talked about this earlier in this series, but you see that it has like this load library, right? Anytime you see that load library, you might be loading SO files, which are typically C, C++. Now, one other thing that I will note about this is that when we ran strings against this library, one of the strings that came up was strcpy, or string copy. String copy is one of those C functions that is infamous for buffer overflows if things aren't allocated properly. So those are the sort of instances where we can actually utilize strings to see what kind of functions might be getting called. So that reveals to us, the function that's getting called, which is strcpy or string copy, right? So, and we can see that when that is used, it seems like it's causing the buffer overflow. So it seems like that string copy is what's causing that sort of problem. To actually get remote code execution is a fairly more complex topic. It won't be one that we'll talk about in this, but I wanted to demonstrate how you might be able to identify those sort of problems in an Android application to be able to report them. Because again, even just finding a buffer overflow like that is a critical vulnerability. So this gives you an idea of a few different types of input validations that might commonly be found in Android applications. So any of these issues in general are very critical because they mostly allow you to access things you shouldn't be able to, or potentially do remote code execution. So they're all very critical vulnerabilities and all ones that you should be able to relatively easily find if they do exist in an application. So this gives you some of the fundamentals to be able to locate those. In this video, we're going to discuss how to set up and install Drozer. Drozer is an application that is used for Android pen testing to be able to help to automate and detect vulnerabilities that are common for Android applications. It works by detecting attack surfaces of the applications, typically through things like content providers, exported activities, services, and broadcast receivers. And then it allows you to find those and potentially run some automated tests to be able to detect if they're vulnerable to some common vulnerabilities. For instance, content providers could be vulnerable to SQL injection. So we can run some SQL injection code through Drozer to test a whole bunch of content providers at once to see if any of them are vulnerable. So this is a very powerful and useful application. There's a lot of different ways to use it, which we'll go over in future videos. However, for now, I'm just going to demonstrate how to actually install Drozer, just to allow you to get set up with it before we dive into anything more. So the very first thing that you'll need is Python 2 installed on your computer. I'm going to use version 2.7.18 just because it's the newest version at this point of making this video. You can use whatever version 2 you really want for this. That being a newer version of version 2 that comes with pip packaged in it. I think that started as of 2.7.9, but really just pick the newest version and you should have pip installed with it. So we're going to go ahead and run this, and I'll install it for all users. I'll put in the typical Python 2.7 directory. If you want to check if pip is installed, you should see it here with the little hard drive icon next to it. So you want to make sure that, yeah, pip is actually present there. And then we'll go ahead and hit next and let it install Python 2 for us. The reason why we want pip installed is because there are a few dependencies that Droser actually relies on. So we want to make sure that those dependencies are present just to ensure that nothing is broken when we try to actually run Droser. So the general concept of Droser is that it's going to be able to create a link between our device and our computer, sort of similar to the ADB link that will allow us to run some like automated testing and commands through that link. And all the scripts are written in Python. They're all open source on GitHub, so you can see all the scripts, you can contribute to them, and you can utilize them as you please. So you can see here we finished the install for Python. So what I'm going to do now is I'm going to go into command line and I'm going to type in pip. You should see something like this if pip has installed properly. And we're going to go ahead and install some of the prerequisites for Droser. So we'll say pip install. We're going to install protobuf. So we'll let this run through. We're also going to go ahead and install PyOpenSSL. This is another important one that allows us to make the connection between the devices. And we'll say pip install twisted. And I think there's one other dependency. We'll be able to see that when we actually install and run Droser for the first time. But these are the three that are mostly required for a fresh install of Python. There may be one or two more depending on your Python installation. So we'll check those out once these finish off. So in general, Droser can be installed from like the labs fsecure page. This is the general web page for Droser. If you're looking for this web page, again, I'll put more links into a resources section for this course so that you're able to access these links and be able to get to the content that you need. But yeah, that's the general location of where this is located. If you Google search for Droser, it will be probably the first or second result. Sometimes the GitHub page comes up first. You can also go there to get the installer. The installer that I use is the MSI. It's just the easiest one for Windows. There's, of course, Linux and Mac installers as well, just in case you're using one of those. It will allow us to install it for all users, and you have to be a bit careful with this. If you have multiple versions of Python, it might default to Python 3, which you don't want to install to. As far as I understand, Droser isn't really compatible with Python 3, so you want to select Python 2 from another location. So we can click here and say will be installed on the local hard drive. And then we just want to navigate to where Python is. So it's typically under C, Python 2.7. So we'll put in this exact path here. And then once we've done this, we can go ahead and click next, and then it will install the components into the Python 2 directory. The reason why I want the components in the Python 2 directory is because our path variable is set to run anything from the directory where this will install to. So that means that we can run it through our command line and it has easy access to the proper Python installation. So once that's done, we'll be able to click finish. And if you want to test if it's working or not, you can just type in droser.bat console connect. And what you'll see is it will try to connect to the device and it will pop up any error messages that may exist. So for instance, you can see that we get this error, no module named service identity. This tells us that we need to install service identity, which you can do by saying pip install service _ identity. You'll see it will work for a little bit, and then it will install that for us. And then we should have everything that we need installed for Droser. So now that everything's installed for Droser, we can try running this again, and we should just see an issue saying there's no device to connect to. And that will allow us to move on to our next step, which is just to set up our device with Droser. Yeah, so this looks perfect. This is exactly what we want to see. When this happens, we just want to be able to install Droser on our device. So I'm going to go into Google Chrome here, and I'll just accept through these and get us through to the default page. And we'll just go ahead and type in Droser. So once you've typed that in, you should see there's the GitHub page here, and then there's the fsecure labs page. We'll go to the fsecure labs. And I'm just going to scroll all the way to the bottom here, and we should see the different installers. So as you can see, there's like the RPM, the Ubuntu archive, there's the MSI that I was using to install it, and then there's the APK. So go ahead and click on the APK. It will ask us if we want to give permission to download and install files, which we'll allow. We will download it to the downloads folder, so this is okay. And then I can click OK here to try to open it. Right? And then it's going to ask me if I want to allow for unknown apps to be installed. We'll go into the settings and we'll go ahead and toggle this to allow apps from this source. Once this is done, I can press on the back arrow and I'll be able to install the Droser agent. So I click on install, I'll run through the installer, and then I'll be able to open up the application. So now Droser is installed on this device. So with this, we can turn on the embedded server, and this is what allows us to be able to connect between the computer and Droser. It's running on port 31415. You can see that on the bottom here. So what we need to do is we need to forward a TCP connection between our computer and the device on port 31415. So to do this, we just go adb forward TCP:31415, and we do the same thing again. Running this command will create that tunnel between the two devices. Once this is done, you'll get a 31415 in response to verify that everything worked. And now once we do this, we can type in droser.bat console connect. And what you'll see is it will actually connect to our device and be working as we want it to. It may take a few minutes depending on how fast your internet connection is, and you should see something that looks like this. And if you want to test that it's working, you can run a few different commands. So we can say run app.package.list. What this will do is it will list all of the applications that are on the device. So if this command works for you, then you now have Droser set up and installed correctly. And now in the next few videos, we'll take a look at some of the things that we can do with Droser to be able to analyze applications and determine if they're vulnerable or not using the tools that are available to us in here. One of the first things that we would typically do with Droser is utilize it to find an attack surface of the application we're looking to attack. So the very first thing that you can do here is you can run app.package.list. What this will do is it will list off, like I said, all of the applications that are currently installed on the device. And as you recall, we were using the Diva app, which has this package name associated with it. This package name is what we're going to be using in Droser to tell it what application to actually be scanning. So there are a few different information gathering type of commands that we can run through Droser to be able to get a general information about the application that we're looking to attack. So the first is going to be run app.package.info, and then we provide it -a for an argument, and we give it the name of the application we wish to scan. What this is going to do is it's going to give you a general high-level overview of details about the application. What that means is it's going to tell you where the data directory is, for instance, where the APK path is, what UID is used with it, what version the application is, the name of it, the process name, anything that's really relevant or interesting, what permissions it uses, for instance, as well. So this gives us sort of like a high-level understanding of information about the application. And something else that can give us something similar would be app.package.manifest. This one, you don't have to provide an argument. You just put in the name of the application. You don't have to put the -a. And this will give you the whole manifest file of the application itself. So if you remember, when we decompiled the application, we could reach this through this manifest inside of the resources. So this is the same information as what we're getting here. The reason why we want to see this is because it can show us information about again, what kind of permissions are being used, what versions of the SDK it's targeting. And in general, it can tell us a lot of very good pieces of information, such as intents that may exist, activities that may exist, providers that may exist. So we get a whole bunch of information about the providers and activities and such. So if we want to take this a little bit further, we can look at the actual attack surface to get a more generalized format of the more of a summary, I guess. It's like a summary of the manifest file to tell us all the information about the things that we could possibly attack in the application. So I'm going to run, app.package.attack surface, and then we'll put in the name of the application. What this will do is it will scan the application to tell you information about the attack surface. So it tells us about activities, broadcast receivers, content providers, and services. And it also tells us if the application is debuggable or not. So each of these are things that we might be able to attack. This one's got activities and content providers. These are able to be used for activities typically could show us potential access control violations, whereas content providers could potentially show us some instances where queries might be able to be used to do SQL injection and that sort of thing. So this helps to expose the general attack surface of our application and helps us gather a bit more information about the application itself. And then from here, we can take a look at some of the different types of attacks that we can do inside of Drowser. So one common type of vulnerability that we can look at is improper activity exporting. When we export activities, essentially, let's just start from what exactly is an activity. That's probably the best place to start here. An activity is going to be any of the user interfaces that you see inside of the application. So for instance, when I launch up the Diva app, this main page that we see here is an activity. When we're looking at access control, it means that certain activities shouldn't be accessible from specific locations. So for instance, if I go into the access control issues, you'll see that there's a page here that allows us to view API credentials. And essentially, something like this should only be viewable from like a privileged page, right? So for example, if we were to log onto this and be able to access this page, that would be okay. However, in some cases, these pages are exposed without proper permissions, which could potentially allow someone to be able to launch them if they're exported. So I'll go ahead and I'll walk through what this looks like through Drowser, and then I'll discuss a little bit about how you can find these vulnerabilities without Drowser, just to give you a bit more of an idea behind what they look like, because Drowser won't always pick up everything, and you may be able to access some of these activities with some different permissions that maybe Drowser can't access. So we'll take a look at both of those. If I wanted to determine which activities are exported, I can run the following command here. We could do run app.activity.info. Say -a and then jakar.seam.diva. And what you'll see is it will show each of the activities that exist. So there's the main activity, the API credentials activity, and the API creds2 activity. And you'll see that both of these have null permissions. That means that there's no permissions that are required to access them. So what this means is that I can go ahead and close off this application just to demonstrate this to you. And when I do this, what I can do is I can run the following command. So I can say run app.activity.start. And then we're going to target a specific component. So the component is the application that we want to target. So that's the application name. And then we say which of the actual activities we want to target. So for instance, I could target the main activity just by typing in main activity. And oh, I lost connection here. I think that's because I closed off the Drowser app. So let me just relaunch that here. So we're just going to go ahead and reset up our ADB, Drowser.bat, console connect. Okay, so back where we were before, we can run the activity start. So we could say run app.activity.start. And again, we could target a specific component. So we could do something like this. We could say jakar.seam.diva. So that's the application that we want to target. And then we want to target a specific activity. So we could do this here. So .diva.main activity. You see when we do this, it launches the main activity on my screen here. So you can see how even without having the application active, we'll be able to launch that activity because there's no permissions associated with it. And then what we can do is we can launch that API creds activity. So we could say API creds activity. And it looks like, oh, API is all capitals. So it's case sensitive, just keep that in mind. And as you can see, I can launch the API activity with all of the credentials inside of it. So this is a great example of improper access control, because this general activity here should have some sort of access control. It should have some form of permissions associated with it. However, since it doesn't have any permissions associated with it, we're able to launch it through Drowser just by using this command. You can also launch it through ADB using similar commands, but Drowser is just like a nice little all-in-one place to do it. So To give you an idea of where you can potentially find these vulnerabilities in general, when you're looking at the Android manifest, what you're looking at are these activity blocks here. So you can see these ones are mostly relating to like strings that are used inside of them. So a lot of the time strings are something that's coded into the manifest files. But a lot of the times we can actually find the actual activity definitions as well. If we just look for them inside of here. So these are all of the labels. These are all of the labels. Yeah, so you'll see here, for instance, like we have the action.main. This one is actually an intent for it. Here are all of the activities here. So you can see the activities here, and you can see the activities inside of here as well. So you can see with API credentials, for instance, we have the API credentials activity. We have an intent to be able to view those credentials, but we don't have any permissions actually associated with it. So whenever you see these activities, these could be potential things that we might be able to try to launch inside of the application, right? So this is the general way that that Droser would be able to find this information is through the manifest. So you can see, like, you can find each of the activities inside of here, and it'll have names inside of them that will be able to tell you like the general information about them, right? So this is the general way that Droser is able to pick up on those. So running Droser will allow you to be able to find these activities, and really you should try launching every activity that exists that's exported just to see if one of them might have something that it shouldn't be exposing to users, because if it does, that means that it violates access control, which in turn means that you shouldn't be able to actually access that without permissions. So that would be a typical type of vulnerability, and it would be a fairly critical one to find. So this is one common type of vulnerability that exists inside of Android. So the next type of vulnerability that Droser is really good at being able to detect are content provider-based vulnerabilities. Content providers are essentially a way of being able to access data from an application from somewhere external to that application. So if like app number 1 wants to access data from app number 2, it will typically use a content provider to be able to access that data. Now, some content providers are hidden behind permissions. Some of them are not hidden behind permissions. If they're not hidden behind permissions, they're accessible from anywhere, which means that we could potentially do something with that to expose data. Now, with that in mind, we have to consider some of the information here regarding the content providers. In general, being able to query a content provider isn't necessarily an issue. However, if you're able to do SQL injection to a content provider, that can be a big issue. So we'll take a look at what that can typically look like inside of here. So if you want to expose content providers that exist on an application, we can do that through Droser, and we can do that through the following commands here. So if I run scanner.provider.find URIs, then I go -a and I give it the name of the application. What this will do is it will expose to me all of the URIs that exist. The URIs are the content providers that we may be able to query. So you can see that there's 2 of them here that we're actually able to query. And I just sort of want to give you a bit of an idea about what this looks like from sort of like a typical legitimate perspective. So if I create a shell into my device here, I can do something like this. I could say content query. I think you do -URI, and then you put in like the URI that you want to query. And what happens is this will essentially run through a specific type of query, and you can typically provide them with some arguments. And those arguments can be interpreted and potentially exploited. So I think I might have to put 2 hyphens into it. Yeah, I have to put 2 hyphens into the URI. So there should be 2 hyphens here. So this is what the actual command would look like. So you see when I run this, it actually gives me data that's inside of the database. And what I can do with this is I can like provide a specific projection, right? A projection is the fields that I actually want to see. So for instance, if I want to see just the title, I could say projection title, which will show me just the title. So if you take a look at the actual code here, it can help you understand a little bit more. When we use the query portion, what it will do is it will utilize this query function inside of the provider, and all content providers are going to look very similar. So what you'll see here is that when it actually runs the query, it runs it through a query builder, and it provides it with a projection. Now, a query builder is generally relatively secure. However, projections have to be set in a very specific way. What we should be doing with a projection is telling the query builder what columns are actually valid to be able to be inputted. If we don't do this, then you can input theoretically anything into that projection, and it will actually get executed as SQL code. So to demonstrate this sort of idea, let me show you what this looks like from my ADB shell. So I have the projection for title. Instead, I could replace this with something different. I could do something like star from SQLite _ master. And then I can put like the comment to comment out the rest of it. What this does is, so when we do the projection, it injects the data between select and from. So what I'm doing is the select is already there. So then I just put star from SQLite master, and then I comment out the rest. So that just shortens the query to select everything from the master table. The master table holds all of the information about what exists inside of this database. So what you can see here is you can see all of the table information. This tells me that SQL injection is possible. So this allows me to be able to see that sort of information. Now, of course, we don't always want to be doing this manually because it takes a lot of time to test a lot of content providers. So luckily, Droser actually has some built-in ability to be able to do that. So the way that you can test this is you can do something like this. You can say run scanner.providers. Or I think it's just .provider.injection. And then -a, and then we put in the name of the application again. And what this will do is it will attempt injections on each of the providers, and it will tell you if you can inject through the projection or if you can inject through the selection, which you can do in both of these cases. So when we talk about the selection is actually the where clause. So we can give it a where clause, we can give it a projection as well, and both of those seem to have injection enabled on them. So now, in general, once we have this information, we're able to run a query like I just did here to get all the information from SQL Master. And then utilizing that, we can get other pieces of information. If there's more data inside of this database that we shouldn't have access to, we'll be able to get to that utilizing this. So that's sort of the general idea and gist of what we're going to be doing with this. And just to show, like, you can get the same sort of information inside of Droser, and you can get that through running scanner.provider.SQL tables. And what this will do is it will essentially just give you all of the tables that exist if a content provider is vulnerable. So as you can see, it tells me that these are the tables that are accessible through this injection, right? So when I'm doing this, like, for instance, if you want to see what an injection could look like, I could replace this with star from, like, for instance, Android metadata. And that could expose the metadata to us. I could do this from notes, which is the other table that exists. And that's the sort of stuff that we got from the content provider, so that's not overly interesting. But, I mean, you can get a lot of other things, such as, like, the SQLite version. I think you could do that just generally through something like this, for instance. And that would be a good example of the sort of things that you could do with this sort of vulnerability. So this gives you a good idea of how content providers can be exploited and how to find those vulnerabilities through Droser.